and you're ready to start the next edition of Kamailio World. Probably not all of them arrived, just to be aware that we are kind of fully booked, so it's gonna be a bit crowded at some point once everyone arrives. Wi-Fi, it's from the hotel. You don't. It's free for everyone. You have like connect for 24 hours. So just in case you're looking for the details. Is the sound okay? Can you hear in the back? Okay, good. Then I'm gonna start in half a minute or so because it's kind of a packed day with many sessions. Okay, so looks like most of the people came in. I hope you had some coffee to refresh yourself and be ready to start. First, thank you everyone for joining us to another Kamailio World conference. It's the 14th, this one. And besides that, it's kind of special, celebrating like a quarter of century since the project started as writing C code. There will be a session about the evolution of SER-Kamailio project with some of the people involved in the early years of the project. And then a lot of the actual developers are in the room. Tomorrow morning we have this short session about like ask me anything, where you can ask about the direction of the project, or if you have some other technical specific question, we'll try to address them. First, I'll really like to thank to our sponsors. It made it possible again, and besides that, we had quite a lot of submission this year, and we couldn't accommodate. We squeezed some shorter session, and yeah, thank you for those that accepted the short sessions this year. We had to reject also quite some proposals, interesting proposals. And we decided to accept, and at the end we accepted, not accepted, but we gave like a free conference pass for 4 other people that made proposals, thanks to the sponsor that allow us that flexibility. So maybe some of them you'll see in these 5 minutes, 5 slides. I asked them, we don't have this one, maybe you want to do that if you like. But yeah, so we had 4 rejected proposals, giving a free pass for them, and then a few other, let's say, invited people from the ecosystem that, for example, the person that helps us with Kamailio World server, hosting it and so on, we were able to accommodate, besides the usual speakers and guests from the sponsors. So thank you once again, because allow us to bring more from the community, those that try to help us. Yeah, Andreas front is helping us with pretty much every edition, maybe a new company for those that know him from like before pandemic. So Cfront, there are a few guys here available to show demos. He'll follow up after me, so I don't focus much on him. But then we have Henning and Gilawa supporting us this year, and they are also a large team here, a few people, comparing like 4 or so, 5 with Henning. Then Diabolocom, last minute, the guys should be here, I guess. Thank you guys again. You should decide a bit faster because we couldn't get you on the roll-ups. But yeah, that helped anyhow to make it possible. Simon is not here, but it's one of those companies that support it at every edition, and this year they increased the level. Thank you. Charles should be here, maybe not yet in the room. I have seen him last evening, but also David Duffett, if not, it's here. He was promoting us, and yeah, thank you, Simon, for all the years, but especially this year where yeah, the level of sponsorship was increased. And probably the company that helped us not only with Kamailio World, but I think pretty much every event that we did, like 10 years SER, but then Kamailio development meetings, Sipgate, Marcus, Andreas should be here, the team from them. They are coordinating the 2 sessions with multiple participants, the 5 slides in 5 minutes about your deployment or your project, and then the Kamailio config challenge. So Marcus and Andreas, again, Marcus, your hand up so people can see you. If you want to participate to these 2 sessions, get in contact with them. If you forgot their faces, come to me and I will set you in contact. You can look on the website in the schedule, the last one today. So if you want, there is a form if you want to submit, but the best now is to get in contact with the guys here. And tomorrow, just before the lunch. And then we'll have, since we are there, another interactive session. I'll have the slides about. But James Buddy with dangerous demos. James was here. It's here. He will find you if you don't find him. So Sipgate, really, many thanks for like very, very long support in all the events we had around project. Then Alexander and Homer team, they gave the red T-shirts. Maybe they're outside still dispatching them. They help also our event at this edition. The bigger things I could have in terms of infrastructure, the PASCOM guys, so recording, audio, it's running smooth for all the past editions. Video streaming in Kamailio World. If you have, I don't know, colleagues or friends that want to watch Kamailio World YouTube channel, probably it's already live there. They have put a lot of effort last evening also to set up everything, and we are really grateful for their support. So Sebastian will speak later, will arrive, but then 3 guys are already here. Thank you, Jan, then Quirin, and Thomas for all your efforts. Snom should come again to give some devices as giveaways. We have other giveaways as well for the code challenge and so on. But yeah, they usually come and bring some phones or some speakers, SIP phones and so on. I haven't spotted them, might be a bit late. They are in Berlin, so everyone local is typically late. Not me, I slept in the hotel. Then, yeah, we have the friends from LOD and Fred Posner. They offer us many servers that we use for our infrastructure, for building, hosting Debians, and so on. They support the event quite a lot. And then the partners projects or events like Lucon APIBan. And I'm from Asipto, the main organizer of this event. So thank you all the companies once again for all your effort, not always financial, but also a lot of time and other resources allocated to make this possible. So yeah, we have 25 years. It's still a few months before, but it's the year. So we try to mark that as a kind of celebration event. We will continue beyond 25 years. Of course, the community looks quite strong, and there is an increase on activity actually in the last couple of months. I have some statistics probably I'll present on this evolution session. Let me see, but yeah, in average we had like over 1,500 commits per year, the average, some years more and others less. And I think there are over 500 overall contributors. Okay, there are 25 years. The last year, over 70. So it looks really good from my opinion. Of course, it's kind of established market, maybe not so much enthusiasm on, on the web like it was years before, a lot of tweeting on LinkedIn on new products and so on. Of course, it's now a lot of AI, and somehow it's reflected also in our agenda here with some presentation. But I'm really happy with the evolution so far in terms of development. It's a community, so there is not a big company controlling the project, but hopefully we manage to get along as much as possible in terms of having Kamailio as a common goal, to have it stable, scalable, and not try to direct it to various purposes. The schedule as a structure, so you will have coffee breaks and should be some bits to eat at that coffee breaks. Also in the afternoon will be a second one. Lunch would be in the restaurant area, so everything is included. And then in the evening, we'll have the social event. Also the restaurant area should be like a buffet, proper dinner actually. And during the day, you have the drinks in the back. I would suggest not to bring too much on the table, especially because there are a lot of people, and not to by mistake or, not intentional, but could happen that you pour on some colleagues. So try not to bring too much, and when you finish, put it back, or better go outside and enjoy during the breaks. Tomorrow will be similar structure for the day with 2 coffee breaks and the lunch in the middle. The interactive session, I already somehow mentioned them, will be this panel about the evolution of the project. Then we have from the Cipgate team the 2 session, one at the end of the day today and tomorrow before the lunch. And then we have dangerous demos today before the last coffee break. And in the morning will be this with kind of open discussion with the Kamailio developers. For those that you could submit the config challenge and the 5 minutes, 5 slides, there is some form, I said, but better at this stage you could just go to Marcus and Andreas from the Cipgate team. Social networking, yeah, we still have accounts, not much activity on Twitter or X right now. I don't know. It seems like it's no longer a favorite channel. LinkedIn, we posted a bit more on it. There is a Kamailio group. I posted in my name. We don't have a group, like an account for the project itself. So it was more like a personal post there. The YouTube channel, as I mentioned, again, thanks to the PASCON team, will be also recording, available after the event available. So if you want to spend some time on chatting with new people here, you can go outside, skip a session, because later you can record it. Of course, we want you here to post questions and so on. I just wanted to highlight a bit that is not really critical if you missed something, because you could look at it later. And it's mainly for me, I would say, because I'm not able to watch most of the session as I have to go out for, let's say, administrative reasons. So having the recording, it's very useful. As every year, we mention that thing with the VAT, that's the rule in the European Union. We have to charge the VAT at the place of the physical events. If your company is located in European Union, should be easy to claim it, but could be case by case. I don't know all the countries. In some countries easier, others not. Germany, it's straightforward. It's the same country. But yeah, 90% is not something that we keep. We give it to the tax authorities. So in the price of the ticket, we have to put this. We are forced by law. From the rest, we have to cover the conference expenses. So that's how the law works. And of course, it's kind of regarding event, but try not to leave your personal belongings, especially like passport IDs or portemonnaies or so. When you go out, there are some other people coming in and on. We don't have like security around. It should be safe, but we don't take any liability. So please take care, especially passports, portemonnaies, and so on. Laptops, phones, whatever you have, very important. So that would be the introduction. We'll go now quickly over what happened during the last year, more or less like a summary. Some of the presentation, including mine, the last one, will focus on some of the features we added. Kind of continues the last one because yeah, we went a bit more into multi-threading, and I wanted to have everyone clear what that means in the way that it's not actually breaking. We try to have like an evolution, not a revolution that will change your deployment drastically from a release to another, even if it's a major release. But that will be later tomorrow when I'll have the session. So yeah, we are in the 25th year of development. We had the last release earlier this year is the 6.1 series. That means the 6.0 is the second last, and the two maintained will be 6.1 and 6.0. 5.8, it's already out of maintenance. It was the last release, I don't know, 1 month ago or so. We don't plan any more releases. Even it was a switch from 5.8 to 6.0. It's still pretty much backward compatible. You should have no issues to backport. So yeah, we'll get back maybe to the history and all this later with the session about the evolution of the project. So what's new on this 6.1, the last release series? We'll have Jonathan there in the back if you need to ask more about the first two modules. I also want to ask, but I'm not sure I have time now to understand where. Then we have two other modules, peer state and the p-timer. P-timer, I think it's from Mac's colleague. I don't see Mac yet here. He's a speaker also tomorrow. And the peer state, it's kind of ability to publish kind of aggregated information like registration state, call state, kind of module, not only presence. Then other features, quite a lot of work on TLS lately. Luckily, not only by me, we have a very good contributor developers in Singapore. It was here 2 years ago, Shipping Chan. I'm really grateful for him. He takes the heavy lifting of these changes in the libSSL that were quite a nightmare to adapt from like a multi-process to a multi-threading. They did those changes and we had to, so like for more than 5 years, we were trying to adapt because they are not that transparent. They change internal APIs and so on. But hopefully we got to a stable state. And now even more in the upcoming 6.2, we have like even more, let's say, pure TLS, multi-threading approach for the TLS. TLS Wolf SSL actually has multi-threading option only. I'll have slides about it. But then, yeah, we have a lot of contributions and commits and new features or enhancements to existing features, new dispatching algorithms, new variables and transformations. Then this CMake is kind of fully integrated, including the packaging, and probably will remove the make files. What is keeping back, it's actually me still having some scripts on server side, relying on the old make files for kind of continuous integration and testing. But Debians and RPMs and build can be done with CMake, thanks again to Xenophon and there, Gilawa, that put a lot of effort on it. Also, Alexander helped at some point, Dubovicov, with this CMake. Then good support for, or some work on this atomic operation for ARM systems. Viktor there, the other Viktor, made the main contributors using the city standard atomic operations, and yeah, you should not see like using a lot of CPU, especially on idle state because of the busy looping locks we had. So ability to use like p-threads and standard atomic operation on these, let's say, smaller or energy efficient CPUs has been a work on it. Enhancement also to RTP engine distribution of this internal hash table, what call it's using which RTP engine. So you have the link. I just selected a few of them to give an example, but I don't want to focus more on the web, or during the breaks we can discuss more. Not necessarily with me. As I said, there are a lot of developers in the room. Likely you'll just bump into it. Since it was last year, a summary of what happened last year with 6.0 release, so also a couple of new modules, and the link for that release, it's at the bottom. Then what enhancements were done last year to the existing modules, again in the series of 6.0, trying to cover last year and this year. And since we released the 6.1 in February was, actually, as I said, I saw quite a lot of increase in development. Might be just the chance. We have Wolfgang contributed, will be a speaker, so it's here, the JWT3, because the libJWT3 changed the API, so it was easier to make a new module than make the old one working with two versions of the libraries. CP integration for some testing, and then a module to facilitate the configuration management for TLS. So these are in the development. I haven't played that much with them. Then, yeah, we have other features like WebSocket client role with support from Cfront again. Allows Kamailio to initiate WebSocket connection. It's work in progress, can connect, can send, but is not yet transparent integrated with like T-Relay or so. I'm working on that, I have to do it after this event. So the past few weeks I work on it, but I didn't finish. Richard from RTP Engine added support for UDP proxy protocol. We had HA proxy if you want to put it behind some cloud servers. Again, these are fresh new. Take it easy if you want to test it, be aware it's there. Probably the 6.2 release will be earliest late this year or beginning of next year. Usually now we wait for our Kamailio developer meeting to happen, which usually is like November. This last year was early December, to meet like 10 people usually, 10, 15 meet in Düsseldorf, hosted again by SIP for like 2 days, and after that we do it. So it's like 2 or 3 months since the release, but we have already like 400 commits, a lot of activity there. We focused a little bit on security by will, or by others forcing us by reporting quite a lot of potential issues, some of them quite important, and we made 2 CVs so far. A few of them are in preparation. I can say one is highly critical if you haven't upgraded to the latest version, so it's in the stable version, the latest minor version, you should do it. Thing is that it's about code that is more than 10 years or sometimes 15 years old, but hidden. Now, whatever AI tools or security researchers use, they report it, they found it, and so on. Sandro here, it's one of them. He put some work on us 2 days before the event, just to be sure in the breaks we don't stay.
It's fine.
But yeah, so we take that serious, but takes also time. Again, it's community in this security team right now. We are like 4 people or 5 because we need to assert if it's something really critical, not put it on the public directly. But yeah, we probably have to increase a bit to add other people there to help with. As I said, there are a couple of them very good, but some of them are more like just casual bugs. We look at them and we'll fix it, but yeah, we discuss with the reporter whether it's really security or not. This is case by case. We created a repository so people doing security analysis, they can get listed for the credits on a GitHub page, let's say, because we want to acknowledge this work. And could be also documentation, so it doesn't have to be only security. Anyone can get listed there if he wants like a reference. So we'll have to approve the pull request if we consider the work worth for listing the credits. So yeah, you are encouraged to contribute not only the code, documentation or something else, and you will be credited with that. To kind of wrap up, not to start with the first session in a delayed, I'm just going quickly over SIPgate. We will have probably again this year, if the situation worldwide is fine, developer event. Last year I said it was early December. Last year also we created an open collective that helps especially Viktor, because Debian, Viktor Seva this time here, covering his expenses. We need to find a way to cover also his time, but we have a collective that at least now pays for the infrastructure. It's a little bit harder, as we discovered, with paying for like consultancy from this amount. I don't know, Viktor might say something later more. But yeah, if we have like infrastructure cost and so on, it's easier. Then yeah, some more Consiremis web interface. This is like a management interface for Kamailio database. I didn't have much time last year. I resumed it a little bit before the conference. Let's see next year. It's working. It's just not yet like battle tested, so look at it. Also the CLI tool got some enhancements. Again, just as a summary. And then for those looking at Steer Shaken, this project I'm having with the company, it offers the library that powers Kamailio module, but also has tools so you can do testing for Steer Shaken independent of Kamailio, generate certificates, and so on. Some resources that we have, again, it's a slide I have every year. We have a very friendly community. Consider joining it. For questions, Fred is running also some chat. I'm not always active. From time to time I'm there. I'm still with the mailing list most of the case. GitHub for reporting issues. We don't use GitHub for like support general questions because we want to have it clear only for bugs and also tracking requests for new features, like if someone wants to implement it. So this would be where I'm finishing, maybe just in time for Andreas to start. I just want to add to show, yeah, if you do like git log reverse, minus reverse, you'll see actually where it was the first commit. So probably it was one of the fastest releases in the history, from like less than 24 hours from the first commit to the first working release. And since that we do it, Andre should be here, lives in Berlin, so it's late, but will be here later for sure for this session. So I still have some slides and some photos, but probably I will put it during the, that session at the beginning. Any questions you have, we have two ladies at the registration desk. Ramona should be here also in minutes. For technical issues, audio, video, you'll notice where the PASCOM guys are located. I should be around for any question you might have in the, or during the event. So thank you everyone again for coming, and hopefully you'll have a very good event. Weather was not the best yesterday, maybe today also a bit cloudy, but you have to be here anyhow. Drinks in the evening again will be beer and wine, during the day non-alcoholic, and that will be. Thank you everyone for coming.
Good morning, everybody. Welcome to Kamailio World. It's kind of early in the morning. We are all still fresh. So let's dive right into the next hot shit, as they call it, which is voice AI. And I'm going to do a presentation today about SIP AI and the 9 dimensions of voice bot performance. And we're going to try building a voice bot from scratch along the way and see how it goes. That's me, Andreas. I had the pleasure to participate quite a couple of times here already, and it's always great to see you guys. Today, though, is a special day or a special year, let's put it that way, because Daniel-Constantin Mierla is celebrating his 9,000-day streak of coding Kamailio, so let's give some applause to him. We wouldn't be here without you. Quite some time, right? 25 years. I looked it up. I think the Apache project that everybody knows is only like 5 or 6 years older, so that's quite a thing. And yeah, a lot of things have changed. I know 20 years ago, back then UPC Romania, now it's Vodafone, was crazy enough to commission a project to 3 crazy guys, me and 2 of my colleagues, who just started Zipwise back then, to rip out a bunch of Cisco BGW and Cisco BTS in Bucharest and replace it with an open SER deployment for 500,000 residential lines, which back then was actually quite a thing. And the interesting thing that you might not know is that was also the point where RTP engines started. Why? Because fax was not working properly with RTP proxy back then. So the next time you blame fax again, keep in mind, without that, your beloved RTP engine wouldn't exist. So who knew? Things were a little bit easier back then, though, as we always say, right? Because when we look at the basic zip call, it was usually all about the invite, getting 180 back, a 200, an ACK, hopefully without a 200 ACK ping pong. And in the end, we had RTP flowing, and that was essentially it. Like, that was the goal. And I mean, it sounds a little bit easy. It's not, as you know. And it has changed a lot with all the different kind of course scenarios that we now have. Couple of things stayed the same, though. One of them is test books from hell. So you have your CP scenarios, and you have one person in a company who knows how they work. Raise your hands if you are the guys responsible for that. Who is it? You. Couple of them, not so many. So I have an alternative to that, which is what we also used like 20 years ago with our first deployments, which was this. Who knows this one? Are you not testing? Hell, how do you make sure your things work? I mean, our industry was always slow to adopt, we know that, right? So we have never been the quickest in telco to introduce new things like testing, continuous integration, continuous deployment, still kind of a new thing. We are trying to solve that with ZipFront, by the way. However, that changed when the FOMO hit in. And the FOMO hit in like last year, when everybody started to scream like, we need to offer voice bots. And I don't want to be sarcastic there, because actually it's a really good thing for our industry, because suddenly telephony become really interesting again. So there's lots of innovation going on, lots of new people, young people starting to work with telephony again, because other than that, when I look at like the meetings I'm attending, it's all the gray, white man. I'm still turning gray as well slowly, so it's a good thing to really get something going. However, and that's the interesting part that I recognize in this industry now, is that people who a couple of years ago just said, well, let's keep our ISDN lines going for another couple of years, because who knows what's going to happen, who knows if we're going to need them still, are now telling me, like, we need to deploy voice bots, and we don't care if they work properly or not. And that's quite an interesting shift in the industry, particularly in the telco industry. I've never seen that before, to be honest. The challenge there, though, is there can be a lot going wrong with voice bots, because it's not just about the beep anymore. It's not about getting the RTP flowing from A to B, and hopefully also from B to A again. The problem, or the challenge, is that we are moving from a goal to a foundation. So when we were asking, like, is audio flowing like 20 years ago, even like 5 years ago, now we are actually asking ourselves, what did the audio that was flowing or is flowing actually mean? And in order to shed some lights into the challenges of, that are involved with this, is we're going to build a voice bot from scratch to really look at the different kind of angles. And we as telco engineers know about, and some things that we might not know about. So we're going to look at the 9 dimensions of voice AI. And the thing that was the goal like 20 years ago, like SIP performance, RTP performance, and audio quality, is just becoming the foundation. So it's about, you know, all the metrics that you know, post-dial delay, answer seizure ratio, but jitter loss and round trip times, audio quality, the MOS scores, all the things that we are or were obsessive about. That became the foundation, and it's actually being taken granted that you have that under control if you start building voice AI on top. Because what we then need is another layer on top, which I call an intelligence layer, And there it's about audio performance, audio stability, and audio correctness. So it's about the content suddenly. It's not about just having the audio flowing, but it's about what is in the audio. And there we are talking about time to first audio, turn latencies, language lockings, impairments, and what if I stutter in my call, is it still gonna work? And also about like word error rates, hallucinations, and everything that you know about when you have ever checked or talked to ChatGPT. And on the very top, and that's more like a management thing, let's put it that way, and it sometimes gets forgotten, is content security. It's about injection, jailbreaking, we've heard about those things, and we will look at that in detail. About cost protection, because you don't want your CFO to come on a Monday morning to you and ask you about this $50,000 bill from OpenAI that you just kind of accumulated. And it's about regulatory compliance. You know, EU AI Act is in full swing, latest by August. I don't know if you know. And that has some relevance for your voice bots as well. So when we are going to build a voice bot, you are asking like, okay, how hard could it be? So you need a SIP application server somewhere in the middle. You need SIP peerings to get your cores to that. And obviously you need some kind of voice AI in order to do the talking, right? Now, when we look at the first dimension, SIP performance, it's obviously about just what we always have done over the last 25 years with SER, Open SER-Kamailio. It's about how do you get your cores connected via SIP, right? So is it going to be UDP? Is it going to be TCP? Is it going to be TLS? Talking about like business communication, UDP is not that much in favor in that industry anymore. It's about like scaling. So what happens if I'm gonna start to do just 10 cores or 100 cores or 1,000 or 100,000 cores? Is it still gonna work? Is your server still gonna answer? Is it still gonna be like within a time where your calling parties, your customers are good with waiting until your bot starts answering? And it's also about like failover, answer seizure ratio. What happens if your SIP server dies? We all have experienced that. And obviously, this is something that we all have seen, like you have all done that in the past, your beloved combo of Kamailio and RTP engine doing load balancing across your application servers. Everybody who has ever done like a PBX, a cloud PBX deployment or something has done that, right? So you have your asterisk, you have your free switches and whatnot. You can even scale within your application server saying I can do 10 or 100 or maybe 1,000 cores with one, but at some point, and especially when you do high availability, you need to scale one way or the other. And usually what we see is this kind of combination in front of our servers. So we all know that. Nothing surprising there. Now, dimension number 2, RTP performance. So what about the media packets? And this is where it gets interesting. And I need to scratch my head sometimes on purpose. We are having spent like 20 years to optimize the path from our SIP peerings or our customers to our SIP cores. You know, we have introduced G722, Opus, all the relevant mechanisms to do forward error corrections, to do redundancy and whatnot, to overcome packet loss and all these kind of impairments that we have on the internet. And now, OpenAI and Google Gemini are asking us to send the audio via WebSocket in PCM, base 64 coded over a TCP connection in 200 millisecond chunks. Maybe we have learned over the last years that that is not the best way of doing things. However, there are alternatives to that on some platform providers like OpenAI. Not so much on Google Gemini. Some are even, I think, 11 Labs providing even a native SIP interface, which is great. That simplifies a lot of that. But I'm just saying the standard way documented is do it like this. And I'm like, I don't know if that's a good thing. There is the alternative, especially for OpenAI. They do provide a REST interface to do STP offer answer, right? And they provide a WebRTC API. Now, that's great if you want to connect your browser directly to OpenAI. So you just do plain WebRTC from your browser endpoints for your customers' doing the voice AI. It's not so easy though when you want to apply this to telephony, because suddenly you're talking WebRTC, which is a challenge in itself, right? If you're presenting the WebSocket part with the PCM and so on to a, let's say, normal developer not having much experience with telephony, they might be fine with that. If they see a WebRTC SDP for the first time, they might gonna be surprised. And the other thing is that you also, apart from a normal WebRTC audio, you need data channels for the event handling, because with WebSockets, you just have like messages that you send over the WebSocket channel to your voice AI provider, which is totally fine. Have you ever, whoever has worked with data channels in WebRTC? Very few people, even in our industry, I'm sorry. So, not an easy feat. Now, talking about the audio quality, that's another thing when we think about, okay, so we have set up all the SIP signaling, we got the RTP going one way or the other. Now we need some elements to actually produce the audio, right? So it's not pre-recorded waves anymore, it's not an IVR menu, but a real AI thing doing the talking. So you have different kind of ways to do that, obviously, depending on the provider you choose. So you have your speech-to-text to LLM or some rule-based NLP ways, and then you have text-to-speech back to your customer again. More modern ways, more modern or a different way to do it is doing it via speech-to-speech LLMs. So there's no kind of hops in between anymore. Has some advantages, obviously, because each and every hop creates latency, right? And you also lose in the speech-to-text and LLM text-to-speech part some nuances, like you know, the mood of the calling party that the AI might be able to react to. So that is more like the more modern way to go. The problem is, though, when we talk about audio quality, in the past it was actually pretty simple to measure the MOS value, right? I mean, there's the R factor, obviously, to calculate it from RTP, your codec, and your jitter, and your RTT, and so on. But there are like full reference models that you usually use, like BESC, Polka, or Viscol, where you have an input file, you send it through your telephony infrastructure. At the other side, you just record it, you put it over each other, and then you measure, okay, what's the MOS value of that? And that's obviously not going to work anymore with voice AI, because you just don't have a reference. You talk to some element, and you get whatever response back. And you actually want to measure how well this whatever is going to be received on the other side. And there are new contenders, let's put it that way, new AI models on the market. It's even open source, which work without references. So referenceless matrix. Two of them are DistilMOS and XSLR-MOS, which come from Microsoft Research and from Meta. Both of them you can find on Hugging Face, and you can run them on your own infrastructure pretty easily. We're going to look at how to run your own AI models in a second. Now, once you want to get going, so we have the elements set up. We have the SIP application server. In our case, for my practical experience, I used the BSIP as a SIP client. We have Kamailio RTP engine for load balancing and so on. We have chosen like an AI provider. In that case, let's stick with OpenAI. What you need in order to get the course going is an initial session burn-in, right? So what you do is you send a request to OpenAI and say, hey, I want to use this model, GPT-4o real-time in that case. The session is going to be valid for a certain time. And then you have like your instructions, like you're a helpful assistant, which might not be super helpful in that case, but you get the idea, right? And then you need to provide the input and output format. So we are feeling lucky today, so we are really using the PCM-based base64 encoded way of sending it off to OpenAI, because our backbone is super stable. And then we define like turn detection things that you also know from your application servers, asterisk, free switch, and so on. And off you go. The thing there is, though, you don't only want a talking FAQ when you deploy a voice bot, right? It's funny, it's interesting for the first time to call your bot and start chatting with your bot. Hey, how are you? Can you provide me this or that information at some point? It's pretty generic. A real agentic voice bot, as you call it, is capable of doing things. And doing things means they can perform actions. Like in our case, the most basic action would probably be to hang up the call, right? So if they are like long enough in the call and figure, hey, we're not going anywhere, they can just hang up. They can also do API calls, for instance, right? So what you do is you send a WebSocket request saying, hey, I can do this kind of tool calling, so I can do an API call. What happens is the LLM at some point when you ask them, well, can you look up my status of the last order? The LLM per se can't do that, but they will send you a WebSocket event, right? Saying, hey, here's the API call, and these are, this is the body, this is the name, Mr. Granig with this customer ID. Send me back the ID of the last order. And that is a request that you get into your voice application that you then can handle one way or the other. Another important part there is transfers, talking about telephony, right? Transfers means, and we're talking about the EU AI Act then, the right for human handover, right? If you tell your bot that you would like to talk to a human person, the bot needs to allow that, right? Otherwise, you are in breach of the EU AI Act. So you might have a transfer tool call here as well. Now, taking that into account, talking about the audio performance, there are two parts there. The most obvious one is time to first audio that we always hear, like how long does it take when I set up the call for the first time to hear anything, like, hello, I'm Patty, your digital assistant, right? Usually you can work your way around that pretty easily, either via pre-recorded messages or something like that to allow your AI and your infrastructure to spin up in the back. Where it gets really interesting is like your turn-based responses. And usually when you talk to your AI and they can just, answer from their own memory and their own context, they are pretty fast usually. But what if you say, hey, I'm Mr. Granig, give me the status of the last order, and then your LLM needs to do the tool calling. And suddenly you have like another 100 or 200 or 300 or 500 milliseconds of delay that your LLM or your bot takes to do the API request, to get the response back, to parse it, to do whatever it needs to be done, and then send you in voice the answer. And that can take some time. So when we see on LinkedIn new performance metrics and benchmarks of certain voice AI providers, and they claim that they are going to be or going to do the 200 milliseconds responses, I have never seen that in practice, to be honest. Never. Usually we are more talking about 800 milliseconds to 1.5 seconds, somewhere in that range, taking all of these things into account. Because the other thing is context pollution. Obviously the LLM might be able to talk or answer quicker if I just yes or no, rather than starting to read a whole book to my agent. How long is that going to take for it to consume? So actually saying 200 milliseconds, my main question is also, okay, in which circumstances? What are the boundaries for that? Now, you can optimize that. So we've talked about measuring MOS, for instance, without references. We have talked about AI providers. For me, all this kind of AI stuff, let's put it that way, was kind of black magic for quite a while, until you really start looking a little bit into how does it actually work. And the thing is, it's not so hard to run AI on your own infrastructure, because you have your inference layer, and there are open source projects, frameworks out there that actually can run modules in kind of like a standardized way, like OLAMA or VLLM. And you can wrap your Python scripts, APIs, and whatever you need around that. And then they run your models. And by your models, I mean, for instance, like a Voxtrail, speech-to-text, text-to-speech, or even speech-to-speech model, right? They're open source. You can download them. They have like 20, 30, 40 gigabytes, so it's a bit of a challenge to handle them, so you can't just easily pack them into like a Docker container and just deploy it, right? Rather than you have to think, okay, how am I going to handle that? The other thing is, for instance, Gwen. It's a Chinese model, whatever you take from that, but where they are really good is, for instance, voice cloning. So we use that a lot in our tests in order to test for dialects and accents, for instance. And the interesting part is they all can then live on your same control plane next to your SIP infrastructure, right? There are some providers out there who actually do a lot of advertising and say, this is our main mode that we run both the SIP peerings and the SIP infrastructure and the AI models all in our data center, right? For a reason. So low latency is one of them. Cost effectiveness is the other one. You get a Hetzner server with a GPU for 200 euros per month, right? And they are tunable. If you have like certain geographic regions that are known to behave badly in terms of transcription, you can actually retrain them yourself. So there are usually instructions coming along with the models that you can use if you have like the data, and by that I mean like actual call recordings of problematic, let's say, accents. Now all of that is great for a demo. So we are up with the SIP infrastructure, we are up with the models, we are up with our SIP peerings and everything. Would it sustain in production? Who has actually ever created like a demo voice bot? Quite a few. Who has put it in production? Not so many anymore, but still some, right? And if you do that, there are still some things to consider, because we are just at dimension 5. Audio stability is one of the things that we as telco engineers are not considering usually out of the box. Why? Because, I mean, it's early in the morning still, and I'm doing a call with my bank, but Daniel-Constantin Mierla gets a little bit impatient and starts shouting something in Romanian in there, right? And suddenly the bot is switching to Romanian language. And we tried. You can prompt, or you can try to prompt your OpenAI to stick with English. You just have to try often enough, and at some point it will switch, right? So if you really want to avoid that, you probably even need some specialized modules for that, or models, AI models for that, because the generic ones are not so good with that. Audio correctness is the other thing. Usually when you have this chain of speech-to-text, LLM, text-to-speech, you can actually tap into the pipeline and say, okay, what is my speech-to-text word error rate really? When you want to test that, you just flood it with a lot of pre-known recordings, and you just double-check, okay, what actually comes out of the speech-to-text pipeline. When we look at that end-to-end, it's not so easy though, because we as SIPfront usually don't have access to like the inner workings of voice bots when we are testing enterprise voice bots, for instance. So we are rather approaching it from intent-based way, right? So I don't care too much about whether all and every single word is being understood, rather than I just want to know if the bot does and did the right thing. And did the right thing is actually pretty simple to test if, for instance, you combine it with tool calling, right? So hey, I'm going to ask something to the bot, and I know the bot is going to do a tool call, and I can intercept this tool call and just check is, for instance, the JSON request with all the fields and my name and my ID and whatever correct, and is the intention correct, right? So I don't care if it's a yes in that case, rather than I care about, okay, I want to buy something, or I want to reserve a seat, I want to book a calendar meeting, and the API request is the right one, right? The other thing there is turns to success. So how many back and forths do you actually need with your voice bot to get to your result? And there what we see is dialects and accents are quite a problematic thing. In English, in German as well, right? So if I'm talking, or if I have a voice bot and I have a person from Hamburg talking to the bot, it might behave quite differently than from Bavaria or from Saxony, for instance, right? And depending on the complexity of the task, the success rate is often really very different, right? And this is something that you need to test for if you know that your customers are talking Australian or Southern US or Indian English, right? Because there might be biases in your models that you are not aware of because of lack of training data or whatever, right? And that's a thing to consider. And you can't just technically, with telco know-how, address that. Now, where it gets interesting is content security. Like 4 or 5 months ago, there was a paper about using poetry to jailbreak your models. And by that, what they did is, sending in rhymes requests to certain bots, to certain models, trying to make the model do something else than it's supposed to do. And the success rates, actually the one-shot success rates, they are really huge, right? So I cut it even at the 65%. Down there's OpenAI still making the cut above 50%. So if I'm starting to get fancy and start to tell my voice bot rhymes and poetry, I can make the voice bot tell me things that probably it's not supposed to tell me, and I can make them things that the bot is not supposed to tell me and do. Just keep that in mind. You can try it in probably with ChatGPT. I think they fixed some things afterwards, obviously, but that was quite revealing. And the other one is cost protection. I already mentioned that, saying, okay, does your CFO come to you saying, well, what about this, for instance, $20,000 bill that we just accumulated? So you probably have heard about these LinkedIn stories, at least in my bubble, they are there where people were like, I did finally create my voice bot in like 10 minutes, right? Because it's not that hard anymore, right? I deployed it, I put a Twilio number in front of that, and then I had fun with it. And on Monday morning, I got quite some surprise. Why? Because OpenAI is charging you around 5 cents per minute, give or take, at a 1-to-1 talk ratio. And you actually only need 140 concurrent cores running for 48 hours to accumulate $20K. And it might be suspicious if it's just a test number of yours, but Kamailio, RTP engine, and even PairSip, asterisk free switch, Jambones, or whatever you're using, they don't even blink an eye on 140 concurrent cores. They just do it, right? So you still need to have some security measures in place that we, as telco guys, I assume, all know. Fraud has been a thing since day one in telco. Not so obvious for at least more naive, let's put it that way, developers coming from the AI side of things who have never worked with the peculiarities of telco. So time capping obviously is a thing. Turn capping, like how often can you go with your bot to say the same thing again and again and again until the bot actually says, we're not getting anywhere, I'm gonna hang up. The only problem there though is, if you hang up, like at a real call center with real human beings, and you get the same call again and again and again, some person might at some point raise the hand and say, look guys, I'm always getting this kind of phone call from this kind of number or different kind of numbers, can we please block that? Your AI won't do that, it would just happily answer the call again and again and again. So really take care of that. Oh, sorry. And the last one, regulatory compliance. As I said, EU AI Act is a thing. It's a thing since 24, 2 years already. In August, it's gonna be in full swing for everybody, except some very specific high-risk scenarios. And there are a couple of things that are obvious in this EU AI Act. One of them is transparency and disclosure, so your voice bot needs to tell the calling party that it's a voice bot, one way or the other. It needs to tell, hey, I'm Patty, your digital assistant. I'm Patty, your voice bot. I'm whatever, but it needs to be clear that it's a voice bot. That's one thing. But it's not even about just the EU AI Act, because in call centers, we always have had this thing, like I don't know for how many years, to have consent, right? Are you okay with the call being recorded? We all know that. Press 1 if you're okay, press 2 if not. Now, the question here is, how does that work with voice AI? Because pretty much all of the calls are recorded because you can't do anything without the recordings. You need recordings, transcriptions in order to get the AI going. How is that going to work? I don't know. The thing is, even the regulatory authorities and places where you can start complaining about violations of this, they are not even established yet. So I don't know. In German, there's a thing where you say, I don't know if you speak German, wo kein Kläger, da kein Richter, so where nobody complains, there's no judge to do anything about that, but don't bet on that, right? So, and the other thing is I would like to talk to a human, like as I said, human consent is a thing. You have in the UI the requirement that when I tell the bot I want to talk to a person, then I can talk to a person. And that means call transfers gets a thing. And we have seen more than one call transfer to drop audio, I'm just saying. All right, and somewhere between dimension like 4 and 9, we stopped being telco engineers and started becoming AI quality assurance people. Whether or not we want to do that, I don't know, depends on you, depends on the person. The problem behind that is that LLMs are just non-deterministic. So you can manually test 1,000 times a certain scenario, and for 1,001st time it will behave different. And you just can't manually test your way out of that, and you need to create boundaries. You need to make sure when you craft your voice bot that you have like rules, state machines, and all of these things in place in order to do that correctly. And you have to have a way to properly test and monitor that, because things can change over time. And I was asking AI to create a good punchline for this slide, and it said, automate or die. And I tried to make it a bit more optimistic, automate and succeed. And the automation of this kind of QA is what we do at Zipfront. We do have a desk out there, so approach us anytime over the next 2 days. You can approach me anytime at coffee or whatever. And let us show a couple of things that we do in this space. Thank you.
Thank you, Andreas. So, AI and questions. Oh, okay. We have to give tokens for the questions. So.
Yeah, Andreas, thanks. Actually, a question about MOS. What exactly do you measure? Because if we're saying about network statistics, like if the network you can measure like without knowing what's actually going, but what exactly do you measure in the MOS?
Yeah. The problem with MOS and the network is there is this thing called shit in, shit out, right? You can transport the most crappy thing in the most perfect way over the network. A lot of times, and specifically if you look at, for instance, how this BCM base64 thing works, there's a lot of things that can go wrong there, right? And then your voice application server already has crappy audio, which is going to transport over the wire perfectly fine, and it still sounds crappy. So what you actually need to measure is really how the audio is being perceived, and this is how the still MOS and XSLR MOS work. They are trained on hundreds of thousands of hours of actual phone calls to determine whether this was a good call or a bad call.
There is other methods, as I know.
Question here.
Hi, I'm Varun. We run Pipecat, which is an open source orchestration framework. So thank you for your talk. It was really helpful. I do agree with you on one front that I think web developers don't understand SIP or telephony. And I think the biggest hindrance has been the audio quality, like the fact that we're using 8 kilohertz and it cannot go over telephones. That's the only thing that can go over telephones and none of the other stuff unless you upgrade your telephony. Like carriers don't necessarily carry G722 or any of the new stuff, which is very frustrating. So a lot of people will just call in and say like, my audio sucks. So, and the other thing I think that you highlight, which is that we need evals. Like evaluate all your audio, stack your SIP bots completely from end to end. And I think that's a really important aspect that everyone should consider. I don't think in SIP world we ever did that in much the way that we are doing in, like we need to do in AI world.
Yeah, I think it hasn't been considered as that important in the SIP world. When we talk to people like, how are you testing? I mean, I ask you, the responses were kind of like so-so, right? It's not like you guys are testing too much, let's put it that way. And that has always been a problem. And when we approach them or approach people, technicians, we a lot of times get like this response saying like, who are you to tell me how to run my telco operations? I'm doing it like this for 20 years already. And yeah, well, are we doing it since 20 years correctly? Probably not. So just food for thought.
Okay, thank you. AI can go a lot on discussions. Andreas will be around, can also do some demos if you want to see what they are doing. There is a table outside. But yeah, we know that AI is quite verbose also when it reports some stuff. I wanted to say that for power, you see those small round, you just have to find a way to open it. I tried. He succeeded, I see one here, but just be careful where you put the cables not to like disturb the others or make them fall. Okay, so now it's time for the next presentation because I guess everyone is also eager to get to the coffee break. There should be some croissant, like a lightweight things to eat. I'm happy to have again Wolfgang has been with us as an event for many, many years, but also with the project as a developer. So I already mentioned the JWT3. It's coming from his contribution, but then he has also a few other modules related to this NG112 or NG911 lost and so extension for those that are in the space. Wolfgang, thank you for joining us again and giving us an update on this kind of continuous try to standardize in Europe this emergency calling infrastructure. Thank you.
Yeah, thanks, Daniel. And I need a coffee as well, so I'll be quick. Yeah, as Andreas already said, technology has changed. Yeah, now we're talking about AI bots and things like that. And in the last 25 years, also the technology that we use in our mobile devices has changed. So in the past, we had circuit switching, and now everything is changing to 4G, 5G, which is actually packet switching, which means when we do a voice call, it's voice over IP, so we have SIP, RTB, things like that. And even control rooms are changing now from their circuit switched interconnects to telcos to SIP interconnects or to SIP trunks. So which means that we have actually new technology at either end. But you may have heard that in some countries, some people or some mobile devices of inbound roamers cannot connect to emergency services. And that's, a tough thing and a very important topic right now at INA, for instance. And it happens especially if 2G and 3G is being turned off. Yeah? So if you plan to join the World Cup in the US, perhaps you do a test if you can dial 911 in the US, if it actually works. And the big question is, so why is that? Yeah, and perhaps that's the answer for you. So who knows that? Yeah, there are a few people knowing that. It's from the 12th task with asterisk quite a long time ago, and there was task number 8, which was simply to retrieve permit A38. And that's actually happening right now in Europe because there is a kind of mandate from the Commission saying emergency communication needs to be packet switched. So that's the permit A38 thing. And they also say it needs to be accessible. So you need to have packet switching and you need to have means of accessibility. So it's audio, video, and text. And that's it. Yeah? And the member states are now asking their local regulators, okay, what technology shall we use? And the regulators are asking back to the Commission, okay, what technology shall we use? But there's no answer coming back, so it's just kind of loop that we have. And one thing, I don't know if you remember how this ended in Asterisk. So I think Asterisk just invented a new permit and just turned the sites, and all the others went crazy, and they said, okay, here's your permit and go. So one thing to get out of this loop is over-the-top applications, and over-the-top means, okay, I'm actually not regulated, I can install an application. And there are some countries already doing that, so this actually creates silos, and we don't get to that interoperability and that accessibility level we would like to have. So in the next, let's say, 15 minutes, I'm going to talk a little bit about this standards gap. So features like real-time text require this end-to-end protocol consistency I was talking about at the beginning. Or there's another challenge, is the callback challenge. So 5 to 10% of emergency calls require callback because the call was perhaps dropped or disconnected. And PSAPs in some situations cannot reach the devices. So again, if you are an inbound roamer and if you're not registered to the IMS, to the local one, they have no identity, they have no MSI to use for the callback. Yeah? So that's quite of a challenge. And then there's another thing, it's new connectivity layers. So we see more and more satellite technology, so direct-to-device SOS or emergency SOS. And there's another thing for accessibility, it's about relay services. And people are using that, and they would like to use it also for emergency communication. So we need to get those things into the NG112, NG911 framework. So let's start with standards in emergency communication. So there are two ways how to deal with it. The one is the over-the-top, so you see it on the left. So actually, if you're a control room or a PSAP, you need to cope with all those things that are happening out in the wild. So if it's over the top, you may have to integrate with different applications. And if you want to do this throughout Europe, for instance, then you have to integrate all the applications that are around in Europe. On the other side, we can have a very clean solution, and it's the one that I'm always telling you since I'm joining the Kamailio World. It's ETSI 103479, so that's the framework document, or the foundation, the technical foundation, how to access emergency services. And that, if you would like, is something we can call an IP-NNI to emergency communication. So that's an entry point that can be used by all originating network types. So assuming they are voice over IP based, which is actually happening everywhere now. This interface provides native audio, video, and text accessibility based on RFC 4103, which I think has its origin in T140, mentioned by Andreas. So the fax is also here in place somehow. And with this, we have a way to get rid of the proprietary over-the-top solutions, getting rid of those silos that work perhaps in a country but not European-wide. And there are three examples I would like to share with you. One is DS 103479, so it's free, available on the internet, just look it up. And it's the technical foundation. So it describes the interfaces, it describes, okay, how to provide location information, which codecs do you have to use, how do you set up a session, and how it's being routed to the most appropriate PSAP. Then there is a new one, which is still not published. We're currently working on that. It's DS 103873, and that can be quite interesting because it's extending a little bit the idea of the interconnect. So it's especially describing, okay, what do you have to do as originating service provider, being a VoIP service provider or an MNO, if you would like to interconnect with such an infrastructure. And it also deals with the callback challenge. I'm going to talk about it later. And then also very important, because that has a different name, it's ETSI EN 303.919. So that's a harmonized standard, and this one is currently out for review. So it's being looked at by each of the NSBs, the national standardization bodies, and they provide their feedback. And if that is done, I think end of May, then we may have a harmonized standard throughout Europe describing accessibility. So this one is especially describing the functionality, to fulfill the requirements for accessibility. So describing real-time text, describing video for sign language, and describing audio, and all those things to get to the most appropriate PSUB, which for accessibility could mean that you select a PSUB with a core data that has the capability to sign, for instance, or that has the capability to connect into a relay service and support a person in need. So the right thing is actually where we want to go and where we shall or should go. It's a clean solution, having one clear interface and then not those different types. Talking about this protocol consistency, we need some things that work end-to-end, and I just pick one example. There are a few others to make it work, like what I was saying at the beginning. If emergency communication doesn't work, it may be because the end device doesn't have the right profile. So there are GSMA profiles. You have to download that the device knows, okay, this is how I connect with an IMS, and these are the features I need to do, and things like that. So if that is missing, it doesn't work. And here's another example. It's about real-time text. So real-time text needs to be supported end-to-end, and it starts at the device. So the device needs to support it, and we do have already devices. So in Austria, I have 2 mobile operators that support, so I can actually text from an iPhone to an Android using different providers. So real-time text is there based on RFC 4103. But if we want to forward a call or transfer a call from one PSUB to another PSUB, we have a situation where there's a multi-party RTT session mixing going on. And if this is not supported by the UEs, they just could do it. There's a new RFC, I think it's RFC 9071, which would allow the device to act as kind of bridge and order the messages that are received or the character that's received into the right bubbles. So if this is not happening, we need something that does it instead of the UE, so it's then the bridge. So another important thing on another side, because it's on the service side, perhaps somewhere in ESINet provided by emergency services or emergency communication solutions. Then you may have already seen a session setup with an STP that has not just a single M line, but multiple M lines. And if you have audio, video, and text, you have 3 M lines. And some session border controllers just drop those things if they don't understand. So that's another problem. You need to be aware at any device that just forwards those things, that all the information is passed through not only STP, but also some SIP headers that we need for emergency communication. And at the right end, there are PSUBs, so they need to support it as well. So currently there are solutions around which totally makes sense because it's currently a voice call. Solutions that just have a touch screen for call taking. So you just click on the screen, it's fast and easy, but it's not good for texting. And if you do real-time text, you perhaps use a keyboard, or you have some clever speech-to-text solution implemented. So however it's done, you need to be aware that there's a new technology, and even there has to be some look at the capabilities and some things that make sure that we have end-to-end consistent communication. Just moving on with the emergency callback. In the easy situation, you just register to your network. So there is something like a BCSCF, can be a Kamailio, and this extracts the user identity during the registration, and the user identity can then be forwarded to the PSUB. So the PSUB gets actually the MSI SDN, any P-asserted identity header, And in most cases, it's two of them. One is just providing the tele URI, and the other one is providing a SIP URI. So the tele URI can be used to call back via MSI-SDN or via the legacy world, via the PSTN, sorry. And that just means it's audio only. But with a new interface, you just get back to the PSUP using the same, like the inbound interface, and you can actually call back multimedia. So there's also the European Accessibility Act saying that you need to support the same media types in the callback that were received in the original emergency communication. So if someone dials in with RTT, you need to call back also with RTT. That means you have to use the IP interconnect back to the mobile network operator. Here's also an important thing. So emergency communication always does local breakout. So in the situation where you're in the home network, it doesn't actually care a lot. But if you're in a situation where you're roaming, like this one, so you're actually visiting another network infrastructure, and then it's local breakout is very important, because if you're interconnected or routed back home via S8 routing and do an emergency communication and it gets back home, then it might be difficult to provide you some help because you're actually in another country. So for that, local breakout is the answer. So emergency calls are always terminated local. And in some situations, you don't get that information about the MSI-SDN for the callback. And this means, okay, you're not locally registered, so that's called unregistered situation, but you may have a data connectivity back home. So like this S8 routing, which is used there, that all your data services from home are being used. So your home network actually may know about your MSI-SDN, which can be mapped using the EMI, for instance. So that the local network just knows the EMI if it's unauthenticated, but the home network can provide you some information for that mapping. So this was actually introduced also by ITUT recently, and we are currently working on that callback mechanisms in this new ETSI that I've mentioned that is being used for the interconnect. So if that works, so if you can get that information, if there are some roaming agreements that the visited network can ask at the PCRF of the home network, you may get that information back and can send it in the same way like before. So the PSUP can actually call back. The big difference here is, perhaps it's you cannot read it because it's too small. The big difference now is that the SIP URI, the host part, points to the visited network and not to the home network. And one can still use the PSTN as fallback because that number will be visible as well. So last but not least, there's another state which is the limited service, which means you don't have a SIM card perhaps, you don't know the provider doesn't know anything about you, you're not registered, but you receive an emergency invite because your device can always do an emergency communication. And for that, we propose something like a temporary identity, which is provided with a peer-asserted identity header, and then there needs to be kind of mapping of this temporary ID back to the IP address of the device or to the EMI. So we'll see how this will be described when the standard is being released. And then there's also another challenge is to keep the device on the same network that is being used for the emergency communication, because if you want to do the callback, you need to reach that device. So finally, if you get those things up to the PSUP, then the PSUP can do a callback, and there's a new element, can also be a Kamailio, and perhaps that one is using JSON Web Token modules, because we can also sign the callback, or we shall actually sign the callback so that the MNO knows, okay, this is a call that is originating at the PSUP, so we can trust, so it's being signed. We're using steer shaking mechanisms here, so there is a an attestation service, and there's a verification service in place. So the one is within the infrastructure, within this OSIF, it's outbound call interface. And yeah, this helps the MNO also to set a certain priority for the callback. One can also show that the call is from an emergency service, so this can be shown at the display. And yeah, very important thing is you can also do the multimedia callback via this way. But again, it needs end-to-end consistency. We need to understand each other, and every element needs to know, okay, what to do. Moving on with new connectivity layers. As I mentioned, this kind of satellite SOS, which I think requires native integration into the NG112 system. So there are some reasons for that. One is currently it's more or less proprietary. There are some relay centers used today, so you receive that message and then they look up some databases and figure out, okay, where is the PSAP, where I have to forward this, and that actually doesn't scale to my understanding. So if this is used more often, you need some kind of scaling solution, which is then the NG112 system. The other reason is that those solutions always have a ground station. So if it gets by the satellite, it needs to be received at the ground station, and that ground station may not be in the country where the PSAP resides. So if I'm hiking around somewhere where I have no connectivity, and the ground station is in another country, but I need a local PSAP, then I have to figure out, okay, how to get there. So that means we need to interconnect those NG communication solutions, or ESI nets, globally actually, and then everything works. Because you get the location, you can figure out, okay, where is the PSAP that is actually responsible for that region, and you can forward it to that. And that's just simple messages. Yeah. Currently, there's no audio, so you can have bidirectional messaging, but that's it. And also important thing which is quite new and which will be part of this harmonized standard I've mentioned before is to provide relay services wherever you are somehow, because relay services provide a fundamental accessibility service. So users are just calling relay service, and there's a sign interpreter helping them to connect to the government, for instance, or to the doctor, or also in emergency situations. And here the idea is that calls always get first to the PSAP, providing the location for routing purposes, but, and that's the new thing, you may find in the future a user setting in your device that allows you to set your preferred relay service. So it can be a kind of URI being stored there that just describes your relay service. And it needs to be in the device because it cannot be on the, let's say, provider side, because if you're roaming, you have no connection back home, that information may not be available. But if it's in the device, you can always send it, and the PSAP is automatically aware of that information. So it gets that additional information with the call setup, and with a bridge, you can then include this relay service in an emergency communication. So that would mean a video call where you have three parties: the calling person, the relay service, and the PSAP call taker. And two people are just signing perhaps, and the other two talking to each other. Yeah? So that's the service people are used to, and that would, with such a solution, work anywhere. Yeah? Because if you have connectivity to that relay service, it can be integrated. Yeah, just closing that to get the coffee. So I think by adopting this 103479 and implementing this harmonized entry point, we can make this accessibility native. So we don't need applications. We can use that stuff that is on the end device. We can have cross-border connectivity. So just sharing information among PSAPs, forwarding calls, bridging in the relay services, for instance, and we have a way for the callback as well. And last point is perhaps something for dangerous demos. So future innovation is also possible if we implement those 103479 spec. And that can be or shall be the permit A39 to get out of this place that sends you mad that I was showing at the beginning. Then thanks a lot and happy 25th anniversary.
Thank you, Wolfgang. Okay, let's be quick. One or two questions about, we have Dragos.
Hey, Wolfgang. Thank you for the talk here.
Yeah. Hi, Dragos.
Hey, Wolfgang. So thank you for the talk. And while implementing voice over Wi-Fi, I observed that it has a lot of provisions for emergency services there. I don't know when they're going to come live, and I'm wondering about your thoughts on it, especially also for SIM card-less calls, emergency calls in that case, because it basically just comes over the internet. And who's going to provide the service directly? SNet, or is the regulatory body going to, force the operators to do this for free or?
Thanks for that. A great question. I think that changing to that, and I totally forgot about voice over Wi-Fi. Yeah, thanks for that. Changing to that means that you need to have a kind of regulation or a kind of act that says you have to provide such an infrastructure, and this is the way how you interconnect. And recently there was in a conference in Riga, and there was a person from the Commission, and he was actually saying in a panel that even if the Commission does not require the implementation of these standards in a document or in an act, he said it's the technology that we need and that we are going to use. Yeah? So perhaps after a long time there's a shift into that direction, and then people understand, okay, we need to harmonize this, we need to make sure that it works. Otherwise we only can fall back to 2G or 3G to make sure that it works, especially with those new things. Yeah.
Okay, thank you. One quick last question here, and then you can approach Wolfgang.
Thank you. Jan from Slum. I have a question regarding any plans you may be aware of regarding European Union implementing requirements like in the US, E911 services like Ray-Baum Act and Kerry's Law, which is quite challenging and also complex for the end user perspective and stuff like this. Is there anything that also enforces us in Europe to deliver the location straight away, direct details and stuff like this?
Yeah, in terms of location, I think everyone at the Commission already knows, okay, we need a solution for that, and the clear solution is here to have a location by value provided with a bit of flow in a SIP session setup. So that's actually coming from all the mobile devices right now, and you can use the same thing from other end devices if they get the location. In terms of regulation, I think perhaps we need to wait some time, because with that new harmonized standard, we have at least something that helps to make sure that everyone sees it in the same way, and that just states start to implement it in the right way, because they're just waiting for a document saying, okay, this is how you have to do it, and then they can force their providers to make sure how it works. The problem is, in the US it's easy, there are some things from the FCC, it's just one authority, and in Europe you have still the member states, and the Commission always delegates such things to the member states.
Okay, thank you everyone for the first session this morning. I don't want to keep you longer. From the coffee is just outside with some kind of breakfast next, some croissant and so on. We'll be here in like 25 minutes or even less a bit, so enjoy the coffee and try to connect between each other. See you in a bit. female speakers to telecom events. Thank you for doing, and I'm going to give to every woman that attends here. I'm starting with you.
Thank you.
Because even in attendance, we don't have so many, and a small appreciation for your initiative to come here, and Yufei we have here. Hopefully I counted right how many I need to bring. And is any other woman in the room at this moment? Sorry? Yeah, I will give it when I'm at her. Okay, let's start. We started a bit late, so don't stress about that, but people wanted to have the coffee. Elena, again, thank you for coming. Push notification in a scalable way with calling and so on. Very much appreciated for taking your time, resources to come and share with us. The floor is yours.
Thank you. Hi, everyone. So this is my first time here at Kamailio World as a speaker, and it's really a pleasure to be here. I'm Elena, and I'm from Spain. I started working in voice over IP systems, understanding the SIP protocol more than 10 years ago. And now I'm working at CloudTalk as a senior voice engineer. CloudTalk is a cloud-based contact center platform, and well, I put some numbers here about our infra. So we are managing 15,000 registered users every day and around 2,000 concurrent calls in a distributed and decentralized architecture around the world. So today, I'm going to talk about push notifications and WebSocket connections, and then how we are scaling Kamailio instances in AWS. So we are managing in our infrastructure auto-scaling groups and Kamailio instances behind a load balancer. Then I'm going to talk about use case in production about the network switching, and just to finish the presentation, well, I'm going to talk about a little bit about voice agents, because you know it's a trending topic now. Okay, so push notifications. Whatever is the reason, mobile devices go inactive. So doesn't matter if we are killing the application, the mobile is going to standby, or just suspending the mobile. So mobile devices go inactive. It means that the mobile device is breaking the WebSocket connection. This is something that anyone building a SIP client application knows. So what is the process here? We have in our phone the application running with our SIP user agent, sends the register, and we are creating the WebSocket. But then if the mobile goes to a standby, and Kamailio would like to send the call to the phone, doesn't matter if we have the ping-pong messages, keep alive, and so on. And doesn't matter if Kamailio has in the location database, in the location table, the information about the public IP of the phone. Kamailio cannot send the invite, cannot send the call to the phone, because the WebSocket was broken. And of course, this is the reason, one of the main reasons that push notification exists. So as all of you already know, we need to send a push notification to the phone, so the phone wakes up and then creates the WebSocket connection, and we can send the invite. How we are doing this one? Well, we have here a simple diagram. So Kamailio is receiving the call, the invite. Kamailio is going to send an assigned HTTP request to the application. The application wakes up, send the register, create a new WebSocket connection, and then Kamailio can continue sending the invite as the regular flow. The thing here is that Kamailio needs to wait until receive the register. So this is the thing. We are doing this using two functions of the TMX module, T-suspend function and T-continue function. So here we have a little piece of code. Kamailio is sending an HTTP async request to a push notification service. So the push notification service sends the push notification to the app, wakes up the mobile, the application, and then Kamailio is suspending the transaction. It means that Kamailio is saving in the shared memory all the information about the transaction with a timeout, of course, because if you never recover the transaction, it will not be pending there for minutes and hours. So Kamailio is saving everything, is saving pseudo variables, everything in the shared memory until waiting a trigger to continue the transaction. So our trigger will be the register. So when we are receiving the register related to the same user, the same call, we are continuing the transaction. It means that in our request route, we have the register process with the pseudo variables and so on related to the register packet. And then when we invoke the tcontinue, Kamailio get in the main request route everything related to this transaction, so you can continue working with the invite as in the first line of this code. But then, well, we wanted to complicate our lives, adding redundancy, scalability, high availability, and so on in AWS environment. So we decided to go with Kamailio instances inside an auto-scaling group. It means that we have a load balancer which randomly is sending the requests to any of the Kamailios in the group. So here we can see our auto-scaling group, Kamailio 1, Kamailio 2, Kamailio 3, and so on, and the load balancer. Well, in AWS, we have, three types of load balancer. So we have the network load balancer. The important ones are two: the network load balancer and the application load balancer. But in any case, anyway, these types of load balancer doesn't know nothing about SIP. They are not deciding, checking SIP headers or whatever. So the invite is coming to the load balancer, and the load balancer is sending the invite to Kamailio 1. So similar as we saw before, Kamailio 1 is sending the push notification request. The push notification is going to the phone, and the phone sends the register to create the new WebSocket. The new WebSocket is created with the load balancer, and the load balancer gets a random Kamailio. In this picture, it is Kamailio 3. So, well, we have here a cool deployment with Redis shared between Kamailios and so on. So, okay, maybe we can try to send the invite from Kamailio 1 to the load balancer, because we can use the WebSocket here between the load balancer and the phone. And, well, of course, we are seeing here the solution that we can't, because the load balancer will drop this packet. The load balancer cannot establish the same WebSocket connection with the same source IP, source port, destination IP, and destination port to link this WebSocket connection to two different instances inside the cluster. So the load balancer will drop our invite here if it is coming from Kamailio 1. And well, in addition, I didn't add here more things to not overcomplicate, but AWS has a lot of possibilities to try to send packets to internet. So AWS will use the NAT gateway to send the invite to the phone. But again, the NAT gateway cannot create a new WebSocket to the phone. So, well, this is the architecture that we have and how we solved this issue. Well, before going to the solution, so we don't want to have isolated regions. We want to have a group of auto-scaling groups in each region, and each auto-scaling group has its own load balancer. So if we have a company in US receiving calls from US, but agents, some agents, of all agents, doesn't matter, are distributed around the world, we would like that the call from US goes to Europe, for example. So we don't want to isolate regions, and we want to make the solution possible between regions too. Of course, with some delay, but it's okay in this case. Just the SIP protocol is so fast. Okay, so here we have a similar diagram explaining the solution. The first part, it's similar. Well, the first part is the same. So Kamailio 1 is receiving the invite, sending the async HTTP request on external service to send the push notification, and suspending the transaction. But then, as we saw in the diagram before, the register is going to Kamailio 2 in this image. So we are adding a parameter, an encoded cookie, indicating in the push notification that, hey, Kamailio 1 is the instance which has the invite suspended. So then, in the register, we can see that we are sending the instance ID in a zip header. So when Kamailio 2 receives the register, send an internal request message, in this case, to Kamailio 1, indicating like, hey, I am Kamailio 2, and I am the owner of the WebSocket connection. So then Kamailio 1 can search in the location table, but we have some delays between regions in database. So in this case, Kamailio 1 just needs to send the invite to the source IP of the message, and then Kamailio 2 will follow the regular flow to send the invite to the application. And here we have, again, the simple code used to do this approach. It's similar to the previous one. Well, here we are managing the message. So if we receive the message, we are going to continue the transaction. Well, I didn't mention before that the T-suspend and the T-continue transactions, you need to save the indexes to identify the transaction, of course, which again is in the shared Redis in the cluster. So again, we continue the transaction, and then we are going to manage. I mean, when we receive the message, continue the transaction because the message is the trigger, as we saw. So here we are going to decide if the message is coming from my IP. Means that I am the Kamailio with the WebSocket connection. So just send the location, the invite. I will follow the usual flow. And if not, well, it's very easy too. So we are just changing the destination URI, use the T-relay to send the invite to the proper Kamailio instance. As all instances in the cluster, of course, has the same configuration. And now I'm going to talk about network switching, which is an issue that we have in production or had, and it's not a bug, it's a feature. Well, network switching is happening when the mobile change the network from the cellular to Wi-Fi or vice versa. So we have two cases of network switching. The first one in the left side, network switching during an active call. So what it means, and of course I am talking about the mobile devices and applications, it's like the same topic. So we establish the call with the flows that we already saw and so on. And then the mobile switch to the Wi-Fi or switch off the Wi-Fi or vice versa. Yeah, so the mobile, here the application needs to do things, of course. So the mobile is going to send a reinvite because the mobile needs to restart ICE, get the new candidates, and so on. So it's sending a reinvite to negotiate the new IPs and the new media parameters, of course. And well, if our Kamailios in the cluster, in the autoscaling group, are sharing the dialogue, this is working as it is. because the dialogue is already established. We are not talking about the first invite or the first ACK. We are talking about a reinvite during a dialogue already established. So that's it, it's working. But now I'm going to talk about a tricky case, which is the network switching during ringing. And why? Because we can think that it is a corner case, but it's not a corner case for us, maybe for others too. So if your mobile device is in a standby, like more than 2 hours, or something like that, sometimes iOS and Android, okay? The mobile is switching off the Wi-Fi, but switch on the Wi-Fi just when the mobile is receiving the push notification. So we have here a really tricky case because, well, in the first part of the diagram, we see that Kamailio 2 is sending the push notification, the mobile wakes up with the cellular public IP, send the register, create the WebSocket, and the invite is sent to the cellular public IP. But then after 1 second, or I don't know, some milliseconds, 2 seconds, the mobile switches on the Wi-Fi. So, well, the mobile application needs to do a lot of things here. It's not just sending the 200 OK. Needs to restart the ICE, get the new candidates, send a register, and establish the new WebSocket connection. But finally, it's sending the 200 OK. So, well, for us, it's breaking the path. Well, first of all, the application can detect this network switching. So the application is sending a specific header in the 200 OK telling us like, hey, the network switching during ring gear happened. Well, so Kamailio 3 receives the 200 OK and magically, it's working for 200 OK its path because, so all Kamailios in the cluster has the same configuration. Of course, each Kamailio has its own private IP, but all of them are setting the same public domain of the load balancer in the advertised parameter. It means that in the last hop in the Kamailio 2, the via added in the invite includes the domain of the load balancer, not the private IP of the Kamailio 2. So when the 200 OK arrives to Kamailio 3, Kamailio 3 see the domain of the load balancer, which is in its own configuration in the advertised parameter, and that's it. OK, the 200 OK is for me too. And then Kamailio 3, well, will remove the via and so on, and the 200 OK path is done in a good way. But the ACK, no. So because here in the 200 OK, of course, the application is sending the same record route headers that received in the first invite. So the ACK follow the first path, which is Kamailio 1, Kamailio 2. But then Kamailio 2 would like to send the ACK directly to the application, but it doesn't have the WebSocket connection again. Well, to solve this issue, personally, I tried first modifying the 200 OK record route headers in the Kamailio 3. You can change the IPs, but you cannot change everything. You cannot change the identifiers of the record route well. And honestly, it is a little bit dirty solution. So, well, you just need to send the ACK to the instance that you want, and that's it. So Kamailio 3 is receiving the 200 OK with the specific header, got it from the application, and it's saving in the Redis the Kamailio 3 IP. So in Kamailio 2, when Kamailio 2 is receiving the ACK, we are going to check in loose root function before the loose root and after the loose root function. So after the loose root function, Kamailio 2, the zip process, we will not have any record route headers because it's the last hop. So we are detecting this and sending the ACK to the Kamailio 3. And Kamailio 3 is receiving the ACK without any record root headers. So it's our ACK, it's our use case. So Kamailio 3 can send the ACK to the application and establishing the dialogue. Well, and then to finish the presentation, I don't want to talk about a different topic. I'm going to talk about this because just to highlight that we used the same solution, the same approach, and the same architecture to work and deploy voice agents. So more than 1.5 years ago, we needed to develop so fast a voice agent solution. We didn't have time to create a full SIP server from scratch to manage this thing and so on. So we are creating voice agents on demand using exactly the same code. So Kamailio 1, again, is sending an HTTP request. Well, it's not push notification. It's just the HTTP request to the streaming service, in this case, API. And this streaming service is creating the voice agent, sending the register, receiving the invite, and propagating the streaming to the AI. So, well, that's it. Thanks to all of you. Questions are welcome.
Thank you, Elena. We have time for questions. We have Ihor. Thank you.
Yeah, thank you. Very interesting. I have a question. How, in this tricky case, when you have switching in the mid-dialog, how do you deal with the dialog states on Kamailio if you do? Like, because you have sort of hanging dialogues and there is a mid-dialog in Kamailio 3 or something like this.
Yes. So in general, in our auto-scaling group, we are sharing the dialogue using Redis. So it's a really good question because Kamailio 2 is never receiving the 200 OK. So from the point of view of Kamailio 2, the transaction dies. But the transaction dies there, and that's it. It's not propagating any issue to Kamailio 1 or Kamailio 3. So the transaction dies there, but it doesn't matter. We can continue with the call flow.
Dies silently.
Yes, yes. And then if we need to put on hold and retrieve the on hold in the application, we always are going to follow the second path. So, yeah.
Okay. Stefan here. Hello. Do you use topos in your Kamailio cluster?
No.
Okay. Thank you.
So topos is topology stripping, making it to look like back-to-back user agent, more or less. I guess Stefan there contributed some code there. I'm wrong or not? Hash table came from you? Topos hash table? I remember. We have Andreas here.
Thank you very much for the presentation. There's quite some complex routing in place, and things go wrong sometimes, right? How do we approach troubleshooting? Because you have like 3 different Kamailios, very complex call flows, and if you're trying to stitch together the actual path, how do you approach this in terms of following the call flow and how it really went through all the instances there?
For the first, here, this one is the most common one scenario using 2 Kamailios. Well, we are sending a specific header, and we are managing a dialog variable and a specific header indicating, hey, I am the Kamailio 1 in the path, or I am the Kamailio 2 in the path. This is the way that we are distinguish Kamailios in the same code. Nothing special.
Okay, one last quick question here from Dragos, not to delay too much.
Thank you for the pressure, Daniel. Since we are on this slide, I see there X header instance ID. I think there is an RFC 8599 which standardizes these things with contact. I don't know if you consider that or you think that's bad? I don't know.
But are you talking about the header, the identification, or what?
So that RFC specify exactly this service. How do you push notifications to some mobile phone with contact parameters, so you could suspend things and then resume? It seems very much what you're doing.
So, okay, here Kamailio, when it's sending the push notification, it is just an HTTP request to an external service. This external service is managing the push notification properly. And we are sending more parameters, like the user, so the all data that the application needs to show things properly and so on. So yeah, we are sending the user, sometimes, yeah, the type of call, if it's incoming, outgoing, well, yeah. Okay. It's external service managing it. And here, of course, I talked about the happy path. So, of course, the push notification can be rejected. So we have solutions for, if the push notification is rejected, we are canceling the call. If the user, if the application is never registered for some reason, or we are not sending the invite, we are sending messages to application to have everything synchronized.
Okay, I see it's very popular to ask questions, and unfortunately we can't really get more because we get delay, but we have the breaks and lunch breaks and try to approach the speaker for clarifying or getting more details. Sorry from there, I can't. Now we'll invite the next speaker. Thank you, Elena.
Thank you. Thank you.
Very interesting, very appreciated. From all
Thanks, Daniel. Quick show of hands before I start. Anyone contributed here to Kamailio in any way? Code, bug fixes, documentation, mailing list answers? Quite a few of you, yeah. In short, I mean, you guys are the reason that it's possible to make this talk. The community, which we'll talk about later. But just for context, Simwood is a carrier, a UK wholesale carrier, 30 years this year. Prior to that, I started a company called Cipcentric in 2010, acquired by Simwood in 2019. I became CTO at that point, and I had Kamailio Dev Access since 2013. Simwood's sponsored Kamailio World since edition 1, I believe, every year, since every in-person edition. And this talk is, in a sense, the sort of combination of all of those things, and where we are today and how we got there. So, the version of Kamailio that we run today, that we deployed in 2005, would still recognize the version of Kamailio that runs today. Almost nothing else in our stack could say the same thing. That's the talk in 2 sentences. I'm going to attempt to unpack that for you now. The talk has two halves. The first part is retrospective. So a quick tour of the last 20 years of stack churn at Simwood. The second part is forward-looking. And we're going to look specifically at two of the most exciting things that we're working on right now, and why they are each a Kamailio story. So, 20 years, or for the more astute of you, 21. We're going to walk you through very quickly, roughly 30 seconds per era, of how our stack has changed in that time, from the very beginning. And as I do, watch for the pattern, because you'll start to see what changed, what didn't, what changed, what stayed. Very condensed, but 20-year timeline there. What you'll see is the horizontal lines being the components, the layers of the stack. Every one of them has changed, sometimes multiple times through the years. But the top one there, the one at the top, hasn't. It's remained consistent from day one. It's grown in terms of its responsibilities, in terms of its role in the stack, but it's been there throughout. So we start 2005. Actually started with Asterisk, AGI for the routing, and MySQL for the data for persistence and config, on bare metal. So pretty much the starting point. I think if you were doing voice back in 2005, that's kind of what it would look like. The point is that Kamailio is not behind the soft switch there. It's at the front, customer facing still, but just purely load balancing between Asterisk instances at that point. And you'll see at the bottom, tiny line there. Kamailio is still here. Well, that's the starting point, but you'll see that throughout. In 2008, we replaced Asterisk with FreeSwitch at the core. It was the routing logic moved to mod XML curl with PHP-backed core routing engine that still exists today, just in a different form, different language, far more performant. But Kamailio's role there didn't change. Okay, it was still load balancing. What was behind it changed. What it didn't. Okay, it was still there, as you can see at the bottom. Early 2010s, I think that's what you call it. That's where the stack starts to look like a modern one. We changed, we stepped up from bare metal to VMs. VM virtualization was a good thing then, real thing, allowed us to deploy images rapidly and scale. We thought, brilliant, we cracked it. We struggled with MySQL at that point with the data, so we needed something a bit quicker to sort of cache the lookups and things like that, the data that we needed for lookups. So we implemented Redis there in about 2012. At the same time, Kamailio stepped up. Okay, so it started to take on things like filtering, security. We ran SIP capture on a spam port for fraud analysis. We sort of fed some of the signals into Redis and then used that elsewhere in the stack. It was essentially the start of the proper edge. So that's the moment, I think, that Kamailio stopped being just the plumbing and started becoming the true customer-facing surface. But then we move on to 2014. Registration. Prior to this, we were registering in the core, so Asterisk, then by FreeSwitch, because it wasn't really a big thing. For us, mostly was direct IP, IP auth, and then sort of set inbound calls to carry the customers was direct to IP. But registration was a thing, and in that year we launched Simwood Mobile. That relied on registration in both directions, so handling incoming registers, but also initiating outgoing registers. So we deployed Red Proxy, as we called it, and that sat at the edge, powered by Kamailio, as is a common theme you'll see start to surface. You'll see mention there of AI and UAC story. Just hold that thought because we'll come back to that in part 2. 2016, 17, getting more recent now, and the containerization was the hors d'oeuvre, the moment, the thing that replaced virtualization, VMs, and we, at the same time, extracted media from the core and pushed it close to the edge with RTP engine. Sat next to Kamailio, it handled encryption, transcoding, forking, and all of them became first-class capabilities at the edge rather than the core, allowing us to really scale and go global with the edge while maintaining quite a dense, performant core for the business logic. That pairing, Kamailio and RTP engine, structurally important, and we'll return to that also in a few minutes. And that brings us roughly to today. The registration, filtering, transport mediation, RTP engine orchestration, all sits at the edge, close to the customer where it needs to be. Latency is obviously important where any real-time media is concerned. Core routing logic, that sits at the core, with FreeSwitch still backed by our core routing app, now in Node, with Redis, performing something like 200 to 300 real-time checks for every call setup around fraud, margin, profit, protection, that sort of thing. But 2 concerns, 2 places. The edge handles the SIP and the media. The core decides what each call should do. Now, the interesting thing about that split, before I move on, is it's been remarkably stable. Everything inside has changed at least once. Each box, the shape has changed. But Kamailio has sat in front of it all the time, as I'm sure, I think all of you guys can agree. That slide speaks for itself. If we look back to that diagram, the initial diagram, Kamailio has been solid, strong, consistent throughout. And the thing about a piece of infrastructure that's been in place for 25 years, unchanged, is you kind of forget about it, until you try to imagine the stack without it. So why is it the constant? Obvious one. I'm going to give you 4 reasons, but the first and obvious one is performance. Kamailio handles real carrier traffic, always has done, does it well. I don't believe there's an open source equivalent that can match its performance. Genuinely, it's why we've used it for so long, and why it's so key in everything we do now. Operators know its worth, and it's why it's continues use today in key deployments around the world. Number 2, the modular ecosystem. It's kind of the Swiss Army knife of the SIP world. Anything that you want to do with it, you can do. Any SIP problem worth solving over the 25 years has been solved already with 25 years of battle-tested modules. The key line here is the boring stuff has already been solved. Okay, and that's praise. It's a compliment, because boring infrastructure is what you want, right? You want the infrastructure to just be boring and do what it needs to do. So you can build the fun things on top, the exciting things on top. Reason 3, that pairing I spoke about earlier, Kamailio with RTP engine at the edge, allows us to keep latency-sensitive media handling and orchestration around it, at the edge, close to the customer where it belongs. And it's not just architectural preference. It's load bearing really for everything that we're going to speak about in part 2, the forward-looking section. And part 4, perhaps the most important, non-technical, but the community. Okay. Oh, it's on this back. Okay. So credit really is due. Credit where credit's due to the community. It is not just to developers; it's to everyone who has shipped a release, fixed a bug, written a module, answered somebody on the mailing list for the same question that may be asked 50 times, with a smile, happily, because it's what makes the project tick, right? So, yeah, I guess this slide is just saying a quick thank you, from an operator who's been at Simwood and myself personally, as somebody who's contributed back, as Daniel said, actively in the past, perhaps more management nowadays, but just time commitments. But still some fixes here and there along the way. The reason Kamailio is still here is not just technical, it's because people continue to show up. So that concludes part 1. We're doing well on time. I'm trying not to go too quickly, but there's a lot to cover, so I'll leave time for questions at the end. Part 2 is kind of forward-looking, as I said. It's the catalyst. In fact, the most important things, also the most interesting things and exciting things that we're developing today didn't exist as product categories 2 years ago. Yeah. Kamailio enables every one of them in one way or another. Number 1, example, conversational AI. I think everyone's doing that in some shape or form. We've had some talks about it today, some really fascinating stuff actually. We'll take some learning back from that. But we deployed our first agentic AI back in April last year, April 2025, and we thought it was great, and it worked brilliantly as an AI component. It worked brilliantly, but our customers didn't use it, and why was that? Because they couldn't integrate it. Okay, we enabled SIP headers to be able to route call back to us to an agent and tell us which agent we wanted it to go to, and then we had some webhooks to channel events and things back to them. But they didn't use it because they had their own platforms, they had their own PBXs. They didn't want to re-engineer it. They didn't want to do all the work to integrate with that. So they wanted to drop it into their existing platforms, simple as. And the PBX shouldn't need to know it's talking to an AI. It should just see it as a regular extension, just as a human connecting via a soft phone or a SIP device. So that's what we did. We developed a reverse registration UAC with the UAC module, UAC reg, which registers outwards to any remote PBX. The customer just gives us some credentials for an extension on their PBX. It registers. And the novelty is what's behind that registration, not the registration itself. But that just really helps them to start to deploy these agents to their customers as if they were just... Yeah, and then all that's left is a bit of API work to define and configure the agent, the prompt and everything else. So it's there, registers, off it goes. We're using this ourselves. So meet Jay. Jay is one of our agents, as you can see. It appears in our list of extensions on the Simwood PBX. Answers questions from prospects, questions from customers. And the PBX just sees it as a regular extension on it. So let's do a slight demo, 45 seconds. Hopefully.
Welcome to the world of Simwood. My name is Jay. How can I help you?
Hi, I'm Benita, calling from ADC Telecom. I'm looking to speak to Charles Chance.
Okay, you're Benita from ADC Telecom, and you'd like to speak to Charles Chance. Can you briefly tell me the reason for your call?
We met at ITW and we spoke about how you guys use Kamailio in your stack and was interested in learning more about it.
Thanks, Benita. Please hold while I try to connect you. Hello, Charles speaking. Hi, this is the AI assistant handling your calls. I have Benita from ADC Telecom on the line. She met you at ITW and is interested in learning more about how Simwood uses Kamailio in its stack. Would you like to connect to the caller?
Oh, yes, please. Put it straight through. Anita, how are you?
Hi, Charles. I'm good. How are you?
I'll stop it there, but it demonstrates it's an intended transfer, right? But it's an intended transfer from an agent that can be integrated with any of our customers' stacks just with a set of SIP credentials, because it then appears to the PBX as anyone else does. So, yeah, quite a simple solution to what is a crucial problem really for customer uptake or engagement on that product. So why is it a Kamailio story? Registration, NAT traversal, transport mediation, all of the above, bending SIP at the edge without modifying endpoints on either side. That's kind of exactly what Kamailio was built for. Nothing in it required new modules. This was purely composition. So we took what was there, existing capabilities, assembled it in a way that made sense to solve the problem. A problem that didn't exist when those modules were actually written, as I said before. And that itself is quite a quiet credit to the project. The newest thing in our stack speaks the oldest protocol, and that's exactly why it works. The hardest part of this project, of this product, was everything except the SIP. Example 2. This one is in development as we speak, due for beta launch in Q3 this year. It will be useful, won't be polished, obviously, as any beta you would expect. But it's a set of carrier layer services to observe, transcribe, label voice calls in real time, and then surface structured highlights and data and insights to operators and to their customers. Available in 3 tiers, completely managed, API for self-service, and then pure sort of SIP tap, media tap, for example, SIPREC. Now, Kamailio, as you discovered in our stack, doesn't own the call metadata. The core does, but Kamailio owns the RTP engine session and orchestration, which is where the media tap happens, where the media is subscribed to at the edge, one or multiple times. So we push this information into Redis. That's not everything we push, but it's just a bare bones example, which enables then the tap service to be able to discover where calls are in real time and tap into the call on demand. It also allows tenant isolation, security obviously. So when when a customer presents their API key to tap into a specific call, we know it belongs to them. And then enrichment later on when the events are triggered or fired. It just allows us to sort of enrich it with things like the trunk involved, check configuration for that trunk to know what to do with them, and et cetera, et cetera. So the project, the real-time call analytics project, as I say, is still in development. The momentum of that is very fast-paced. It's moving swiftly, largely enabled by the recent additions to RTP engine with subscribe, unsubscribe on the NG protocol, and Kamailio's exposure of that. SIPREC is still in discussion internally as to where we handle it. Kamailio is a very real possibility directly versus the tap service, but we're still, they're both viable. Still actively reshaping what's possible 25 years in. We're not adding AI to Kamailio, okay? Kamailio is giving AI access to the call. essentially. Okay, same picture you saw before, just with a slight addition, and we go sort of just beyond now. Those two things I just spoke about are kind of at the front. They plug into the edge. They plug into the edge, and the edge enables it in a performant way, one where we can get closer to the customer wherever they are in the world, you know, that we're across the global platform. This doesn't happen at the core. There are other things, WhatsApp Business, Teams, Operator Connect, all of those things, they've all been enabled in recent years by this structure and by Kamailio. And as we near the end, the thesis, the sort of the thing that all this is based around. For 25 years, Kamailio has been the right answer to a surprisingly stable question, which you see there. And I don't believe the next 25 years of products or problems will change that question. Fundamentally, it's still very relevant. And that's the most exciting part. Thank you.
Thank you. Thank you for the prize, Charles. You contributed to the project as well. Thank you for that as well. And yes, we know we're going to have some questions here. I start with James.
Yeah, hi, Charles. Thank you for that. I really love your little demo. I thought that was really sparky. I was hoping that, I'm hoping that you can do a proper dangerous demo tomorrow.
Tomorrow,
but we'll talk about that later.
Okay.
I was hoping that you were going to say something about what you've been doing with WhatsApp for Business, and in particular, how you've implemented WhatsApp to SIP. And I don't know whether you can say anything about the Meta 2000 rule as well.
Meta, the WhatsApp Business API has SIP capability out of the box, so we opted to go that way, that route, rather than WebRTC, because it's kind of what we do at the core, and it's the core of our business. And we've got the edge locations wherever the call might ingress from. So it works really well. We use a lot of GeoDNS and some Anycast, particularly on AWS, where we've got some edge nodes around the world, to make sure that the call reaches us in the nearest places. But there's nothing special there really in terms of WhatsApp and how we're handling the SIP. It's just SIP at the end of the day. And Kamailio running at the edge enables us to be reachable.
Okay, just to add, because it was also on the community, actually these past days I added some support, because WhatsApp supports also SHA for hashing, for authentication. So that's now on UAC module, very fresh.
Okay.
It works with MD5 as well. It gives both options, but if someone is looking for the stronger hashing algorithm, it's now on the development version of Kamailio. Just as a note, and with Cyprus, hopefully Tori will have a short presentation. You decided to do it? Okay. He did quite a lot of work to make it easier to do Cyprus with Kamailio, and in the last session today, he's going to present the work he has done. And there is also some example in a README file.
I look forward to that one.
One last question, if any. If not, we'll have the lunch break soon. Thank you, Charles, and again, thanks, Simon and Simwood.
Thank you, Daniel. Thank you very much. It's working? Perfect. Great. Yeah, 20 years also with the project with some breaks. Today I'm talking about real-time text. Wolfgang already had a talk about that in the morning, about emergency calls in particular, and I will extend a bit on that. Real-time text for voice over IP infrastructure. First, a few 1-2 slides, just a bit about us. We provide web RTC service consulting in this area, do a lot of open source development. We one of our mottos is that we integrate almost all of our extensions, all of our work, what we have done with the customers in the open source project, and it's really good to continue this way. We provide consultancy, as said, integration, different areas. Kamailio, also recently with Asterisk and other projects. Our customers are mainly in Europe, in the US, Canada, also a bit in Asia, Middle East, and we are independent as a proper open source consultancy, and we consult them mostly in the Kamailio and Asterisk field. Okay, this whole project started 2024 when a customer from Germany contacted us and asked, hey, there's these real-time text requirements coming up. Do you like to have a look into it? And little I was knowing about it, I was pretty naive. I said, yes, of course, let's go for it. And it turned out to be a quite interesting journey, interesting challenge, and took also, unfortunately, a little bit longer than we all expected. But here we are now, and I think we have a good state, and I'm happy to present the current status. For the agenda, a quick overview. What is the real-time text in particular? You, of course, know all the WhatsApp, whatever, Telegram, Signal, different chat methods. It's a bit different. Motivation, legal requirements. Wolfgang, as I said, already presented a bit about that in the morning. I go over quickly the technical implementation of these real-time text, and cover a bit the implementation with Kamailio, and in particular also with Asterisk, and give an overview about the current status in Asterisk in particular, and next steps from our side in this project. As I said, it started in 2024, this whole phase, this whole project. We created the first version of the pull request in 2025, in the beginning of 2025. Now, here we are, 1 year later. I will talk a bit why it took so long. Some slides later, come back to it. It was a team effort. Everybody from the team sitting over there was involved. Many thanks for it. And it haven't been possible without everybody working on it in some part or the other. And of course also thanks to our customers for sponsoring this work, and also for the patience during the delays. So what is real-time text? Real-time text is text transmitted instantly as you type. If you are used to like Slack, Teams, WhatsApp, whatever, you type, you press send, and then it ends up on the other side. Real-time text works differently. You type, and it will send directly. So basically, similar as you talk, you can have a conversation directly. You can also delete real-time text that you have written. So it's real-time in a way that the receiver will see immediately the text that you sent. There are different technical means how to transmit real-time text based on different standards. Here in this talk, I will focus on one main standard, which is mandated also from the legal environment, from the legal regulations, especially in Europe. Why it's important to look into it, why it's necessary to implement the capabilities for it. Of course, the main audience are people that cannot really hear well, that are maybe hard of hearing. In the past, there were special devices or special apps, OTT apps, which were used from these people to communicate with other people. Of course, these special devices, they need to be installed in a place at your home. Special app needs to be installed from all the communication partners. This creates some barriers for the communication, and of course, we don't want to have it. We want to have it seamlessly integrated into the normal public telephony system. There may be also other people that prefer text-based communications instead of a voice or video-based communication for, I don't know, other reasons. Maybe they are just shy or whatever, right? So there are different motivations why this is important. Real-time text provides full support for international character sets. So we did tests with multiple languages. I think some Indian languages we tested. Of course, English, German, some other European languages we tested, and it works quite well with the asterisk. There might be also emergency situations where it's not possible to speak, right? Imagine you have a burglar attacker in your house, and you want to call 911, 112 in Europe, and then, you cannot really speak, but you can still type, right? And there's a standard from the European Union. It's also other regulation authorities. It's called total conversation, basically combining the video, the audio, and the text together, and this is a goal also to achieve. There are different regulations around this. I will share the slides later on. You can look it up. Basically, there are different regulations, accessibility requirements from the European Union, and then there's emergency number 112 regulation on the right side. These are basically the legal requirements in the EU for it. In Germany, there's Bundesnetzagentur, which mandated it in the current regulation 2.1, and other countries also have similar requirements, like in the US, FCC requirements, or in other European countries. It's all mostly boils down from this European regulation. There are different approaches in the EU. I think I'm not so much into the regulation side. Probably there are other people here in the audience that know more about it. But there are some older reports from EINA that present the situation. So some countries, like Germany, France, Netherlands, etc., they plan to integrate RTT as part of the national legislation and also in the core network. And some countries were a bit less patient, and they already standardized more or less some OTT apps on the mobile phone mainly to use it. The countries are moving in parallel, so even a country that has an OTT app will still mandate it in many cases to integrate it into the core network. And, which is important to know, the legal deadline, implementation deadline is 2027, so it's less than 1 year from now. And of course, it's overall, changes are necessary. Wolfgang already, as I mentioned, presented in the morning. We need to change the core network. We need to change the user devices, and also the public service answer points, basically the centers which receives the emergency calls, also needs to be changed. This whole thing is going on for some time. So there is already a lot of support in devices. And just to show you how it looks like, some slides about some user devices. So this is the iPhone, what we see here. Android, it looks a bit similar. If you look into your Android mobile and look for RTT in the settings, or in your iPhone, look for RTT, there's a toggle, then you can activate it, and it will be supported already, if the core network, of course, support it. If you have a phone call here, as seen on the right, you do the call, and then you can basically activate an overlay, like a keyboard or whatever, and then you can chat over the normal PSTN network. For the testing devices, here I have some conversation just tested a few days ago. On the left side, there's a client called ETSI Touch. It's a bit more modern. On the right side, it's a pretty old one, Tipcon. And but it works. You can see, you can communicate over these clients as well. These are desktop-based clients sitting on your Windows or Apple PC or whatever. And for the emergency center for the PSAP, just on screenshot I found, there are not so many publicly available, but here we have a US-based system, 911, and here you see, okay, my husband shot himself. It's transmitted over real-time text. You have here the output from the emergency center and the feedback from the from the caller, actually. Okay, great. So we know how it looks like and why we want to do it. So let's talk about techniques. We are a technical conference here in the end. So the good news is that real-time text calls are standard zip calls in the end. There's nothing really special about the zip call. It's just invite, 200 OK, acknowledge, bye. That's it. The text format is standardized in some ITU specification in T140. And the RTP payload for this specific text format is specified in RFC 4103. It's an older RFC, but it's pretty short, actually. It's not a complicated format. There are newer developments, like RFC 9071 for multi-party real-time calls, more recently published. I haven't been able to find an open source implementation of that yet. And from an RTP or media point of view, the real-time text calls are just using a dedicated text media stream. You know, there's an audio stream in most phone calls, then there can be a video stream, and now we have a third stream, just a text stream. We're using the normal SDP offer-answer mechanism, nothing fancy here, and also important, similar as with audio and video. You can have standalone text calls, you can have audio with text, video with text, and all kind of combination you can imagine. How does it look like from a header point of view, from a network point of view? Yeah, we have the standard sequence number, timestamp, synchronization source, and then the T140 encoded data. And as I said, it's pretty easy, not so difficult to implement. There are two different ways how to transmit the data. As you know, the RTP is transmitted over UDP, and UDP, we can have packet loss, these kind of things. And if we send text message, of course, we don't want to lose the text information, so there's an additional format with redundancy. So this is here on the next slide, and here we have basically the primary data, and then we have redundant data that we additionally add. And you can, in a standard way, basically you can have multiple, it's called generations, multiple copies of redundant data, and then multiple packets will have these redundant data. And even if one packet is lost, you still have access and can reconstruct it. Reconstruct the original message. From an SDP point of view, as I said, we just have the M line, not M audio. M equals text. On the left side, we have a normal real-time text call. T140 is the payload, basically in the packet. On the right side, we have the RTT with the additional redundancy. We have again a text line, and then the additional codec called RED, like real-time text redundancy. And in the last line here, this encodes basically the generations, or like the level of redundancy. Here in this case, a level of redundancy is 2. Okay, great. Now we know about the SDP and the RTP. How can we implement it? As you all know, probably, Kamailio really doesn't care that much about the media. It mostly depends on the user agent, so it's quite easy to implement with Kamailio. Just add the capability to the user agent, it will work. We did some tests. It seems to work with RTP engine as well. It's pretty easy to set up, and that's the easy part. And so if you're just concerned about the core network, you don't need to do much in the best case. The main issue is with the user agents. These are the user agents we are used for testing. The PJZip UA, since some months, also supports it now, which is great. It makes it much easier for testing. There's an old, more than 10-year-old client called Tipcon. And then there's Easy Touch from a Scandinavian company. Unfortunately, as I know, I might be wrong, but as I know, it's not free available. There's no open source version. So they set it as a commercial version, so you can contact them. And as I showed you, Android, Apple phones, of course, also support it. If you want to test it with a mobile phone, of course, you need to have like a mobile core or like a test IMS system. it's of course a bit more difficult. Yes, okay, about the asterisk. As you might know, there has been an older zip channel stack, older zip stack in the asterisk called ChanZip. There was an implementation in ChanZip. ChanZip, of course, it's now obsolete, it's not used anymore, not useful anymore, and we also tested it, it seems to be also broken. And since some time, we're working on a Chan PJZip implementation for this support. And this, as I said in the beginning, turned out to be more difficult than we expected. I've done quite a lot of PRs in my 20 years of experience with open source projects, and this is the longest and also most difficult, I would say, PR I experienced so far, for different reasons. I put a screenshot here. We have a lot of discussions in the PR. I think it would be also good sometime to, we resolved most of them, but it's still not merged, unfortunately, yet. So why it was difficult? The PR was based on a previous unfinished PR from other people. We needed to integrate it and to refactor it. This was really difficult. And then, of course, we need to integrate with many existing asterisk parts. Why we based it on this existing PR? Basically this existing PR was there. It was already partly done. It was not pushed further from the original contributors for different reasons. Sometimes it happened. People, of course, maybe change the employee or lose funding or whatever reason. They did not continue merging it. We needed to integrate with many parts of the asterisk, as I said. There are interesting choices in the asterisk regarding some interfaces, internal integration, in my opinion. So this makes it challenging sometimes to really integrate new functionality into the asterisk. It was really difficult to test because there were no good test clients, and the test clients also have bugs, and they are closed source, so you cannot fix these bugs so easy. So PJZip UA was really a blessing that we got it. But it has also bugs, unfortunately, but at least we can open a PR and hopefully fix it. As I mentioned, the testing was a challenge. We had also longer waiting phase, sometimes from our side, sometimes also from the asterisk part or asterisk project. And then there are multiple ways from the asterisk side how you can implement it. There are different bridging modes. There are different ways it can be worked with audio, without audio, these kind of things. And also asterisk changed their requirements from the PR side also several times, unfortunately. But now it works, as you can see here. Here I just did a test call a few days ago, and you see here tube audio, and there should be also type text here, exactly. So now it works. This is a simple bridging. It works also for native bridging. So from that side, we are quite happy now. About the status, the main PR is complete from our side, I believe. And we created also an automated test suite based on PJZip UA. This PR is not yet published. It needs to be a bit polished and a bit cleaned up because there are some test cases which are still failing, unfortunately. And then basically a lot of things are already working. Some of them are not working for some client issues. We have one bug in PJZip UA regarding an asymmetric codec issue. It's listed here on the top. And there's also one issue with asterisks regarding calls without audio, that there's no RTP in one direction anymore. I think this is probably a bug in an asterisk, but there are workarounds. You can just add an audio stream, for example, and then it will work. As I said, the native bridging and the simple bridging will work. We have done many test calls, automated and also, of course, manual with different clients. And we have interoperability with the different clients with T140, also with the RED. It will be, if one client doesn't support the RED, it will be also transcoded now. So it works quite well from that side. Sorry. For the PJZip UA issues, we opened some pull requests, some issue reports, some bug reports already. Pull requests maybe we need to do later. Haven't got any feedback yet from the project, but we will of course work with this open source project to get it addressed. And with the Asterix guys, we will also continue to work to finalize it and to merge it. And then hopefully it will be in Asterix 20, 21, 22. Yeah, that's the main one. And of course also in the master for the upcoming stable versions. Yes. Okay. For future work, as I said, we want to get the PR merged. Right now, again, we are waiting from the feedback from the Asterix side. PJZip UA, we need to wait also on the feedback there. And for the Asterix audio issues, we will create another issue as well in the Asterix bug tracker. And hopefully, of course, we will see it in production soon. And it will work great. Let's see. Great, thank you very much. That was my talk about that.
Okay, thank you, Henning. We have Lorenzo, you are the second. Just behind you was fraction of second faster.
Thank you for this session. It was quite informative. I have a couple of questions. One is how the deletions are communicated in the RTT.
Sorry, can you
deletions of the text, like when you type something and delete the text, right?
If you delete it, it will be like a control character, like a backspace, basically. It will transmit a backspace.
Oh, okay.
Yeah.
And another question is regarding the redundancy mechanism.
Mm-hmm.
Is it proactive or like the old RTP world, you have to send a PLC notification and request for a redundant packet?
Not sure if I got it correctly, but if the question was how this redundancy works, basically you need to decide at the session setup time, similar like we do an audio call, you decide I want to do G711, I want to do G7222, right? Similar, you decide I want to do plain T140 or T140 with the redundancy added. And then, of course, you can send a re-invite later to change it during the session, standard zip procedures. But you need to decide during session setup, and then it will be applied, and you get always the redundancy.
No, my question is more about how the if a text is lost or if a packet is lost, like you communicate that to a redundancy payload, right? So is it requested through a packet loss indication, or like it is proactive? It is along the stream the redundant data is transmitted.
No, it's not proactive, so there's no retransmission or something like that. It's RTP over UDP, right? So there's no retransmission. Of course, like from a reporting level, you get the XRTP, like the RTP statistics, of course. And on the other hand, basically, how this works is that you have the packets, and then you add multiple layers of redundancy to one packet and the next one and the next one, right? And then you hope basically from 3 packets, 1 gets through, and then you will be able to recover it. Yeah.
Okay, thank you. Thank you so much.
Hi. I'm not sure if you remember, a couple of years ago I presented something where I basically integrated in Janus basically the WebRTC side of things of exactly this. So basically
nice blog post. Thank you for it. Yeah.
But it was where you use data channels instead of RTP, and so I took care of that. But I encountered the same issues that you had, the lack of proper clients to do proper testing and so far. At the time, there was only TipCon available, which as you know is not really that. I mean, it implements stuff, but it's really basic in terms of stuff.
It has bugs as well, as I mentioned.
And for PJZip did not support it yet at the time, which is cool to have. So a couple of questions on that. So how advanced is the level of implementation of RTT there in case I wanted to experiment with that too for some testing? And aside from that, considering that you now have also an implementation and there are a lot of clients that are not available for whatever reason. So how open would you be to making some more interop testing? Because I'd like to revive that effort sooner or later. I just didn't have the chance to find any actual implementation that I could play with, basically.
It would be great I would be pretty happy to have like a test with Janus or whatever, right? To just have the Asterix talking with the Janus. This would be probably great to see and to do. We definitely should do it. About the PJZip UA, I think it's much better from a standard point of view. So like things that the TIPCon1 is not doing correctly, they do correctly. Also, there's some stuff that the PJZip UA does which TIPCon1 doesn't like because they just didn't implement it. So it's more stable. On the other hand, they didn't seem to speak the redundancy, the RED protocol yet. We haven't been able to really activate it. It seems to be a bit broken, but the main T140, it works reliable, and yeah, just from the user interface, I mean, you know the PJZip UA, right? You have this text client. Of course, you can use the Python libraries and whatever for testing, but if you use this C client, it's not that nice user experience. And of course, this TIPCon1, it's a bit better, but it works well.
Okay, 2 more questions. One was a hand here, and then Wolfgang, and then we have lunch break, and before lunch break, some announcements.
So very simple question, like why asterisk not free switch?
I mean, it was the customer uses asterisk. I mean, if there's some interest on the free switching side, we can look into it. Some other people can look into it, of course. Yeah, it was just the customer uses asterisk right now, and this is what we use also for internal reasons for some of our products. So this was a bit easier. Yeah. Okay.
Yeah, Henning, thanks for that presentation, and it's great to see that things are getting implemented. I was talking about real-time text, I think, years ago. And my question is, do you have any experience with mobile devices?
Yes.
And do you see any differences in their behavior on creating bubbles on the user interface, things like that? And just before you answer, very important information, there is a ETSI plug test event taking place end of May, and that would be a great chance to test with mobile network operators and devices the real-time text.
Okay, great. We should talk about that, of course, later. About the mobile phones, unfortunately, I was not able to test it firsthand, but there were some people in this long PR that reported that it actually works with mobile phones in some earlier states already, so I think it should still work. I think that some people tested it with some Samsung Android phones, and it was working okay. It was working great. There are some issues. Actually, I just contacted one of the reporter some days ago. There were some issues, for example, when you have a re-invite and you add or remove the text capability, and then the other side doesn't really like it. How to basically do the negotiation in these cases. But in the end, it boils down a bit to testing, and then maybe some proper parameter on the asterisk side. Yeah.
Okay, thank you.
Thank you
once again for all the contributions so far. Just don't.
To demonstrate something that's exciting, educational, energizing, anything you like, possibly with a little bit of danger in, something that you want to share with everybody else in the audience. It's only 3 minutes, and the timings are ruthlessly controlled. So it's 3 minutes worth of total fear, but well worth doing. Because the prizes look a bit like this. So this is an exclusive lead crystal 3D engraved trophy, very sought after. To get one of these at Kamailio World means that you're good. So I'd like anybody who's willing to have a go, come and find me. I'll be around today and tomorrow. The actual competition will be last thing tomorrow. Sign up for your 3 minutes. Yes?
What about the prize categories, James?
So we're running a slightly reduced number of categories because we've this year, because we've got compressed time. So there are only going to be 2 prizes this year, not the normal 4. Normally we do a full dangerous demos, which is over an hour long. This time we've got to try and compact everything down into half an hour, which is kind of mission impossible if you know me. So we're only going to be running 8 slots for this. And there will only be 2 prizes. One is the overall big prize, but then we have the much sought after crash and burn prize, which is the one that goes to the demonstration that goes most horribly wrong in a spectacular way. So just 2 prizes this year. Okay?
Okay, thank you, James. So now let's start with the other prizes or giveaways. I have a Kamailio engraved, beer. So some of them will be given tomorrow for those that enroll in this code challenge. So if you want one and increase your chances, Marcus, Andreas are your contacts here. But now let's ask, okay, Ramona is next to me here. And I know she picks me, so you have to choose someone, don't look inside. So I have Akash Gupta. I hope you enjoy beer. And for the, it doesn't drink, okay, for you, okay. And then again, we have Snom as partner and supporter. Some devices are still on the way, some delays, but Jan here, it's with us, will come more devices. I will go to him. So the first one, which is like a speaker, I think, will be selected. You just. He drew himself. So you see everyone. Okay. So we have Lubomir Yatansky. It's there. Okay. Thank you. Okay, so this is you. It's like a speaker phone for conferences, probably. Okay, and let's do one more. That's from the last year for the wine lovers. You might have troubles with the airplane if you just have carry on. So, engrave, Kamailio. So, who is going to select himself this time? Okay, I'm going for another woman. Here, you choose the winner, so they blame you, not me. Evgeny Rami. First time, long time coming, but it's good that you are not with carry on. I know you had check-in baggage. He lives in Berlin. Yeah. Okay, so now we go for the lunch again. We still have this stuff. A couple of them. Code challenge would be where you have the chances, and maybe also dangerous demo. The third, let's say, community prize. We can keep one for that moment. And For those that are new here, the lunch, it's in the breakfast area. If you have the breakfast, if not, just go over the receptions, and should be like a buffet with after like 1:30. Thank you, everyone. let's say, deployment by, discovering early, before they get to you, some attackers' sources, let's say. So, Fred, thank you again for coming, taking a long journey from USA. Not the same weather like Florida, but still good enough for Berlin. Thank you again. The floor is yours.
Thank you. It's awesome to be here. This is my favorite conference and my favorite place to be. So it's great to be here with all of you today. Today's presentation is APIBan and Kamailio. So the agenda I'm hoping for is who am I? That will be extremely quick. What is APIBan? What's new with APIBan? APIBan clients and tools. Integration with Kamailio. And then questions, ask me anything. And then for our trivia today, and I'll do the David Duffy. Does this agenda sound good for everyone? All right, great. Okay, anybody know who that is? Anybody old enough? That is Rowdy Rodney Piper, who came up with a great phrase of, I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum. All right, so let's do it. Who am I? I'm Fred. No, I'm based out of the United States. I consult with LOD.com and former baker with my beautiful wife up there. That's our daughter. You can see her running around. You can contact me through fred.tel, and I helped found APIBan in 2020. So what is APIBan? APIBan is a free service to help prevent unwanted traffic to your systems. Okay, and it's free thanks to our generous sponsors. We started in 2020, and it started from conversations that we had here at Kamailio World. At one point I was thinking about doing something with DMQ to, we're all getting attacked by these similar IP addresses. How can we share information to keep ourselves from being blocked? I was also originally going to use just HTable and see how I could do it within Kamailio. And I spent a good couple days on that, and I decided that there's really no reason to reinvent the wheel. I could, but much like Jurassic Park, just because I could doesn't mean I should. So I decided to instead deploy something based on this. APIBan sits at the LOD data center, and we have behind an F5 a couple HTTPS nodes that then connect to a Sentinel cluster to gather information in real time, try to keep things as quick as possible. And then for long-term data and storage, we use a Galera cluster. So it's pretty simple. The API itself is written in Go. We have an API reference for you if you wanted to connect, because basically all we are is an API that tells you if an address is bad or good. We collect these IPs by honeypots located throughout the world. If an IP hits a honeypot, it stays active for 7 days. That's an arbitrary number that we made up. I like it, and it sticks. All right, and then many IPs are relisted within minutes of becoming inactive. So, it's good to just keep it up there. It does SIP, so we listen on UDP, TCP, TLS, TCP, and now we also do HTTP and S to help with free PBX and some of those phone provisioners out there. That was a change requested by one of our sponsors, which is, hello, thank you guys very much. It's a free service because of our generous sponsors. All you have to do is get to the website, you get a free API key. NetSapiens, Jambones, Clearly IP, LOD, those are the big sponsors now. Huge shout out to Ivan, who moved, he's right back there. And you can visit his website at quanlabs.com. Ivan helped us with many honeypots in the past and current, as well as, I think it's almost 2 years ago at this point. Ivan goes through and analyzes traffic here and there, and he found an amazing proxy registration attack that was just a wonderful exploit that Sandro even helped us try to figure out. Asipto helped sponsor us and integrated it through CAM-CLI, and we have GitHub sponsors. Ben Kaufman, Jose Franco are current ones. In the past, we've had generous sponsors from like SIPFront and things like that. Last year, we blocked 83,466 IPv4s. Okay, we blocked 0 IPv6. We didn't get hit by a single one. 2026 might be our year. Of those that were blocked in 2025, 16,000, give or take, were brand new IPs for us just last year. Brand new. For on the HTTP side, 111,457 IPs blocked. So we can block them or you can get hit by them, one of the two. So what's new with APIBan? We added a flush after feature. It's like third down there. It's my favorite. All right, so like I said, we have a feature that says an IP is active for 7 days. If you are using our APIBan client, which we'll get to in a minute, you would automatically flush the cache of your IP addresses every 7 days. Now you can choose to keep that period longer. Like I said, some of these are updated within minutes. If you want, you can keep them 30 days, 45 days, however long you want. You can change that. So that's a setting. The default, again, is 1 week, but you could go shorter or longer, however you want. Choice is yours. Uptime is a new feature for when you reboot your system. It now says, oh, okay, I've been rebooted. Let me go ahead and pull the entire list again. Otherwise, it's just getting the ones from the last time it got. So uptime is really useful when the system is rebooted. We support YAML, or however it's spoken. Our configs had always been in JSON, or JSON. And we added an NF tables client because, as you saw, some of those IP address numbers that we had are absolutely enormous. I joked years and years ago that I wanted to retire before IPv6 became a thing. I really hoped I'd never have to do anything with NF tables, but I actually love it now. I'm really happy with NF tables. Everyone should switch. It's great. But NF tables client, and we also created a local API so that you can manage your own NF tables entries via HTTP. So speaking of those clients, the clients that we have with APIBan, the first one I want to bring up is APIBan client NF tables. All of our software is that, and it's a generous term to call what we make software, but if you go to APIBan on GitHub, it's written in Golang, so you can build it yourself, or we have it compiled for you. You get to choose your data set, SIP, HTTP, or both. It's called all. It's documented right there in the README. It tried to be as good as any open source README is. You can add to a set in NF tables, and what I love about the way that we use NF tables here is that it's going to block both incoming and outgoing to that IP. So you're not going to send anything to the outgoing IP as well. Simple install script through Bash, or you can build it yourself. The original one was API Client Go, and that's just basically the same thing, but for IP tables. There are so many active IPs now. So generally, you're looking at thousands of active IPs. So especially if you're going to use a data set of all, of HTTP and SIP, I really recommend that you go to NF tables. It just, for the rebuild of it, it handles huge data sets of IPs much more efficiently than IP tables, is what it comes down to. And it's all about saving your CPU for handling real-time communication. We have a Bash client. This one hasn't been updated in a long time, but you can use it for IP tables or NF tables. It's an old client. It's written in Bash. You can do whatever you want with it. It's ugly and it works. We've made some Go libraries to help people. So we have a Go library for APIBan commands. So if you wanted to build your own Go application and just use some of our polls and things like that, you can just use that library. It's not well documented, but it's there. And we also have a library for dealing with NF tables for adding and creating data sets, creating filters, things like that. There's an APIBan fail to ban integration. This was designed mostly for people running like FreePBX or something like that, which people in this room might not run, but your clients definitely do, right? So you could give them this and it will just integrate with their fail to ban. So whatever they're running, if they're running NF tables, IP tables, whatever, it just integrates right with the fail to ban. It defaults to asterisk, which is the FreePBX jail, right? But you can change that as you wish. It's really simple to do. And the last software I want to touch base on is NF Tables API. And this is that local HTTP API for adding or removing IPs through NF tables. And it supports IPv6, IPv4. It can do add, remove, flush, and it has multiple ways of doing it, because my whole problem with fail to ban was that I could never remember how to remove an IP. And when you have to remove it, you're already in a stress, and it was just so, here if you send it block, it's going to block it. If you send it add, it's going to add it. It's block IP, it's going to block it. It just tries to figure out what we're doing and just does it. And then I think Dan Jenkins pushed me where if you do a push, it adds it as well. But so it's a fun little API. It's well documented on GitHub there. But let's talk about Kamailio. So the reason that APIBan exists is because we're all into real-time communications, right? And it's gotten so bad out there that we all joke about it probably when we load up a system that you load it up and you can immediately start seeing traffic, right? So, I mean, it's actually one of the great things now about just testing to see if you're connected to the internet, right? There's a couple ways we can approach life. So if we're in a smaller providing circle, maybe we just allow list IPs, right? So we, by default, block everything, and then we only allow the certain ones in. That would be great. But in reality, if we're selling to customers that might have dynamic IPs or something like that, or can't do VPN or anything, in reality, we're probably going to be open to the internet, and we have to deal with it. APIBan will not block targeted attacks against you. So if you're out there and you're attracting attention, people are going to find you. What APIBan does is it goes against the scanners, which is what we're seeing a lot of traffic, just going and finding the scanners, listing you in certain areas, and then, oh, okay, look, I found this, I found a password, now let me send it to someone else to do the full attack. Skipping that first step helps you a lot in getting the second attack. But APIBan itself is just, preventing the scripting and the honeypot attacks. With Kamailio, there's generally 4 different ways to integrate. One is CAMCLI. Viktor probably has the neatest use I've seen of that. You can use APIBan clients, which is what I really recommend. You can also use the Kamailio config, which is awesome, and you can also do a hybrid approach there. And you can use Chemi. I'm not going to talk about Chemi, but basically Chemi, you can use, if you're running your scripts in Python or whatever you want, your config, then just do an API calling however you want. You do your own API and you handle it there. That's the beauty of Chemi, right? CAMCLI is Python. It gets installed, I believe, by default now. You can run a check, a load, which loads all the records into HTable. You can check a specific IP address, and you can also show the IP addresses that are listed in HTable. So you can run some sort of cron job or something that automatically loads records into HTable and just let APIBan within your config handle it that way. So that's one way of using CAM-CLI. I really like the APIBan clients, and here's my main reason for doing it. Okay, so we all love talking about the OSI layers, right? That's our favorite thing to do, other than telling SIP jokes, right? So Kamailio runs in layer 7, right? It's software. So if I'm checking each IP, I'm taking away CPU that I could be using to handle real-time communication. And as I like to hammer to any of the deployments I do, I want all CPU possible for Kamailio. And when it uses more than 1%, I'm getting scared. But you know, I want it to have all the CPU. I also want it to use none of the CPU. So IP tables runs in layer 3 and 4. It's just more efficient. The kernel's doing it. NF tables basically runs in 3 and 4. There's a way of doing it in 2. I'm not an expert on that. But it's also much more efficient. So I did a sustained attack, and I did that, I think, a few years ago. I showed the difference. But if I did a sustained attack at, let's say, 1,000 per second, even if I was blocking it in H table, so I wasn't doing an API lookup all the time, but I was using Kamailio to just exit, I'm running 10% CPU at 1,000 calls per second or something. If I was using IP tables or NF tables, it's negligible. You know, almost nothing. It's just happening in the kernel, and it's very, very efficient. So significantly reduced CPU under heavy load. And NF tables is excellent for these large address pools, right? I don't have to say, okay, I need an H table that can support, you know, 40,000 IPs or something. I'm going to give you some examples that I like to do for configuration. They're also on the APIBan website, so don't worry about writing them down. We could just go over them. I also have these slides online, and there'll be a link there. The big too long didn't read is the default Kamailio max while loops, I think, is either 100 or, yeah, I think it's 100. You want to increase that to 600 because APIBan looks for IPs in batches of 600. So if you don't increase your max whiles loops, you're only going to get the first sixth of the, and it's just not going to work. So you increase max while loops to 600, and then basically we can accomplish it with as simple as 3 modules, HTTP client to get the API info, Jansen to parse the JSON, or JSON if you'd rather do it that way. You know, we have over a few hundred modules for you to choose the one that fits you best. And then our timer so that you could say, okay, every 4 minutes I want to go ahead and check for new IPs. So this would, and there's where the top in bold has where I have these slides, so you can just grab the config there. But I'll choose the middle one here. In the beginning, I'm setting for an H table. I'm just saying, okay, I want an APIBan H table to store all the IPs. I'm going to make it a size 14, which should cover everything, and 60,000 or 604,800 is 7 days. And so I'm going to automatically expire them after 7 days. I'm also going to keep a control which has the ID of the last IP I grabbed. So I'm going to then set our timer to look every 5 minutes or 300 seconds, and I'm going to put that in a context called APIBan. So my route APIBan just grabs my key, goes to the API, pulls from the last ID, and adds it to the H table. So basically all this is doing is saying, I'm just going to parse through the JSON. As long as I'm more than 0, then I'm going to go through. If at the end of everything, if I haven't reached 0, then I'm going to go ahead and check it again. And then somewhere in your code, if the source IP is in APIBan, then exit. You know, it's that simple. You can even keep count of how many blocks you're doing or something like that. And then if anyone's used mod init from H table, you can preload that route whenever you start Kamailio. So as soon as Kamailio starts, you load the IPs. All that being said, The fact remains that the NFT client provides better performance, especially if you're under attack. Now, the NFT tables API that I talked about before, I love integrating this with Kamailio. This is my favorite part, because as I said, the APIBan is getting the general attacks out there, right? Things that are hitting the honeypot. But if someone is directly attacking you, it really helps to block that, not within just Kamailio, but maybe at the kernel level itself. And that's where this NF tables API came out. So with this API, we get incredible flexibility. You can block anything, you know, block it by user agent, account, country, whatever you want. If something fails the core parser, you get, as famous like 4 or 5 years ago, someone was sending DNS to your port 5060 there. You know, you can say, okay, well, someone's attacking me with DNS, let me block them. You can do slow registration attacks. When they hit a certain threshold, block them. And this is how we can definitely keep out bad traffic at the kernel. And so it's one of my favorite implementations. So let's first talk about the core parser. So this is right part of the core module. You get a core receive parse error event route. So what I would do is normally, it's something as simple as here. If I have something that triggers that event, then I'm going to go to my block IP route. Okay, and this is what my block IP route might look like. So as the example is, I'm not going to block myself. Let's say it's my local media server. You know, again, this is just an example. Or anything that I have as specific allowed IPs I don't want to block. As long as it's not one of those, I might do a log notice. I'm going to set my APIBan to that IP, set it to 1. This one's using client async. I'm then going to go to block IP is the one I chose there, and then it's blocking it. So now I've blocked that IP in the kernel. For extra credit, you could do whatever you wanted for your expiration term. So let's say your APIBan was 2 hours or 2 minutes, whatever you want. When it expires, you can automatically remove that IP from being blocked. So you could dynamically add it and remove it. You don't have to leave something as permanently blocked. And so this one will do that, and it will also log, in this example at the info level, that it removed that IP. For slow attacks, I just flat out stole this from Daniel. A few years ago, he showed a way of checking for slow attacks. And for this example, we're doing it in 30 minutes. If they try, a bad password every, 5 times within 30 minutes, I'm blocking them. It's that simple. So this, again, I modified it a little bit, but it's basically just flat out stolen. And that's on the website as well. Or you could do whatever you want. If it exceeds your Pike module, do it. For user agent, I've specifically called out Sandro, as well as friendly scanner. And then SQL inject, things like that. So have fun. You can do whatever you want. If you don't like PJ SIP, block it in the user agent, however you want, And that brings us to the questions part. Again, I just want to say how happy I am to be part of this community. Thank you all for supporting Kamailio and everything that you do. This community means the world to me, and I'm so glad and honored to be here today. Thank you. Looks like Tori was first. I think Tori was.
Tori. Oh, I still don't have my back eyes.
Hi. I actually have 2 questions, if that's allowed. The first question,
We currently use the APIBan in the HTable method, and one of the things we like is as in your example, doing a count to see how much traffic's actually blocked, but also keeping track of how much per IP address traffic blocked, so then we can know if we accidentally blocked an important customer or something like that. I was wondering, is there a good way I think with IP tables, there's a way for a chain the number of times it's invoked. Is there a way to get similar counting stats from the NFS tables?
Yes. The flat out answer is yes. It's just putting a count in there. The default way that this chain gets added doesn't do it, but even just you bring that up means that I have to add it. So I'll add a method of adding a flag where you can add the count method so that you could, so that the data set will show you how many times an IP has been hit.
And you showed another example where you were having the H table, and then it was syncing via the API, NFT API to the to the NF tables. And the thing that comes to mind is, and then you're doing the cleanup. But what happens if you restart Kamailio? So you lose the H table. What do you do in that case?
So that's a great question. I'm sure everyone heard because he's mic'd. Normally when in that mod init, if I'm running NF table API, I'll start off with a flush. So there's a flush command that you could send, and that flush command will allow you to to just empty out both the IPv4 and the IPv6 tables.
Okay, one more question and then two. Okay, two. And then we go to the next presentation.
Thank you for the session. I have a basic question. So in our ETSI world, the real endpoint which is attacking, right? The IP that you receive may not represent the actual endpoint's IP, right? So an entire office or an entire building may be behind that particular IP. So how intelligent is the APIBan to block such kind of attacks, which comes from a natted or a turn server IP?
Yeah, so I guess this would be, can everybody hear me if I talk this? I think I lost my mic or something. If, I guess spoofing is the question, like how do you handle spoofing? You know, I really don't see spoofing that much, especially on UDP. It's been very difficult to see it make it to a Kamailio instance that traverses the public internet. It's not impossible, but it is, right? So I still like the source IP method because, again, I don't see spoofing that often. But there are ways in Kamailio. If you looked at some of the tutorials, I think even the default config might have a spoofing example. And when I do see spoofing, I'm blocking anyway, and I'm not letting that go through to begin with. But spoofing, generally, I would want to see handled on like a router or the OS.
Okay, like last quick question.
So I will just add on to his question. If Kamailio is running behind the load balancer, Kamailio won't be seeing the actual source IP. Does NF table will help in that place also?
Yeah, so if you're running it behind a load balancer, you know, I'm not a huge fan because I consider Kamailio the better load balancer there. So I generally don't, but if you are running it through a load balancer, then you're probably not going to be able to use the client, and you would have to use the HTable method or Kamailio itself, and then go for either whether it's an X header that the load balancer is adding or something within the VIA or something like that.
Okay, thank you, Fred.
Thank you all.
You can find him today, tomorrow for further. The floor is yours. Doesn't look good. Can you unplug it again and put it?
Can try with USB-C.
One second.
Okay. Looks good.
Thank you, Daniel,
Thank you,
for
Viktor.
introduction. Yeah. Thank you for having me here. My talk will be about the DMQ again, like the past year. I start from my name. My name is Viktor, and I am originally from Ukraine. And I really said that I should repeat my words from the last year. Please support Ukraine. War is still going. Now I'm living in Spain and working with a Netophone. But this talk will be made my own. It's not related to the Netophone and to my work there. So quick reminder, what is the KDMQ, this Kamailio distributed message queue. It uses SIP as a transport. It used like SIP message, special SIP method that's called KDMQ. There are three main things in each DMQ message. It's a node. There are always two nodes, like source and destination, peer, that you can see as a user in the SIP message. It will be all users, from to in request URI. And the data that you will see as a body. There are now currently supported two types of bodies. It's JSON and plain text. Plain text is used only in one place for the notification peer. So there are 5 modules that currently support the DMQ. It's user allocation, presence, hash table, RTP engine, and dialog. And also you can replicate any data you want from the script. So DMQ works well. I'm using it, we are using it, I think someone else uses it, but nothing is perfect. So what we can improve in the Kamailio distributed message queue? So again, DMQ is a SIP with all pros and cons, and what if it will not use SIP? But how? I implemented 2 new functions for DMQ model. It's called DMQ handle custom and DMQ process custom. The difference between them that one of them handle the message at the same process, and another one send it to the queue that taken, and this queue is like working on another processes by the DMQ model itself. So using these functions and the event route local request, you can stop to use SIP to send in data. This is the syntax of these new functions. What we have there only 4 parameters, like the peer name, node, that is SIP URI, body, that's any body, and the content type, again, plain text or application JSON, because there are only 2 currently supported data. This is a small example how you can use it. You need like only 3 models and 1 more model that you will use the data from what model you will replicate. And my example is HTable. Using DMQ transaction and table model and nuts, that is like the generally used message queue. My example is not, but you can use Rabbit, you can use Kafka, you can use like every you want, like even HTTP Like it's and what is done there, like the event route, not such stable. This is event route when like that is fired when we are receiving some data from NATs. So we are separated for some queue or for some topic. I'm not sure how it's called in NATs. When we're receiving the data, we just handle this data. There's some just JSON data. No need, like we are subscribing to the H-table topic, receiving data about the H-table, and that's it. In an event route, local request that is fired when some local request created, we are filtering by KDMQ method and especially by the user H-table, because we are interested only in H-tables here. We're just doing publishing this data, and we are doing drop. It's really important. You need to drop this message if you don't want for this message to be sent via SIP. But at the same time, you can check the returned value of NATS publish function, and if there is some issue or problem with publishing this data, you can fall back to SIP, and you can still you will have two ways to replicate your data, using the message queue or using the old one, SIP. So this is the fallback. And one more thing that I want to highlight, that DMQ, like everyone who use DMQ, they use it for replicating data from Kamailio to another Kamailio, between Kamailio instances. But what I'm proposing you to do here, using this simple code, is to share data from Kamailio to any other application you want. Like every backend developer, web developer, call them how you want, they know how to use Kafka or Rabbit. And probably in your product or a product where you're involved, there is already some message queue. For example, in my practice, we have a task, really common task. We want to share the registration data. And what we are doing now, we are publishing this data when we are receiving some registration. But then we found that when the registration is expired, we don't know about this and we not replicate this data. So we need to add it in one more place. Then we understand that when TCP connection is closed by the client, we are deleting this location from user location, but we are not replicating. And we added one more. What you can do with DMQ, you don't need to replicate it between Kamailios, but you can use the DMQ model to share the data with your web application using, again, Rabbit, Kafka, any MQTT, for example. So this is the main thing, that it's not only can be used not only to replicate the data between different Kamailio model instances or nodes, you can use it to replicate data between your web application and Kamailio. And this is the general way, I would say it like this, because you can handle any data for any model that supports DMQ. Is it presence or user location? The way is the same, always. You only need the two routes, that's it. Just enable DMQ for your model. So, but what if you back to SIP and using DMQ over SIP? So there are few things that should be improved. There are 4 of them. I described them as 4, the memory consumption and performance, cluster management and versioning, data synchronization, and conflict resolution. Let's go one by one. First one, memory consumption and performance. DMQ is a SIP. It's SIP. We know that Kamailio works perfectly with a SIP. We know that. But it's SIP. And originally, for each DMQ message that are sending, DMQ model create a transaction. And you know that creating a transaction is a bit hard operation. You need to take a memory for it. You should fire some timer and check the status of this transaction, etc., etc., etc. So, what is the solution? Like, but do we need this state? Do we need the transaction for each message? I think no. Only model where, like, only peer or model that is needed for the transaction is notification peer. Notification peer is the peer of DMQ model itself, and it's used to manage the cluster. So ended up that sending the messages statefully, so with the transaction, makes sense only for the messages that has the custom callback. It means that I care about the response. And for now, this is only notification peer. For any other messages, we can send it without any transaction, without creating the transaction. So the new parameter was added. It's called SL send. It's the DMQ parameter. You just set it to something that not equal to 0, and that's it. And you are sending almost everything in stateless, without any transaction. But again, like, to be sure that the data was sent and received by any other node, you can simply use TCP. You don't need any transaction, anything. You use TCP, and that's it. Just connect all your instances using the TCP and send data statelessly. And there are something that should be improved still, like there always something. And this is like the DMQ model main loop, because it's busy loop. It's something that Daniel talked about earlier, and this is especially critical for ARM64. There was something already done for ARM64, but we still missed one part for this DMQ model. Let's go to the second topic that should be improved. This is the cluster management and versioning. And what was done, 2 new RPC commands was added. Right now there was only 2 commands: delete node from the cluster list, node list, and show node list. So I added 2 new commands: add, so just to add a new node to the cluster, and change status for the node that is there already in the list. Also, by my colleague Stefan, we added the parameter DMQ peer ID. This parameter was added for each model that use DMQ. And why we need it? So there was already a notification channel parameter, and it was like, this is parameter of the DMQ model, and it was really useful to isolate different nodes in the cluster. Like, you can have different notification channel for one part of the cluster and for another, and they will not communicate with each other, like never, because like the notification channel is different. But what if we want to isolate like newly deployed version of application, or the newly deployed Kamailios that has like some not backward compatible changes? We can change the same DMQ peer ID as the notification channel, but for specific model. For example, if you updated your Kamailio and you know that in a user allocation model, the data structure for the DMQ changed, you just manually change the DMQ peer ID. I think this is the example. Sorry, move it a bit, but like you can set the version, we call it version, but it's like DMQ peer ID. It can be any string. Again, it's just a user in a SIP message. So this is the ID and that you can set for each model, and this give us a way to manipulate the different version of the cluster, or even like different parts. For example, if you are deploying our cluster in a few different regions, and we, for example, want to share only user location between all of them, but not, for example, RTP engine data or presence, like we just set in the presence, and RTP engine we set DMQ peer ID to be region specific, something like presence, I don't know, US East 1, for example. Then we can be sure that this presence will be not shared with nodes that are in US East 2 or US West, in any other region. And again, there are stuff that should be improved and can be improved. The notification peer design, I think it should be redesigned, but it's pretty difficult. Like I already told, the notification peer is only peer that use plain text still. Any other model they're using JSON. And the notification peer always have like the same body, like just a list of CPURIs, that's it. There is no commands or actions, as them call it in any other model that use DMQ. Like, we need to discuss what we should do this. And especially, I think that especially it should be designed from the beginning with understanding that we are using this. We can use this with again, like Rabbit, Kafka, or other stuff, because notification peer can be also and should be replicated with Kafka or other message broker. Data synchronization. Almost every model that supports DMQ has this sync action. Again, notification peer doesn't have any actions. So any other model that share the data has this action, but this is something that was missed for RTP engine and was added by another my colleague, Vladislav. There was, I won't say this was the problem, but this was like by design, and there was a question last year about this. By default and by design, when new node become available in the cluster, it starts to synchronize it with all the nodes in the cluster, with each of the nodes. But like, should it? Like, do we need this? Because if with the cluster is everything fine, then like each node has all the status of the cluster. And you need to just synchronize with a single node. So this synchronization is something that is done on initialization of the Kamailio. So this option init with single was added, and it is already in master, so you can try to use it. What else can be done with the sync? So the sync process itself should be improved, definitely. Right now, synchronization done only when you are spinning up a new node, and like on the start of Kamailio, I would say like this. So if one of the nodes in the cluster will temporarily like lose the connectivity with any other node or with all other nodes at the same time, then like we don't have any callback, any way to do the synchronization. Only way to do the synchronization is restart Kamailio, but this is something that we don't want to do. So the idea is to add one more callback that will be fired on status change. There is also like advanced sync process that can be discussed later. Conflict resolution, and I have like the easiest way to resolve the conflict is last write win. This is something that was done by Stefan, that sit there, and it's done only for user location and present models right now because they has all needed data for this. And like in the future, what we should do, we should add this to all other models, but they are not right now. They don't have only the data. That's it. Thank you for flying Kamailio.
Thank you, Viktor. So we start to run a bit late, but let's have a quick question if someone wants to ask about DMQ until Ramona is setting up. We have Tori.
So you showed how you can take a KDMQ message and then turn it into a NAT and stuff. Have you given any thought of trying to do the reverse? So say like consuming events from Kafka and then turning that.
Hold on. Exactly. This NATs table.
Okay, so the DMQ handle custom will take that care of the reverse direction. Okay.
Yeah. So you are receiving the data from the same topic, but from other nodes or from any other application, and handle this data. And it's automatically like handle it as a DMQ message, but it's not true SIP DMQ message, but it updates all needed structures inside the Kamailio, inside the cache.
Okay, nice. Thank you, Viktor. Thank you again also for the other contributions.
Daniel for the introduction. Yeah, so I'm Ramona Modroiu. I know many of you, but also many of you I don't know yet. I try to put the microphone a bit better here. Okay. My presentation today is about sharing with you a few insights that we got during a recent experiment we conducted with our research team at TU Berlin, but also with the research team at RPTU, Rheinland-Pfälzische Technische Universitat in Kaiserslautern. We came to join our forces in a large German research project called OpenCG Hub, funded by the Federal Ministry of Research and Education in Germany. And yeah, we had completely different backgrounds. The research team in Kaiserslautern is mainly on AI, but for 5G towards 6G. And at TU Berlin, we are on the edge, RAN, core network, application layer continuum focused. At TU Berlin, we are working mainly with open source projects. At in Kaiserslautern, they have other setups. And we had the chance to have to be able to build several setups of a 5G private network, and then we came to build some joint demonstrators. And therefore, the idea, let's see what each team can do and how we can have a nice demonstrator for real life, for agriculture. I've lost my microphone. This work, the results were put in a scientific paper that was submitted and accepted to an IEEE conference that will happen in July in Italy. And I'm very happy because it's going to be in Cagliari, and I think we have somebody here in the room from Cagliari, so I can pay him a visit, to Giacomo in 1 month or so. Let's go through the paper quickly. We don't have too much time, but I'm going to give shortly the main ideas. So what was our motivation? What was the background? We will see the 2 test beds. We will see the experimental methodology that we used, the metrics that we measured, call setup time, and quality models for estimating the quality of the calls, and then several conclusions and future work directions. So our motivation was that we have a problem. We have now private 5G networks, and these private 5G networks are not carrier grade, are small networks with 100, 200, let's say 500 users. And if we want to add voice services, voice audio, multimedia services, well, IMS, that is the native 5G voice services for, that rely on, would be overkilling. So it's come with prohibitive costs, and also operating such a system is not trivial given the complexity. So we said, okay, for these use cases, for this special case, better said, let's look at pure VoIP and see if we integrate the Kamailio RTP engine and LinPhone or BearSIP. We get a non-3GPP IMS alternative, but it's a growing relevance because it comes with reduced cost and architectural simplicity. You can deploy it centrally, locally, how you want. We will see in the architectures that come on the next slides. It's a rapid deployment, it's open source, low cost. And we spotted that the performance in private 5G networks of such audio and voice services remains insufficiently characterized. Therefore, with this paper, we addressed a gap. And shortly about the testbeds that we built, we have the one in Kaiserslautern, which is based on commercial software stack for RAN and core. And we have, in this case, a part of the communication platform, SIP and RTP engine that resides in the cloud. Everything is locally, so the UPF and the core are locally deployed. The testbed in Berlin, it's a bit more distributed. We wanted this on purpose. We have the RAN, of course, locally, but the UPF and the core are on a cloud server, and the SIP platform is on another cloud server, which it was the same use, so we used the same SIP platform deployment for both testbeds. So do not think it's a comparison between commercial and open source implementation software. It's not. It was not our intention. Our intention was to give an idea what kind of performances we can achieve with private 5G networks that already exist with their own architecture. We cannot compare the both because the architecture is different. The deployment sites of the keynotes are different. Just for orientation, we are working here with cloud servers, and they are located in Falkenstein, Germany, or in Nuremberg. And then we have the distance Berlin, Falkenstein, Berlin, Nuremberg, and then Kaiserslautern. Falkenstein, that comes of importance, is just an idea. We haven't acribically looked at the latency that they introduced.
You lost the microphone again.
I lost the microphone again. It's here. I think I have to put it better. Yeah. And let's look better on my computer. As I said, we have Maxware commercial implementation of a 5G RAN and core located on campus in Kaiserslautern. We have UEs that we realized with Latte Panda Delta 3. It's a single board computer similar to Raspberry Pi, but it's more performant, and we paired it with the Quectel 5G modem to transform it in a UE, 5G UE. And on this computer, we run Ubuntu and Linphone for the over-the-top SIP app. We had Kamailio and RTP engine on the public cloud, and after we conducted the experiment, we noticed that for the calls, the codecs that were chosen by Linphone were VP8 for video and Opus for audio. The others are details how the NAT was done. In this case, it was a bit special because all the phones got the same IP and port visible from the outside, but still the core worked. So, but this was nothing that we were able to touch. So these test beds come with some constraints. On infrastructure, we are not allowed to go at which level we wanted. So therefore, the architecture are different because we deal with integration here between two different research teams, two different universities, architectures, and so network architectures. And the test bed in Berlin is based only on open source stacks. SRS-RAN was chosen for this experiment, Open5GS, Kamailio and RTP engine. We had to use WireGuard for the communication between the G-Node B and the core network to have SCTP over the public internet possible. And we used for UEs Nokia X30 smartphones, on which we run Linphone, and after placing the calls, we noticed that Linphone was choosing for a video the H.265 codec and for audio the Opus. A bit more details. We have the left half of the picture is the private 5G network without going into the details. We just show the UEs and how they are seen by the cloud server where Kamailio SIP server is running and where we capture the traffic. And we highlighted here that, we got the same port for an IP, public IP for the UEs, but it was not an issue just for SIP grep that was discarding one of the RTP streams, but it was just a display issue. Actually, the call was going on correctly. The experimental methodology. So we had to launch 20 consecutive calls per testbed, each call 90 seconds. We did this for having a statistical meaning and making an average. The SIP RTP traffic was captured with S and grep, SIP and grep on the server running Kamailio and RTP engine, and we define metrics, the call setup time, which is the time between the SIP invite and the 180 ringing SIP message. And for the quality of the calls, we were looking this time not simply at jitter and packet loss. We computed MOS, mean opinion score, which is actually a subjective metric, and we should evaluate this metric taking let's say 50, 100 persons listening to the calls and grading the quality from 1 to 5, 5 excellent. But we can avoid this time-consuming study using some mathematical models that ITU defined, and there is this G.1071.1 for evaluating the audio RTP streams, and there is another model also from ITU, G.1070, for evaluating video RTP streams. I'm not going to go into details what these models are. They are not easy to understand in a few minutes, but they are very well defined. You can find plenty of information. The main idea is that you can use them to have this metric that captures the quality of the calls. Yeah. So our results that we got, in the case of the testbed in Kaiserslautern, we got a call setup time of 0.17 seconds, and for TUB 0.45. Of course, they are different because TUB has to travel around Germany between the cloud servers. But the main takeaway here, both values are below the 3GPP ETSI call setup thresholds, far below. So we are doing wonderful. Just to remember, with some results we got 1 year earlier, when I presented last year here, we were comparing a bit voice over new radio and OTT, and I summarized these results. For example, in the previous paper, we had this local scenario and distributed scenario, where we had a local scenario means everything runs on a laptop, yeah? Quicker than this, I don't think it gets. And we had for OTT a call setup of 0.06 seconds. And then we distributed a bit. We put Kamailio and RTP engine and the core in the cloud, and we got 0.09 seconds with the cloud server that we chose, so the distance that we had at the time, which actually it was the same. It was to Nuremberg. And the last two setups are this from this year, RPTU and TUB, and we see that if we opt for a local UPF, but we have the entire core local, and the cloud Kamailio, okay, with a commercial stack for RAN and a commercial version of stack for RAN and core, we got 0.17 seconds, and for TUB we got 0.45. So just to have an idea how these values compare to each other. And then we went further to evaluate this MOS, mean opinion score, and we obtained for audio, for Opus, codec, MOS of 4.01, which means consistently good. And for video, in the case of TUB testbed, because of this H.265 codec, we got a bit better value for 7.96, which means good to excellent, and for RPTU, not bad at all, 4.27, but with another codec, VP8, for video. And further, we were looking at MOS versus RTP packet loss, and we saw that, for example, even with a packet loss of 1% or 2%, H.265 stays stable. So the MOS was over 4.5. Just the summary of the results. We have the audio MOS, video MOS. We see a small difference. And then packet loss, cannot say we have too much loss there. Call setup time, yeah, as expected, there is a bit of a difference between the two test beds. And more than this, I think that was. the influence on quality of experience is actually given by the codec choice more than the network topology. No. No. Okay, wonderful. Where I was, here. So a few key insights. It's actually resuming what I've already said. H.265 consistently outperforms VP8 independent of testbed topology. The distributed USB setup still delivers excellent video quality. Even with packet loss, we have good quality of the calls, good quality experience of users, and Opus holds most approximately 4 on both testbeds. So Opus proves to be quite a good, codec for this scenario. And also jitter and loss remain well within the real-time media thresholds. So main takeaways: C-based OTT voice consistently delivered high quality of experience. Call setup was under the thresholds that are set by 3GPP and ETSI. We avoided the IMS complexity, and the open source proved to work quite reliable, and it enables us to do experimenting, teaching, early stage innovation with good quality of experience and latency. As future work direction, we want to go deeper and see under dynamic congestion what happens, under dynamic conditions what happens. For example, if we have congestion, if we have user mobility, if we have multi-user scaling, and see if we can assess the robustness of the private 5G networks. Under these conditions, we want to look also of integrating a kind of QoS, thinking on DSCP marking for priority traffic handling, to study the impact that this could be on the over-the-top services media quality. And we want to extend it to smart agriculture or other verticals campus to validate applicability. And now I'm going to close with several impressions. Photos from the conference and field trial, because we had a demonstrator last summer at the 6G conference in Berlin. This one are moving by themselves. So this is on the fields in Kaiserslautern. That was their network. It was it put on a van because they need to be mobile and have 5G access in the middle of nowhere for farming. And then the guys in Kaiserslautern are dealing with these AI-driven robots for smart agriculture. And then we said, okay, let's make it a bit smarter. Let's put a communication platform on top of it. And then if you don't have the specialist on site, you can connect instantly with specialists around the world. They can view how the crops look like. They can see the IoT sensors results, and they can immediately take actions. So the photos here are from the 6G conference in Berlin. We were visited also by the representatives of the federal ministry. Since we are funded by the Federal Ministry of Research, Technology and Space. And of course, all this work was possible with insight and expertise from Kamailio developers. And we thank you both for funding and for knowledge. And this was just a bit about our work. If there are any questions or during the coffee breaks, I'm happy.
Thank you, Ramona. Very useful. So let's see one quick question if someone, it's up to you, otherwise we are quite late. We have Wolfgang until we have done preparing.
Yes, thanks for the presentation. Quick question. Do you have any figures about the end-to-end latency for audio, for instance? Because you just measured, I guess, the...
I didn't get it.
The latency for the audio. So the end-to-end latency of the audio path from one device to the other device.
No, only what I put. We haven't measured from device to device. No, we measure just the call setup time. It's problematic to measure on the SIP, on the UE. Okay, on the Latte Panda with lean phone, this is doable, but on the smartphone is not doable because we don't have access to the baseband and we don't see this traffic very easy. Also for the data bear, yeah, we could do it, but we haven't done. We stopped when we researched for the IMS and we couldn't get access to the baseband, and then we didn't come to the idea to measure this anymore. But it's a good point that we could take it for the next experiment.
Okay, thank you. You can find Ramona around the event.
Guys, thank you both Daniel and Ramona for putting up so big crowd here. So quite some efforts, I can understand that. So I'll go quicker so I don't delay further. Just a few words about us. We are a company located here in Germany, in Bavaria. I still needed a flight to come here. So it's quite long German. And then we have back offices in both Romania and Albania. Over 19 years by now of experience with doing server-side solutions in VoIP environments, both in retail as well as wholesale. And you know how responsible we are by now. Regarding CG rates, it's a real-time enterprise billing suite for those of you first time hearing about it. It's simply pluggable, as I will talk in the next slides, into existing infrastructure, so you don't have to route through some specific solutions. It should be able to be future-proof to accommodate new components. It should also be non-intrusive into existing setups. It's all open source software, born in 2010, first sources published in 2012. We were here in 2013 at first Kamailio World. By now it has more than 450,000 lines of code with close to zero AI. Consideration for at least we don't know it, so we have a no AI policy since we are an open source company. 3 branches, indefinitely supported, the famous V010 stable, master and 1.0. We work more and more on 1.0, as Daniel said. We even have it on production, but not full set of functionality which we have in master or V010. Performance-oriented system, of course, we are an OCS. We need to be fast. For that, we have an advanced caching mechanism, which recently became a database. So we can store offline, same like Redis does. So we can replace even Redis by now with a complete standalone solution without needing any database. We include API load balancer for big to very big networks, and the in-memory database, which I talked about. The architecture is modular. It was from beginning like that. For those of you knowing Golang, it's all asynchronous and micro threads and microservices. It should be fairly easy to enhance by replacing one of our components with one of yours if you are you dislike anything about LGPL. Test-driven development, it's our philosophy, so we have more than 10,000 tests on the platform, again, zero AI. CG writes, since everybody promotes AI, there are also people which are promoting no AI, so I think it's democracy. CG rates appliances, what we do, online or offline charging system with complex rating involved, unlimited bundles, and CDR server, high number of interfaces both in and out. Another use case is routing server, flexible routing strategy, number portability support, because it starts becoming very important with routing, especially cost-based routing. And there we have complex rating, we have bundle support, so you can get a specific number of minutes from your supplier and then change the suppliers as soon as these minutes are gone. Statistics-based routing, I'll talk about it, and also channel limits, so you can terminate only 10 simultaneous channels to a specific destination. Then fraud mitigation server, built-in multiple systems on our side. It can be informative or reactive, so it can go up to shutting down the account itself. And it supports also escalation procedures. Then statistics server, I talked already about some of the functionality in routing. Then resource utilization control, this monitoring of channels, simultaneous channels, very based on anything you like to think, based on time, on destination, on source, or whatever. It can also group resources and fail over through them. Then mediation server, if you have to enhance your CDRs with specific information, like adding PayPal account on the fly or Stripe or whatever. Then billing assurance, do parallel billing to what you already have, just to prove if your supplier is wrong or not. And recently, IPAM server, so IP address management system. This starts to be important in 5G networks and IoT, for example, where you have to assign to specific devices static IP addresses. And mobile operators, they don't have this functionality. They usually go with DHCP. So it might be that you need to assign private IPs or make VPNs between two fridge, for example, if it makes sense. So you can use such a solution. Then our architecture is basically based on agents talking outside. So there we have the diameter, which is talking to mobile networks, radios, IP networks, or DNS, enum, all this. And you can also find Kamailio agent and a generic event reader system, which can read CDRs or events from SQL or other message buses, Kafka, SQS, even NATS, if you heard about it. So we support all of this. Then all of these events are gathered into a central point named sessions, which are creating virtual sessions parallel to the sessions which you find in Kamailio, for example. And then core subsystems, which are having implementation of different or implementing different functionality. And there, it's worth to mention that all of these agents, sessions, core subsystems, they all talk between themselves via APIs. So you can keep them in the same process, or expand them over the entire globe if you want to. So if you have to implement a very big application, you can do that by splitting them all over the place. As soon as you have the routing, then you export it by either writing to a database or going out to Kafka or Amazon Cloud or whatever you want. Then a session processing will take, it has normally 4 or 5 states. Authorization and CDR is what it matters today, what we are talking about. But you can also have session start in case of real-time prepaid and session terminate. Again, they make a good team together. And in case of mobile networks, you have also session update, because there the billing heartbeat is given by the diameter client. In terms of dynamic routing system, it's using a dedicated subsystem in CG rates. All these subsystems, as I told you, they look like standalone API servers. So you can take one or all of them. It depends on what are your needs. It has full API coverage, integrated inside sessions, process event API. Remember, session is the one gathering from all the agents. So that includes Kamailio sending this API to CG rates sessions process event. And it has LRN support or number portability. LRN is more for US market, but number portability support also for dynamic routing. It has bundle and cost based, so you can do a block of minutes with specific cost, or you can go cost per minute, cost per hour, or per anything you like to cost. Quality filters based on stats, so you can send your traffic to a supplier, but consider its stats. So you will terminate to a supplier only if its ASR is close to or higher than 75%. Even if its cost is low, you involve quality metrics, and in that case, you are a bit on the safer side. Then you have independent data feed possibility. So you can use a SIP tester, for example, to feed you CDR's information in order to gather the real stats. So and then you can use this into your existing routing. Then you can also have quality monitoring via another subsystem named Thresholds. This is sort of our NMS. And there you get various notifications and actions on them. Then you have also load balancing. The balancing is based on supplier ratio, and the calls again are considered based on the CDRs. So it's real terminated calls. Integrates traffic patterns, so if you want LCR, it doesn't have to be per minute. It can be per your average call duration of that time. So that's important, because if you are going between peak and off-peak, it could be that you are failing, because you will normally consider your price per minute, but in reality you have a 3 minutes average call duration, which goes to your off-peak time, which the price will matter differently than the one in peak. Then you have various strategies for routing: weight-based, least cost, highest cost, for whoever wants to I don't know, make some damage. Quality of service, resource ascending. So, for example, send to the supplier with the most active calls, or send to the suppliers with the least active calls. So you can also consider channels inside. So as you see, you have a lot of options when you are routing. So it's not anymore only prefix-based routing, which it used to be in all times. In terms of configuration, this is how a route profile looks like, and you see here that you have filters. These filters, they look into event itself, and you can put anything what is in your event. You can control it and make decisions using the filters. And if you see the filters, they are in multiple places what we call dynamic. So it can be dynamic blocker, dynamic weight. So even if a profile has priority, depending on the weight, you can make also its priority dynamic. So it can be priority 10 if the user is A and calling B at this time, or it can be priority 100 if it's another user or another time or another prefix or whatever, how you want to do it. So you are very, you can fine-tune very deep your routing. And then you can also have inside the route the same filters which are modifying the behavior. So routes also can be more priority or less priority depending on your event. And then you can have also blockers and failover between routing profiles, so you can gather multiple routing profiles inside. Kamailio integration, it's via EVAPI client. So we maintain an EVAPI client for Go. We do it since beginning, so since I think EVAPI was available in 2014 or so. Then bidirectional communication open to sessions, so we can force disconnects from the billing side. Session synchronization with Kamailio, because it could be you have restarted CG rates or whatever, missed some events because of networking or something, and we need to synchronize between real-time billing and Kamailio. And we have also predefined events for requests and replies. And we support also billing out of DB flat store files. These are useful again for wholesale. So if you don't want the real time and you don't want to influence the performance of your Kamailio proxy with CDRs, you can still write them to flat store and process them offline. Then routing using the routes module, which I explained you about. And here what is important is that we complement Kamailio routing modules. We don't replace them. So what we do, we return back some routing labels, and that's all we do. And it's the responsibility of the administrator of Kamailio server where it uses these routing labels. And some modules where you can use it and how you can route CG rates with Kamailio is carrier route or LCR or derouting or dispatcher. So you have quite some options in Kamailio to make use of this extra application. Then it's fast. It's asynchronous on top of EVAPI, which is by default very fast. And CG rates on its side, it uses everything from cache. And it's flexible. You don't have hard-coded. You can feed any information you have in Kamailio, you can feed it in CG rates and the other way around. And flexible and reliable. We have a pool of connections, and we have automatic authorization. In case of CG rates is down, your calls are secured because the calls will not connect. They will stay blocked there in the route, in the asynchronous route. So this is just an overview how these things can work. So you send an invite which gets passed to CG rates like an external module. So it looks like CG rates is part of Kamailio, and it doesn't influence your SIP call flow. And this is an example of authorization. So you send this event via EVAPI. So you see you are asking an authorization to be done with accounts and routes. And the event coming back, it tells you what is the call maximum usage which is allowed to take, which is in this case 1 minute. And it returns you the vendors and some extra parameters which you can send in CG rates. So for example, if you want to strip or append some prefix per vendor. And based on this information, this is how you do it in Kamailio. And this is how you do how you process this reply from CG rates. You see, you are extracting via JSON get field from the reply, and you are using this, for example, extracting carrier, and you do carrier route, and you use instead of domain, you could use here directly instead of carrier. So you are flexible. Instead of domain of the carrier route, you are using CG rates domain. So it's pretty straightforward, and I encourage you to do it and complain if something doesn't work properly on our Google group support. Sorry, I went through fast because I was already late by default. Thank you.
Thank you. Thank you, Dan, for all this integration and components that you are running. We have time for here question at least.
Does it support multi-tenancy? Multi-tenancy?
Yeah, of course. It's
okay.
multi-tenant by default, please.
Okay, I have one more question also. If I don't integrate directly in Kamailio and I want to use REST API for rating and routing, is it possible?
Yeah, there are APIs available. You will be like a Kamailio agent, same like here. So, by the way, here you see the tenant. So you can define tenant in the root profile separately. Of course, you're welcome. But I encourage you to use Kamailio.
Okay, we have Evgeny with a quick question until Alexander gets set up.
I probably didn't notice. Do you support origin-based pricing?
Yes.
I didn't see, but it's supported.
It is supported. Via this filter, you can do anything you like because
but
you
how
have...
do you handle the inbound rates from operators? How do you handle and import? It's a lot of
via these filters, you define a rate associated, and what rate it means, it's up to you to define it. Because in the rate profile, you have multiple filters. Contact me offline, and I'll explain you deeply. Okay?
Okay, Alexander, you ready?
No, not yet.
No, we keep delaying.
Again on this conference.
Red T-shirts as well. They look very good.
Yeah, I hope everyone grab all T-shirts. Yeah, so
the floor is yours. Let's see what's new with Homer.
Yeah. Okay. So let's start. Homer 11. Yeah. No, that's it. Yeah. So, a small introduction who I am, who we are. So it's QXAP company. We are R&D and located in Amsterdam. We do packet capturing, observability since 15 years, and now it's question: do we need observability and such stuff in 2026 in our OpenAI era? Yeah, even more. So we are absolutely self-made company. We don't have any investors, and therefore we are absolutely free to go to any directions. And this is we are absolutely happy to choose and make it without any limitation. And of course, our model, it's Robin Hood model. We have also customers who paid our money, and we will spend some time to make also open source projects and development. So don't forget to grab T-shirts. We have some of receptions. So about Homer. So if you missed my presentation last year, it was like a vision in 2025 how we see Homer 11 should look like. And a lot of stuff inside, it was like prototyping, it was imagination, guessing. And we are absolutely happy what our vision was right. And based on what's happened in these years in 2025, 2026, a lot of directions exactly went to what we hoping. And especially with DuckDB, Duck Lakes, everybody is now thinking what it's not, we don't need a database anymore. So we need some files which we can manipulate, like Parquet files, arrow format, etc. But it was 2025. What has happened exactly in 2026? So it's mission completed. So we complete and created Homer 11. So we're working on Homer and Hepic, of course, and it's Homer version is so far its most complex and advanced upgrade in our series. And what is very important, it's single binary. So if you remember Homer 7 and Homer 5, etc., it was MySQL, Postgres, it was Haplify server, it was Homer app, UI, and a lot of additional components, and it was like monsters. So some of you complains that it's very complex and very hard to maintain. We heard you, we redo it, and we redesign it, and it's done. Now, I want to make or spend half my presentation to show how it works. So, do you agree? Yeah? So let me take glasses because I'm old already. So, as usual, Homer 10, we did it based on Grafana. It was also engine, but also somebody of you complains what, where's UI, we missed UI. We want to click. So we heard you, and we did it completely from scratch. This is how it looks like landing page. It's a login page. Homer supported OAuth, yeah? So it's by default. LDAP authorization, etc. It's of course it's internal authorization as well. So we log in, and kaboom. So we have a normal page. We can make search. Here's data. This data is coming right now inside. So you can create multiple dashboards as usual. You can edit, locked, etc., etc. You can add multiple widgets. We have multiple widgets here. Forms, it's in old Homer 7. You can select and add additional fields as usual, drop, blah, blah, blah. You can select what type of methods it works. So everything is fine. But what is very advanced stuff here, let me do some click. So it's here as call flow. It's running right now. You see call flow. You can do grouping by IP. It's from the same local host. You can remove some IPs. You can remove some methods. It's everything. It already works. Payload, zip types, etc., etc. Compact, absolute time, compactions, etc., and so on. You can also have some QoS. Boom, QoS is here. Most calculations based on RTCP stuff. You can change. You can click. Call info, as usual. What is okay? It's still connected. SRD. Some internal measurement is bigger. So tell me if it's too small, guys. It's fine. I apologize. We have some, okay, here is not an event or TLP. I will explain it later. What we can do also, TXT export. It works. We can do pickup export. We can create a share link. Open, boom. It here works. Perfect. What is cool stuff? We can also generate. So you have call. What we can do, it's like Andreas said, we want to generate a CP scenario based on this call. You can click it, and it's already generated. You can download it. You can install and make your test scenario. For example, customer complaint, what it doesn't work, blah, blah, make a call, click, done. You can download it, you can install it. Of course, you can check each message. You can make decode. Yeah, it's decoded as you want. And if you don't like this white screen, you can switch to dark type. Yeah, I know, it's impressed, yeah. I also like it. So, but this is not, that's it, yeah. So now we install in Home Core, this is Home 11, we support DuckDB inside with Duck Lake, and also you have possibility to make any type of SQL query inside, and let's do it. This after completion, of course. Select from Homer Lake, main, and table have proto 1, and boom, bam, it works. So, but if you're lazy, guys, you don't want to touch and find any fields, you can also connect your LLM connections, yeah, MCP, or you can use OpenAI. It's absolutely standard API. You can connect it to Llama, or you can use your own regular expressions engine, and let's say find invite from the last hour. Boom, invite. Well, okay, invite and buy. Oh, this buy is also here. It's great. So it works. You can extend, you can connect, etc. So what else? Like I said, OTLP. It's OTLP. So Homer 11 support not only HEP, it supports also OpenTelemetry collectors. So you can send logs, metrics, traces using OpenTelemetry stuff. It's absolutely fully standard. So there's a lot of agents and programs supported. So what we can do is we can make search by OTLP. So it's here, we can click it. Yeah, and we can click it, this metrics, and to this metrics is already it's sent by our agent. What we can do else, we can make metrics, OTLP metrics. Boom, it's already charts. And of course you can see tables. You can click one more time. So it works. And of course, if you send some OpenTelemetry traces, you can do this search and click. So, and it works. What is really cool stuff, what I really like is, so let me try to make this screen a little bit smaller. I will add widgets which call time charts. And let me do search. And you see, we have already a target, which we can select where this data should go through. Yeah? So, or it will be in results. Let's do some for 7 days. Okay, it's anyway, it works. Let me show you. It's in charts. It's 7 days. So this is another type of widgets here. It's called data chart. You can, inside of these data charts, you can write your own SQL query, DuckDB query, or let's say Homer query, which will do time basket, method counts, etc., based on interval, which you will take from UI method. And you see, it's very fast. It's take exactly for 7 days. We are sending permanent data inside, and it shows it. You know? something like that. So inside, what is very important here, it's also we do some redesign. We here users, user settings, IP aliases. You can add IP alias with mask, yeah? So not only 32, but 24 and whatever. We have some advanced settings. We have mappings, so you can add your own table. So we don't have time, sorry. We have subscription, auth token. We can use auth tokens against subscription dashboards. What is very important here is we did also complete redesign for our correlation scripts. So before it was not correlation scripts, it was like mapping. Yeah, you want to correlate registrations or let's say login with another protocols. Now you can use Lua script. Boom, it's completely full documented. You can use it, and it will automatically correlate data how you want. Okay, games, I will not show you. It's too dangerous. Yeah? No, but I need another 20 minutes. Okay. So, but the question is here. Okay, many of us work in console, yeah? So sometimes you don't need, or you don't have browser. Yeah? So how we can also use Homer without browser? We implemented CLI, which give you possibility to make search. So it's boom. So you can execute it. No, not yet. Wait. Just work arc. So we can send it in different formats. For example, if you don't like table, you MySQL style, yeah? So it's all good. What else? We can do call flow. Let me see if it works. It works, yeah. So we can send in any time, any format. So if you use CSV, you would like to make some export, you can do JSON, boom, JSON is here. So machine learning, you can immediately set, so it's normally Homer is now can be headless data source for any LLM platforms or MCP. What is else you can do exactly? Any fields, yeah, so any fields, we can do, okay, call flow, it's already show you. It's already gone, sorry. Let me take one. Yeah, so it's huge one, yeah. So but it still works. What is very interesting, let's me do some experiment. It's dangerous demo now. So it's 24 hours, limit 5,000, boom, charts. Oh, you can also see. Okay, it works. Yeah, so let me make dangerous demo. Yeah? So 50,000 and how fast it will be. You see, it's 5,000. It will be processed in 700 milliseconds. It's very fast. Yeah. So a little bit bigger. Yeah. Okay. Anyway, it's 3.5 seconds. 50,000 messages. So impressive. Wait. But if you are lazy, yeah, and say, but I would like to have something like UI Homer and also in terminal, you can do it. So you have this and cursors, and you can do and make search. Bam, it works. So table, for example, we change to JSON. Bam, works. So it's something like that. We have a little bit more, but let's go to slides now. Where's slides? Yeah, here. So now it's recap what I showed. Yeah, so we did it. So in 2 words, Home 11. It's like one application. It's Homer Core. It's called. So it has internally module, ingester, nodes, and collectors. So this means what you can extend and your home instances to many devices and make a cluster. So of course it can be compiled on a modern processor, 64, AMD 64 and IRM 64 on Linux and macOS. It's powered by DuckDB, Duck Lake inside. We use Apache, Arrow, IPC, and Parquet files. So it's a columnar database. So it's no cluster, files, let's say, no database, files. So it can be linear scaling. We have flexible schema. It's compatible with our HEP free agents. It's easy to maintain. It's cost absolutely nothing. So it's cloud native. You can install it Kubernetes, standard deployments, everything is fine. So user interface is already done. It supports MCP, LLM agents, friendly design, and so on. It works. As usual, HEP injection works as usual. So any HEP version 3 protocols, Kamailio, FreeSwitch, etc. We send data, Janus, we can send data to Homer and it will be displayed. OpenTelemetry, like I said, many agents already support OpenTelemetry, and you can send from Promptail, from Telegraph, Prometheus, OpenTelemetry collectors, metrics, logs, traces, and or use InfluxDB line protocol, and it will be also works. What is very important, we support also InfluxDB gRPC module inside of which you can use in Grafana. So this data, what you send to Homer, you can already display in Grafana without any limitation. It's already supported from the box. And here how it looks like. It's in 2 words. We send data to ingester. This is Homer ingester. We use DuckDB for compactions and memory storage. DuckDB makes this dump of small files and make compactions. So we have small files, and each you can configure in the Homer how you would like to see compaction. So each 20 minutes, 30 minutes, 1 hour. So it will be not small files. So first we write small files on the disk, and after it will be compacted and will be just one. And with indexes and therefore it's very fast. Also, what is very cool here, Parquet files is just files. So we just have metadata inside in a SQLite file. But the data you can send to any S3 storage, R3 storage, R2 storage, and also to install Minio. Okay, Minio doesn't exist anymore. It's RustFS, for example. RustFS you can install. It's very cheap to store this data. So it's good compacted. We use compressions of Parquet files, so it's costs absolutely zero. As I said, you can use our user interface to get this data. You can use with SQL queries from Homer or also DuckDB SQL stuff. You can use Grafana and Flight SQL API for data from Grafana and from our local agents. So analytics pipeline is how it works. You can display it in console, or you can display it in UI. How to install? It's already released. I released it 2 hours ago. So nobody will ask how you can download it. You can go to this URL, download it. It's already packages already exist for Debian and Red Hat, RPM, sorry, and Docker as well. But Kubernetes will come. Helm Rita will do it. I hope will do it, and will be published later. Of course, it's already support ARM 64 processor. So if you want to install on your new Linux Raspberry Pi, you can do it. Yeah. So be brave. And of course, it's everything is documented. OpenAPI documented documentation is inside. We have some internal documentation how to set up in any different scenarios. All good. So what else? So what we did also, we released Haplify 2.0. So we completely, let's say, destroy old one. Not destroy. We use, of course, the features from what we built. But normally we created completely new Haplify 2.0. It's support new modern stuff. So here it's features. You can even install on Windows. So I don't know, somebody is asked, can we install on Windows Haplify? Yes, now you can install on Windows. It supports macOS, of course, Linux. It has a lot of features here. So I'm out of time. Yeah? Okay. Yeah, it supports environments you can use in Kubernetes without any problem, in Helm charm, and et cetera, et cetera, et cetera. Also, we support native collectors. You can also send, I don't know, one of our users created a HAP over HTTP2. Okay, so we also add this in Haplify. Probably you saw what you have seen what we did some tests with CP, yeah? But it's not CP. So we completely rewrote ZP from scratch. It's Go Zipper, it's called right now. So it's open source, and it's support ZP scenarios. It's based on Golang. We also had synthetic RTP, RTCP stuff. It sent automatically everything in Homer, in our HEP protocol, and RTCP scenarios. Its pickup can be also integrated in GoZipper. You can immediately use pickup without convertation of to XML files. As I said, it's support ZP scenario. If you have already, so like Andreas said, we have a lot of with XML files. You can still use it and retest it. We have small terminal user interface like in Homer, where you can install it. And of course, it's open source. You can use it without any limitation. So I would like to say thank you for our happy customers. Without you, we could not exist, and we could not spend time on open source projects. So thank you so much. And of course, for you guys, support open source before you ask open source support us, yeah, and we will make another cool stuff in the future. So thank you so much.
Thank you. Thank you, Alexander, for your long support. Time for one question only, because there are some.
But we have break. We have more questions. Yeah.
No, there are some good-looking cookies outside, and
okay. So no, we could
thinking that it's gonna take longer for this break because some cheesecake and other stuff I saw there. We have Viktor.
Thank you, Alex, for your talk. I have one question about the.
I don't hear you well.
I have a question about HEP over HTTP.
HTTP2, yeah.
Yeah, does the server support it right now or no?
Okay, server is not, but in Haplify, so we have implemented collectors. So normally it's, let's say, some of you can send HEP version 2, yeah, it still exists because why don't touch running system, yeah? So, and in Haplify, we implemented collectors. You can send data over TLS, over HTTP2, so, and it will convert it to HEP3, yeah, so internally. So it will be like a gateway to your network.
Okay, no, Surendra wants an extra question, but you shared the table during the cake and coffee break, sorry. But yeah, we are a bit late and then we get even later afterwards. But it's the break, you can meet and discuss it. Or eventually tomorrow during Ask Me Anything, he's going to be here.
Yeah, tomorrow please don't miss our dangerous demo with Rita.
Okay.
It will be fun.
So thank you, Alexander. Thank you, everyone. a bit of historical discussion about the early days of SIP Express router, then Kamailio. Let me first introduce everyone, and then I'll show just a few photos. I'm not sure if Julie prepared anything else. But yeah, so I'll start actually with Dorham because he was the head of the department. Here, the second one, so to say, the boss of the others, more or less, except maybe he was a student eventually. But Dorham was in charge of, funding the research at that time or finding the projects to have the money to pay us and work in this real-time communication field. He will get the microphone to introduce himself as well. I just say a few words. Then we have Giri next to him that was more into technical at that time and kind of coordinating the team at technical level, if I remember correctly. Then we have Andre, which kind of did the heavy coding in the first days, and then Jan also part of the team coding quite a lot. And Dragos, the junior, we have it here because he's the one that has the IMS extensions. Yes. IMS extension, and if they are not working, you blame him, not me. I just wanted to show his face so you know who is it. But yeah, so I also was quite young at that time. The last joining the team, okay, besides Dragos. So yeah, just to show a few photos from that age. So the proof that, yeah, this year, and we have Andre, which is this one here, the commits we have in the Git history. So probably it's one of the, the fastest first line of code to the first working release, right? So it is like less than 24 hours in the September. And I was not there to attest it was actually working release, but whatsoever. A few days ago, this is from this open hub or whatsoever. So I thought it's more like an independent rather than running myself some scripts, so everyone can search on the web. It's doing like monthly or aggregation. So over all these years, practically are like 564 contributors with over 40,000 commits and millions of 1,173,000 like codes offline, effort evaluation and so on. But as you can see, it's rather stable commits and contributors, which I'm really happy to have after so many years. I have to make a small correction in the way that this is 25 years of development. The project was like 1 year later made open source, right, if I remember. It was developed internally to have something working than more than this first release. Something like that. We get that. So yeah, this is me at Cebit. This is Cebit like March 2002. I joined in January, if I remember, a few months after the first commits. Then I have the next. We had the meeting because, the history, we had kind of a split of the project. And then in 2008, we met in Karlsruhe with Henning, arranged that. So you can see some younger faces here. Ramona, that's the entire group. Should be also this one, maybe it's more accurate. You can see Andreas was there, Dragos was there. Karsten Bock is not here, but was there Stefan Suer. You see also Jan Janak is there. Dan was in Karlsruhe. You are everywhere, all the time.
No beard.
Henning, no beard on the other side. And some other people from community at that time. Then what still I have here? The dinner at the same event, more or less. Bogdan Pinta, maybe some people remember him. Stefan Suer at the dinner, again, Karsten Bock, Andrei, Dragos. What else I found here? These are the Linux tags. So Raphael is also here somewhere. Raphael, it's in the middle, but was supposed to be around here. Maybe he's still having a coffee. Then Karsten Bock, Henning, and Timo. I think it was 1 and 1 at a time. With Ramona, the Linux tag. This is 2010. This is 1 year later. And Andreas Granig was also there. Yeah, no bird, but looks. What else I found here? More recent. This, I think it's a Kamailio World, but I wanted actually to give credits to other community members like Ole Johansson, then Peter Dunkley that added to WebRTC and a lot of presence. Then Klaus Darillion was quite active in the past, and I was looking for a photo because he was the one actually proposing the Kamailio name. And this is like 10 years ago, 15 years Kamailio. We had the panel again with Dorham and Jiri and Andre. So just to see some pictures from time ago. And that's it from my side. I wanted to just show some memories. But otherwise, let me start with some discussion, and again, maybe with Dorham. How was it at that time? Did you expect to go so long, so far, and what you expected? Because you've been in the research and you know some projects kind of succeed more than the others.
Not really.
You have.
So Fraunhofer is not exactly famous for building research projects that last more than the duration of the project. And that's simply because the way research world is structured. You get money for a certain topic and you try to do your PhD, your papers, and then you move to the next one. We've tried to build something that makes fun. Well, basically, Andre refused to work on the research projects, so we had to have something for him that excites him, which is basically how many thousand TCP connections can I do on BlackBerry or anything small. Jiří was never the type of person who works just for the work, but he wanted to have a goal. He actually left a well-paid US job to come back to actually work on the project. Jan, as our, I would say, Czech slave, sorry about that word, but that's the way he described himself.
No, it's green.
No, he was also left a well-paid job to actually join the team and work on something that is fun. And that was actually our luck as a group at Fraunhofer to have such a great team. Everybody with his talents and dedication to work on something that we believed is really nice. Why did we believe it's nice? Because at some point in time we had a lot of money to buy Cisco equipment. Wow. And soon after we deployed it, we discovered, well, that really is crap. Well, that's 25 years ago now, so I'm not sure how they work now. I'm sure they have better equipment. So I don't want to talk long, but I think if you look at the group, one of the first comments we received was, SER is a great example of German engineering. Now, at times in which nations and people seem to compete who is the most national, who is the most racist, I think the combination of Czech, Romanian, Palestinian, French, we had a Hungary guy, we had, also had Germans. At a German institution shows that research and development will not work with closed borders, with closed minds, but we have to work on something that we like, with people we like, regardless of where they come from or how they speak.
Okay, thank you. Maybe Jiri, you take over, and you're kind of the guy, if I remember, because I'm no longer young, like you're scanning the world, trying to promote the project and at many conferences. And what did you find by going around, and how you try to shape SIP Express router based on your experience? You already said with Cisco, but yeah, I remember some photo you sent recently, like some were having like huge, like servers to run some telephony engine. And how is your experience, and what motivated you to believe in this, let's say, project?
Maybe we confirmed what Konrad Adenauer has said. You have to piss off someone to be taken seriously, first of all. And Durham has been very helpful in that. I remember we were first showing up in Atlanta, Bonn, Voice over Net. It was a big party, big trade show, and also Bake Off. And we were demonstrating our software, and there suddenly some MBA type of guy came in and said, "You're gonna tell me why you're selling this crap when we have already Vovida?" I don't know, who remembers Vovida? Too long ago, but it was the first open source project for SIP. And for that, you had like a SIP redirect server, which you were building for 2 weeks, and the register, which took like 3 days of building, and so on and so forth, totally decomposed and just way too big, shooting for too big dimension. So Durham, honestly, when we were asked by the guy, why are you doing this? What does it make better than Vovida? Durham said laconically, "It works." And the guy was Alan Knitovsky, and he was founder of the Vovida, which was later acquired by Cisco. And probably for the human talent, because they had a lot of good guys there, but his software was a little bit over-engineered. So that was one of the points how we started making ourselves well-known. But I would like to expand one more story. Durham has already said it. But it was like the 2000-something when I really thought that this Fraunhofer research, I wanted to be part of it. I wanted to see running code, and running means not it compiles, but it pushes the bits back somewhere in production network. So I came to a company, and I thought, okay, screw the research stuff, let's go for some real thing, which was a prestigious American company, startup filled up with VC money. They had all the best people out there, and of course they hired me too. Got a lavish salary, everything. And it was really exciting, and the people were magnificent there. Just when I look at the Java software, I was beginning to doubt my own decision to go there. And it was really that I was looking back in Andreas' SER code that I just gave it up. Didn't say to my wife anything about change financial conditions. Said we are returning to Berlin, and that was it. And I came for Andreas' code. So I think really Andreas deserves a big credit. And that was the things which formed us in the beginning. That was it.
Okay, thank you. Let's go, Jan, maybe. Yes, this next. Because then you then continue at some point, or returning back to the research. How was your experience from the first years in research and building SIP Express router, then eventually helping, or how is the second part of your research that was more applied? How you feel it was an evolution in this?
So after many years working on SIP, I decided it was time for a change. So I went back to academia. I moved to the US and started working in Henning Schultrini's lab at Columbia University. So my original plan was to not do SIP anymore.
Okay, so.
But after getting there and talking to people, I realized that many of the research projects that the lab was running at that time actually had a SIP component. So when I would talk to someone, they would say, "Oh, so you're one of the SIP Express router guys. I have a problem for you. Maybe you can help me fix it." So for me, it was a great way to actually be able to talk to people and to make connections. So for me, SER and what then became Kamailio really did open a lot of doors. I met a lot of people, some consulting companies from Wall Street that were running SIP Express router in the basement, powering the phones on the Wall Street trading floor. At that time, there was this project called Internet 2. Many of the leading US universities did run a version of SER for their internal voice communication system. So it's not an exaggeration if I say that the second half of my career, I owe it to SER and Kamailio, and the fact that there are so many of you here sitting in this room 25 years later makes me think that I'm not the only one. So we were able to create something very special in the sense that it's a piece of software that attracts people, attracts smart people, and that for me is probably the biggest achievement and the biggest satisfaction I got from all the years. Okay. Hacking on modules, writing documentation, responding to emails on the mailing list, and doing all the thankless work that needed to be done.
You want to add something, David?
Yeah, so I was kind of the student a little bit, well, the student in this group at least. I came relatively late to the party, right? The SIP Express router was 2004 I joined, so it was already kind of working, it was solid. And I had this thing where, you know, I came from H3 to free, and that was the closest thing that you could have to IP, actually. Because the other thing that we had, if you don't remember, was I worked in this company, ETSI in Romania, DG, I think there are some colleagues here, I don't know where you are. Hey, and we had these racks from Alcatel. Yeah. And the way that I made them a little bit work over IP was RS-232 to IP, to TCP adapters, you know, so yeah, that was the level. And automation meant OCR scanning manuals and then trying to generate some, you know, something to deal with that so you wouldn't manually manage all of that. So, you know, when I joined Focus, and it was all about SIP, and it was so modern, you know, and yes, it was way simpler back then. But the mind-blowing thing was that Dorgam said, you know, hey, implement this IMS thing. And it was, what do you mean? This is a whole mobile core network. Like, yeah, but, you know, there are armies of engineers that build these racks. What do you mean? It does not compute. You know, so no, just see what's the best that you can do. What can you make out of this? And I think that that's the nice thing about Fraunhofer Focus. You know that we got a time, we got the opportunity to try crazy things and to see what works. And the other thing about the performance, how the IMS, the open source IMS core came to be, was actually that there was a paper published somewhere, and people were scared to actually put the real names, and it was sort of, this is what one C proxies uses of CPU, this is what another, this is another, and this is another one. And Intel came to us and said, we found out that the smaller one is SIP Express router, and we think that's the future. So how about you make, you know, how about we invest into this, into IMS and so on. Yeah, and with research, I think, you know, it's just a wonderful environment. All of you that work in the industry know that it's very hard to actually get budget to work on new ideas, new things. And at Focus, it was actually kind of the norm a little bit. Sort of, what do you think it works? Okay, it's a crazy target. Let's see if you can do it, you know.
Okay, so now to Andre, because I know he likes to talk about sales and business. So I have a question for him because, again, he's like the main architect of the first releases, and still probably we use or we rely on his design decision at that time. And he's still involved a lot in development, I know. So my question would be, if you'd start from scratch now, you'd change anything on this architecture, like not multi-process, but maybe multi-threading, or I don't know, other programming language or so?
So, a hard question. What I would do, I think I would try to make it configurable, to make it run both multi-threaded and multi-process and have some, I mean, a little bit more abstract, so that you could combine both. I mean, the multi-process architecture has some advantage, especially if you have, right now I like memory separation. At the time was for performance, because at the time threads were not so fast. Context switches between threads were slower. But now it has, still has the advantage of isolating memory. So if you have some crash, some memory, it's isolated to one process and way easier to debug. So I guess I would try to combine both. I mean, it has some limitations, and it would be nice to be able to have thread for some other stuff.
So we are kind of leading there. From last year, we had multi-threading UDP, now multi-threading TLS and so on. So yeah, looks like we follow his kind of direction, let's say it. Okay, so I don't know, we don't have much time. Maybe someone wants to ask a question that, again, Andre would be on the technical side. If you found something strange in the code, probably it's his fault or Jan's fault also. And Jiri has also some strange comments.
Andre will be keen to tell you everything about the TM module.
Yeah, these things. But yeah, they are running. Sometimes it's like they said, if it's running, don't touch it, and you think about how at that moment the decision was made. But we are 25 years, so that proves it was not really a bad decision. Maybe we kind of lost why, or we are not part of that coding. So I have Ihor.
What was the reason of writing own memory manager?
Speed. It's way, at least at the time, but I think now too, it's way faster and adapted to the workload of Kamailio, of SER. So yeah, those are my reasons. Speed.
And I would say I really love that, actually. We based a different project, but with the same memory allocations. And we said, you know, we're going to run with debugging until we get to production. We never turn debugging off because you have while grind built in. And it's so far so good that, you know, it just makes sense.
Okay, back to Dorham, because it's about this, what could be done different. So Dorham, from your leadership and maybe also Jiri, would you have been a little bit more strict on, let's say, be more, how to say, commercial friendly rather than very techy results? Because many complain about this config file being rather strange and so on. With your experience now, you will kind of force Andre, okay, let's go for, I don't know, prefix-based routing or something else, or Node.js. How do you think now? It's more valuable, fast, but very technical, or a bit more, I don't know, user interface oriented? Not user, but admin, more admin friendly.
Well, Fraunhofer is not famous for its great sales team. So we were actually the first group that went open source. I mean, they usually had some products which you tried to sell through startups, and we looked at this and said, no, we don't want to be that. Like, company after 5 years was still struggling, so we said, either it goes well or we don't leave it. So with no sales budget, no experience in operations, and actually no voice over IP market then, because there was no voice over IP, we decided that whatever pleases a guy like Andre will probably please a lot of other geeks who are doing voice over IP then. And apparently we were right. So no, I don't think we would have spent more time on GUI and that then, because we were getting, like, the first people who were contacting us and wanting to solve something, we always had some weird issues. It's not something that you could solve with a prefix GUI, and his configuration language, how ever complicated and strange it is, was probably the right answer to actually solve all the problems of all of our different weird scenarios that we had to solve them.
Okay, Jerry, you want? Oh, Jan wanted to add something.
Just wanted to add very quickly to this that early on we used to go to these events called SIP bake-offs, like interoperability testing, and the configuration language and its flexibility was a killer feature of SIP Express Router.
Because for no tech guys, but
no other software could actually match that, and they were running these complicated tests with spirals and loops and everything. And for some of the other companies to be able to configure such scenarios meant recompiling everything. So today you might want to consider something like Node.js or like a more established language for the configuration file, but that didn't exist at that time, right? So hindsight is always 20/20. But having this kind of programmability early on was actually a really great feature.
Yeah, we have actually like Lua, Python, not Node.js. We have JavaScript, but with a duct tape interpreter. So
we used to have TickleTK then, and that was not really flexible.
Yeah, I think Perl was really with a lot of memory leaks, not for parallel running and recursive running of the same script.
That was Python.
Python?
Parallel running.
Okay. Okay, so Jerry, so your thoughts on what could have been done different to be more AI friendly, or no? We have AI at the core now with Kam.ai.
I think at the time it was actually okay, but I hide myself behind Gemini. I asked yesterday Gemini, tell me the best things about SER/Kamailio. And it said all the things now, it's super fast, super robust, and so on and so on. And it has a lot of modules. And tell me the ugly things. It's really horrible. Labyrinth of age documentation, 100-something, many modules. Nobody can configure it. And unless you need the 100,000 parallel scores, don't use it. So I don't think it's actually a software failure of the software itself. I think for something which would provide more product experience, you need to wrap it in distribution, have a GUI, have a lot of things around it. But Gemini told that if you take it as is, it requires quite some black belt, and I occur to think that too. I don't want to hide myself behind Gemini. But at that point of time, things were very fluid. In the first years, we were not sure who would be using SIP. We were all excited about possibilities it would be telcos because they were rich and we desperately needed money. We thought intuitively the first adapters would be ISPs, and it actually turned out to be the case because the ISPs began to challenge telcos, and ISPs, they have always very deep technical experience, and they have this do-it-yourself inclination. So that was actually, at that point of time, it was a very good match. And then there were a lot of cases, forgot now, but there were some tests of SCR on a US submarine. There were tests on Boeing. There was, for the time being, a Boeing connection project, one of the first internets on transatlantic flights, and they were experimenting with voice over IP2. That was then discontinued because the annual budget was 300 million euro because of a complicated satellite handover architecture. And we were always able to align it to some very specific needs of very specific deployments, which would have been thinkable otherwise. So I think for the initial birth hour, it was better than perfect match, and it continued to be so for quite long. Now AI, I think it begins. I return a little bit to what Gemini has said. That it begins to be a little bit cumbersome. A lot of modules, a lot of documentation to digest. A lot of requirement of understanding the SIP protocol. I think maybe it's waiting for some overlay layer that will make things by default a little bit easier.
I'm taking that we, the developers of the project, we are not going to be replaced by AI very soon, based on that report. Okay, to wrap it quickly, but first I want to ask Dragos, because how hard was for you to kind of start working, because you joined a bit later and then you had to do this MS extension on an existing, let's say, complex project? Was easy to get in? Like, trying to say it for new people in this room eventually, or watching online, if it's hard to get into the code and build on top of it?
It wasn't easy. I mean, you can still probably see it in some of the modules that I did for IMS, because it was at one point, you have one task and you want to get it to completion, but sometimes you don't understand the architecture. And I remember a very interesting talk with Jan that came into my office, and he looked at my code and said, "What are you doing here? Why don't you export all of this to the script and to the routing script and just orchestrate all of this stuff from there?" So, I think what helps a lot, what helped me there then and also probably helps now, is to just have some, maintainers, some developers in the project explain you the philosophy of the modules, because, or the whole structure, because, you have a lot of developers, which is a blessing, but it's also sometimes overwhelming. And I will kindly ask all developers, when you're doing something, when you're adding a feature, you need that itch that needs to be scratched. Please add tests. Please make sure that, if you do something and you find another bug, well, try to fix that. Think about the architecture, think about those things, because this is, how the project will continue. So, for example, for IMS, for what I did back then, I did it for my diploma thesis, but I think Smilecoms, right? They overhauled everything, and then they made it kind of usable for more people.
It was a separate project and then integrated into Kamailio. Okay, we don't have much time, so I don't know, the last words from everyone. I don't know, is there any future for telephony? Just a random thought.
Oh, definitely.
Okay, he's not easy. Okay, I put him in the right position.
Yeah. No, but I just want to say one thing. I tried with IMS, and IMS was very slow to get into the market. And we were struggling, with all kind of soft phones and, making our own devices and our own clients and so on. Today, I'm literally buying second-hand phones from eBay, mobile phones. So any iPhone, Samsung, whatever, everything works with SIP and with, with these things. So it's much easier to test now.
Andre, then what advice you could give to new developers? They should now focus more on this, easy to use, or you still think that performance and so on pays?
What advice I would give is look into AI. Get a subscription, run it locally. It makes life way easier. Well, unfortunately, for the ones who really like to code, but...
Okay. Yeah. Jan, for you, what advice you have for open source, I don't know, community and everything, research eventually? Focus should be on?
I think it's generally, when you're trying to design an application or potential open source software, it's better to make a small number of users really happy rather than making everybody sort of happy. I think that was the original appeal of SIP Express router.
Dorham, your thoughts for us, for younger people here, about this kind of decision, go with open source and more, flexibility, look better at usability or easiness. Where you think in long term it's the right choice?
Well, I must confess I have mixed feelings when it comes to open source. We made all our success based on open source, but we actually did not make any money with open source. Really. There are lots of big companies using the open source software that we built, and we actually, at least Fraunhofer invested a lot of money into making, and we never received any money back for that. So it's a difficult thing. I mean, if you're looking at it from a commercial point of view, yes, it can work, it can be tough, but in the end, everyone has to decide what is his best sales opportunity. I know that we would not be able to sell a very complicated zip proxy that 25 years ago nobody knew what is being used for as a competitor to Cisco. So from this point of view, it was for us the right decision.
Okay, maybe for you, with this future of telecom, I understood it's no. So what do you think will be the future of communication then? The bots chatting between them and then making a summary?
Well, actually, I will start with my favorite. I like analytics because we find out what's going on, what's going wrong, and so. And we find out, we know of cases that there were like some guys calling themselves on a 900 premium number 24/7 in 30 parallel calls. And the question is, what is that? And it sounds like money laundering. So there are apparently some good use cases still surviving. Other than that, I have some dilemmas. One of them is we have been doing all the life SER and SIP, but I actually see that I make 9 of 10 phone calls using WhatsApp and 10 of 10 messages just only WhatsApp. So I think it may be, if one is seeking for a stronger explanation, it may be a extrapolation of the end-to-end principle, which says put more intelligence in the end devices and the rest will be sorted out. So it may be actually something not to be forgotten about. The standard is there, but maybe the end devices are super powerful and they can roll whatever standards we have very easily over. And the last dilemma is, I was just looking at some use case, and it looked like complicated. This was Gemini called Labyrinth of Modules. So I thought I will try to write my own proxy using AI, and I think I've got a pretty good proxy, which has cost me like 6 or 8 hours of AI time, and it has user location, authentication, registration, processing, media relay, DTMF analysis. DTMF is still living with us. It's incredible. And these 6 hours almost seem easier to me than to start downloading, relearning all Kamailio modules and putting them together. So that's a dilemma for me. Like, what would be actually easier for me to do? Just come and shout at AI and do it for me and like that with a shopping list? Or just go and start reading the how-tos?
Okay, so yeah, AI seems to be a threat to some businesses then, including developers apparently, and consultants. We don't have more time, but the guys will be around. We are already past the time, but we planning to finish earlier so we can go over the 6 p.m. They will be around, so if you want to learn more about the initial, design decision or, stories from that time or what they are doing now, they are also doing amazing things with like Frafos and NetPath networks, something like that. Jano is back in research for PhD. But yeah, meet with the guys during the break, the evening event, if they can stay all here. And then big thanks for coming here and, digging into some history.
Thank you for inviting us, and thank you all for having us here.
Thanks for the invite. I always feel a slight fraud coming here because you all do millions of minutes and long-lived projects, and all of mine projects are short-lived and tens of minutes. But nonetheless, some of it is hopefully interesting. And this one is about, I found myself doing some weird stuff in the browser because I didn't have a media server. And so this is basically talking about what that means. And it's maybe also drawing to your attention that the WebRTC API and in general the web APIs aren't static. The W3C keeps adding stuff, and in particular Chrome keep adding stuff that might actually turn out to be useful for you. So for those of you who don't know me, I'm Tim Panton, I'm the CTO at Pipe. I wrote a while ago a WebRTC stack for running on small cameras, and it was like just destined for baby monitors, but it turned out that it's now being driven around the track in race cars. It used to say 250, but now it's 300, because yesterday I clocked a car doing 300 kph in southern France. So, yeah, it's a race car camera that we've been working on. It sits over the driver's shoulder. It feeds live audio and video at low latency to the pit crew. So it's not for broadcast, it's so the pit crew can look over the driver's shoulder and see what they're doing and give them advice over the radio. So you need low latency, and the range of this thing is too far for Wi-Fi, right? So the tracks are 5 kilometer diameter typically. And the cars move at high speed. So we end up using public networks, public 5G networks, to do the backhaul, the uplink. This is what it looks like and sounds like when it's running. So just to give you a sense of how crazily they drive. I find myself watching this stuff every now and then and being scared, but anyway. So this is the architecture, the kind of context for the architecture we're talking about. You've got an ARM SBC running our WebRTC stack, talking to the camera and a few other sensors, and then sending that over pure WebRTC over the 5G network peer-to-peer to a laptop browser. And the only thing we're doing kind of in the cloud is the signaling. So we're trying to keep that peer-to-peer link for latency reasons, also privacy and cost. So that means that, like anything we have to do, it has to be at one end or the other. And so today's thing is about what we've done in strange things that we've done in the laptop browser to try and, in some case, work around the fact that we don't have a media server. So yeah, here's example number one. There's somebody's Mercedes doing silly things. But one of the things that they did, I saw this photograph and I thought I instantly knew exactly which car that was because they put the camera in upside down. Because of the way that the roll cage was constructed, the obvious place to bolt the camera on was the wrong way up, which gave us a problem because our image was upside down. So I then thought, well, okay, well, where are we going to rotate this? In the media server? No, we don't have one. So then where do we do it? Well, initially we did it in the camera. And this was cute. You can use the G-sensor to work out, like your mobile phone does. Use the G-sensor to work out which way up it is and then rotate it as needed. Unfortunately, this didn't go down well when they rolled the car because you end up with the image the right way up when it shouldn't be. So we then tried to move it. No, I don't have a media server. We tried to move it, and I then moved it to doing it in CSS. So it's really nice. You can do a CSS transform, apply it to the video tag, and it just rotates it. Perfect. Except that the moment you press the full screen button or send it to a Chromecast, that strips off the CSS, and you're back the wrong way up again. So then we had the extreme case, and this did actually happen, that the easy thing to do is take the monitor off the VESA mount and turn it upside down. That works really well, but it's hard to justify. So we ended up with transforming the media stream track. Now, I should give a bit of credit to the concept of media stream track to Harold and Bernard, the late Bernard Aboba, who pushed for this in the W3C, and it's this quite nice abstraction for holding real-time media in the web browser. And what's interesting about it is that you can get a medium stream track from a ton of different places, and they all behave pretty much the same way. So you can create it, as some of you may already have done with and you do every day that you use Meet, Google Meet. It does calls get user media, and what get user media returns is a microphone track or a camera track, or both. The same thing is if you're painting pixels, you're doing some kind of drawing on your web canvas, you can capture those using capture stream on the canvas, and you get a media stream track. Same thing with media devices. So if you want to capture a whole screen or a window or a tab or something like that, it's kind of at the operating system level, media devices, get display media, gives you a media stream track. And last but by no means least, your incoming RTP traffic that turns up in a WebRTC peer connection is also, in the web terms, in the browser, it's a media stream track. And they're all the same abstraction. So it turns out that what you can do, and this is relatively recent, what you can do with a media stream track is to transform it. You can say, hey, for every frame, I want to do something to it before I pass it on to the rest of the WebRTC, the rest of the web rendering engine. And in this particular case, what we're doing is we're saying, well, I'm going to create a new frame, but as part of one of the constructor arguments is a rotation flag. So I'm going to rotate this flag, this new frame, and I'm going to throw away the old one and pass the new one back into the transform. So we end up with a rotated frame, which is perfect. So it's actually quite a clean API. So you kind of have the transform written as one function, and then you pass it to a processor which applies it to every frame that comes in. So this is actually quite clean. So this is the first strange thing that you can do. There is a problem, though, which is that JavaScript is single-threaded. And so doing work like rotating things, rotating 30 frames a second, on that thread will impact the rest of the UX experience. It will make it sluggish. And modern laptops have got tons of cores, so surely it would be nice to run that on a separate core. So how can you do that? Again, surprise number 2, you can do this in JavaScript. It is single-threaded, but you can have multiple single threads. You can create a worker which has in it doing something else. You can't draw to the screen, but you can do other stuff. And in this case, what you can do is on the main thread, you can say, hey, I'm creating a worker that will do rotation, pass that off, pass my rotation task off to this separate worker, and then my frames will get rotated in another thread. And so this works quite well, as I will attempt to demonstrate. This is a high-risk activity. So we have, with any luck, got a 5G camera. Come on, you can do it. Or not. Yes, there we are. There I am. So, hello. And I can rotate it. So if I click the rotate button, it rotates. And that's, what's interesting about that is like my mouse isn't sluggish. There's nothing else glitchy there. It's just working, which is quite actually interesting that you can achieve that without huge overhead. So, next problem, multiple viewers. Now, typically the way these things work is they take a screen and they put it onto the wall, and the crew stand around and watch it, and they watch the other monitors for all the other data as well. But there may be team members who aren't actually physically in the pit. They might be in the stands, they might be in the VIP suite, they might be somewhere else, or they might even just be a piece of AI software analyzing this. And all of those things still need a low latency feed, but we don't want to get it direct from the camera because that would double the 5G load. So the browser typically has a decent internet connection. It'll be on the local Wi-Fi, or it'll be Etherneted in or something like that. So what we can do is send a copy from there onto the VIP, and there'll be a bit of extra latency, but not a huge amount. But how do you go about that? Just kind of think of it as almost like an SFU. Well, it turns out that you can take a media stream track and send it, even if it's an inbound media stream track that's come from another WebRTC source. And you can do it even if it's being in use, being rendered to a video element, and send it on. So you can end up with this architecture that you get the stream from the car, you get it into the peer connection number 1 in the laptop in the pit, you draw that onto the video onto the wall, but you also send that one out, a second peer connection, to the VIP who's in a hotel suite or wherever. And this is done with actually not very much code. So surprisingly, that you can do this without having to kind of get clever about, I don't know, I actually thought quite hard about how I would do it, but it turns out to be really easy to do. And Chrome and the other browsers just sort this out for you, which is surprising thing number 3. So my next problem was, and I blame all the sports commentators for this, like they all wanted instant replay. Like, we want to see that thing again. Like, well, okay, that means I've got to record all of it forever, and just because you might want it. And where am I going to put it? And like, who's going to encode it? And stuff like that. So, and it's a computational and disk load that I wanted to try and avoid. And obviously you could do it in a media server, but we don't have one. So, then I thought, well, hang on, what about those video frames that I've been rotating and doing stuff with? Maybe I'll do something with that. And it turns out that you can cache them. You can cache them in the worker. So what we do is we cache, I forget, a few minutes worth of the video frames and just sit them in memory in the worker. And nobody cares. And so you can just put them into a ring buffer. And then when you want them, you can get them out again. So, and if people don't want them, they're thrown away. And it costs a bit of memory, but nothing else. So that's surprising thing number 4. However, they want to save the replay, right? It's no good just looking at it. They want to be able to create a copy of it that they can send to a colleague or a race marshal or the social media people or whatever. So, and this is surprising thing number 5, with web codecs, I can take a video frame or an array of video frames, pass it to an encoder, which is completely different from the encoder that was used to send the video in the first place. It can be a totally different encoder. In this case, this is VP9, and that's H.264. So it's a completely different encoder, different bit rate, different anything you want, and you can just run it through this in a worker, so it's not taking load off the main thread. Run it through this, and I've skipped the bit that actually writes it to the disk, but you can write it to the disk. So, even more risky. I'm going to try and do that. So we have, yes, that was risky. So if we enable, no, yes, no, do rev. If we enable do rev, we suddenly gain, well, I say suddenly, it's got to reconnect over 5G. Come on, you can do it. We suddenly gain a button, which is the rewind buffer. Now, unfortunately, I've got to put something in it, so I'm going to kind of wave my hands around and do things so that it looks like there's something in there. So we'll do that for another second or two so there's something worth having. And then we press save the rewind buffer, and you notice that like the thing is still reasonably interactive. We're not, like, the fact that I'm stashing all this doesn't seem to matter much. So we'll open a rewind buffer, and it's still writing it to disk. it's still writing it to this. Come on. No, come on. Yes, okay. So now you can view it. And there I am. And I can press play. And you can see me doing the thing I was doing before. So, yeah, so you can do this. And whilst this has all been going on, the video is still live, right? We haven't lost it. So that was kind of interesting, the fact that you could do that. And now what we'll do is we'll save it. And I'll save it to a name I can remember because I might do something with it. So now we can save it and go back to our presentation, wherever it's got to. Right. So, okay, I've saved it. I've got myself a WebM, but maybe I wanted an MP4. Or maybe the social media people wanted a .mov. So normally what you do with that is you throw it to an FFmpeg server, or you'd either run FFmpeg locally on your Linux machine, or you'd throw it to something in the cloud that turned out to be actually an FFmpeg. But I don't have a media server. So, and the file's on the user's laptop, and I don't kind of want to install FFmpeg on everybody's laptops because that would be unpopular. But what do? Yeah, I still want to run FFmpeg because it's the obvious way to do it. And I'd like to run it in the browser. So you just get the WASM cross-compiled version, and there you go. You've got your sixth stranger thing is that you can actually do this. And this is so there's an proper API, and you can wrap it up so that it looks tidy. But actually, you can also do it in a charmingly command line-ish way. So here is that. This is the WASMed FFmpeg running in Chrome. And you can give it now, you have to, it thinks it's, I actually have no idea how this works, but you can upload a media file. So we can upload our recent, if I can remember where I put it, users video probably? Movies, there we go. So there's our WebM. So we can upload that into the thinking space of this. And now, so that was, what was it? K World, no dash. I'm going to wish I'd copy-pasted this, isn't I? Actually, it'll be here. Okay, worlddemo.webm, and get rid of that. And now, so I'm going to take that and I'm going to convert it to MP4, but I don't want to do the whole thing. Maybe I only want to take the last, I don't know. So that's minus SS, comma, and I'm going to start 10 seconds in. And I want to run for, I only want, I don't know, 2 seconds of it, because I'm already a bit bored with it. So, does that look plausible? No, it doesn't. There's no comma there. There we go. Right, so now this is going to run this command line. No, I can't believe I did that. I did, and it's gone. Right, anyway, I'm not going to put through that. Well, I'm going to let it do the thing that it already knows about, because that's more boring. But basically, you can run the thing, and it runs FFmpeg in WASM very slowly, about 10 times slower than it would do normally on the machine. But if you're not converting codecs, if you're just trimming or something mathematically simple, it doesn't matter. This transcode is going to take too long, but I will, if anyone actually wants to see that really working, I'm happy to demo it later, but I'm not typing live anymore. Right, so that's FFmpeg. running in WASM. So I want to summarize this in saying that like the web browser is a very capable real-time media engine where you can do really, I say they're strange, but they're kind of unexpected. It is not a SIP phone in your browser. It genuinely lets you get at the data, get at the thing, re-render it, do stuff with it. You can transform streams, you can run on separate threads, you can cache things, you can re-encode things, you can write things to disk, you can run any of your old Linux software that you want in WASM. I mean, really. Without needing a media server. So you don't have to have a media server to do any of this stuff in the cloud or anywhere else. So yeah, that's my little story. Very happy to talk to anybody about it afterwards, outside, whatever. Contact details there. Tim at Pipe, Stiegel into Chaos Social. I do consulting on open source, WebRTC, Pipe. Actually also on W3C and the ITF. And I should give image credits there. The images for the countdown thing, count up, whatever, are actually Stranger Things posters you can buy from Netflix. And the Merc was at the Dubai 24-hour rally, and it was one of the PR photos. Now, I'm going to put these in because they help me here, because I am a bit deaf.
Okay. Okay. Thank you, Tim. So, time for questions. We have Yuri back in the corner.
That might be not exactly a question, but there is a video rotation RTP extension header, which you can path, and then you will be able to rotate video right on the fly after renegotiation. So that's a little tip for you.
So
instead of doing this in JavaScript, it's a built-in into the RTP.
Yeah, the question then is, how does it know? It needs to be a user request.
It sends.
So you'd have to send a data channel message to the far end, to the camera, to say, hey, set a renegotiation. And then you do an offer answer, and then maybe Chrome would render it the other way up.
Yes.
Right. This is quicker. Like, this is a single click, stays in the browser, and that doesn't have to do a round trip, two round trips.
This is expensive, more expensive in your case, because of you doing rendering and then re-rendering. Because if you receive the frame and then re-render it.
What I didn't say was that Chrome actually optimizes that, because what it does is it sets the bit in the codec header, which says, by the way, this is rotated. It sets the 3GPP rotation flag. So although I did that in a worker, I didn't need to, it turns out, in Chrome, because Chrome just sets the flag. So it's actually a low energy activity, and I can do it locally. I don't have to round trip. But yeah, I mean, if the camera knew which way up it was, then perhaps that would be the right way to do it. But there's no switches or dials or anything. There's no settings on it. It's a dumb box, as dumb as we can make it.
It's not a dialing, it's standard. So if you use WebRTC, the WebRTC library is already supports, and if that built-in camera, so it's just runs.
Yeah, we could.
You could, but
no.
Yeah.
Okay, so we have Fred here.
How many connections are you running on a camera like that?
How many connections? In what sense?
Well, like you said that there's like people in the pit and then some other people.
Oh, it's very limited. Like, I think the most we've ever had of the VIPs and that's is like 6 or 8. We're not, like, it broadcast is a whole other thing. That's another game. Typically, there's only one viewing station, and that's in the pit wall. It's just in exceptional cases they have like an investor or you know, the brand consultant who's swanning it up with champagne in a hotel room and needs to see it. So it's a very small user group, and deliberately so.
Okay, for further questions, you'll be around, not too delayed because we started with some delay and then the panel took a bit longer. Thank you, team. Really appreciate it all, sharing all this.
The topic has changed like throughout the day, because it started with like the fact that we are doing millions of calls per day, tens of thousands per second or per minute. What I found was like to tell you folks that it is possible is preaching to the choir. The main thing I would say is thank you to the work that you all have done over the last 20, 25 years, because it made it super easy for us to do this. One person, part-time, over the last 6 months. We were able to set it up, get it out. One of the things that has been enormous for us, Daily has been doing WebRTC for the last 10 years. We now jokingly say that we did human-to-human calls, and now we are doing more human-to-machine calls. And Pipecat actually allows us to do that. But the underlying technology is still like SIP, WebRTC, and in many cases, some folks are using WebSockets. So shout out to Andreas, who started the day. He actually took half the thunder out of the talk. And it's really hard to follow Tim after his demo, because his demos are always exciting. That being said, I'll get into it. So voice AI in the last, since ChatGPT launched, like we got it in our phones, our desktops, we could chat with it, text with it. And immediately we knew that if we are able to text to something and can respond back, we should be able to like transform our voice into speech to text, which has been, people have been doing meeting notes for, maybe like last 7, 8 years. So real-time transcriptions was already there when ChatGPT launched. And the only thing that was missing was the text-to-speech, which was very robotic in the last couple of years. It's improved vastly. But in the last couple of years, we've also seen that the need for voice AI has greatly increased. There are two aspects of it. One, people are overwhelmed with SMS emails. So people have found that if you call someone, people will pick up the call. So, it's just a method or a means or a channel that was underutilized until now. So people are happy to take these calls. And the other thing is support has been like the biggest mainstay for us. So, if you think about voice AI, people say, the holy grail problem that we want to solve is all the support. So very quickly, today we have dial out, which is like the biggest portion. It's fairly easy. Voice AI, the bot knows what it needs to do. It needs to call up a person, say something to that person. It's very like the guardrails around this is like super strict. If the other party says something else, it can just drop the call because it made the call. Like it doesn't have to like satisfy the end user's questions if it goes off the rails. In the support case, that's kind of hard because like the person called you, the business, and now the bot is answering for you. So you can't necessarily like do that. So dial out is like the fastest growing and probably the largest portion of like voice AI today. Dial in is growing very fast. I think for small, medium businesses, this is nearly a solved problem. But if you're thinking about Fortune 50, Fortune 500, where like your support queues have like tens of SKUs or tens of products that they need to support, 20 other things that they have to like take care of, then it becomes really complicated because now you are telling an LLM that there is like a matrix of features, products, things that it needs to support. And just like humans, we have like a cap on like how much we can do. And we've already, of the last 30, 40 years of running support call centers, people know that it is like tier 1, tier 2, tier 3, tier 4, and as complexity of the issue, you escalate in that way. So LLMs not necessarily need to like follow that kind of pattern because we actually know that pattern very well. But I'm here mainly to say like, these are things that are already happening. And I think we are embarking on a journey with voice specifically. I think it's like the future because, and I'll come back to this later, we've been told, like if you watch Star Trek, if you talk to any like space, if you've seen any space opera, they've been talking computers from there, like from the beginning. From the 70s, we've imagined a world where you could talk to the computer. We've not had it till now. We've had Alexas and Siris, but not really. But now, in the last couple of years, people have used the OpenAI real-time, have used Gemini. People are talking but they're talking to a thing that is just an interface to an LLM. There are other interesting things that are happening where there's companies like Whisper Flow, there's tons of companies which are like, see a text box and you can talk into the text box. So any text box, instead of typing, instead of your keyboard, voice becomes input. So I think there is a whole new area of space that is unexplored that is going to be explored by us and other people in the world. So, just thinking about conversational toys, there's a bunch of them already out. Education, if there's a use case for speech-to-speech, it is education because the LLM, the speech-to-speech model, already has intrinsic knowledge that you can probe. You don't have to like give it more guidelines. Apart from like saying like, hey, it's a 7-year-old talking to it or a 70-year-old talking to the thing. So, change the cadence of how you're speaking. You may have to elaborate, you may not have to elaborate, things like that. So elder care, education, robotics, social avatars, like there are tons of use cases and there are many, many more that you will all imagine. So a little bit about us. Daily does WebRTC, but Pipecat is fully open source, vendor neutral. So even though Daily supports it, we support every major provider. So Twilio, Bandwidth, OneEdge, SignalWire, anyone like that. We also support every speech-to-text, every text-to-speech, every LLM provider, self-hosted or on the cloud. So all the Qwens and the Voxtrals and the Mistrals, they're all supported. You can run it. I have a 128 GB M4 before things became very expensive. I can run the speech-to-text, and it's actually probably running a speech-to-text locally and an LLM and TTS. The LLMs are kind of hard to like run locally because they're not that intelligent. But we sit right in the middle of this API stack or the stack. So we just do orchestration. We call it orchestration. Now people call it harness. So if you think about coding harnesses, so just a segue, voice AI, if you work with voice AI, some of the things that you run into or encounter, you will see parallels of it like few months down, like 2 months, 3 months, 6 months down with the coding harnesses. So like a year ago when we said, when you use this STT-TTS LLM cascaded pipeline, and you get into like turn 20 or turn 15, like talking to the LLM, at turn 20 or turn 15, it'll start hallucinating. So the problem was the context was getting full. You needed to do something, so you had to compact it. You had to figure out how to compact it. And now you see, like, if you look at any kind of, if you use Claude or you use Codex, you see the auto compaction, or the fact that as soon as you get to 100,000 tokens or 250,000 tokens on Claude, you manually yourself, before it starts to hallucinate, you say like compact or clear, like give me the summary. So we're all like in the coding harnesses. We are now actually realizing what the voice agents actually already knew a year ago. It's just that we did not actually understand if this is the right thing to do. So keep an eye for that, because as you build voice AI agents, you will run into these kind of greenfield areas where you will have to come up with solutions that you think are appropriate for you, which everyone else will frown upon, and then wait a few months, and then coding agents will copy that. Or not copy, they'll invent it independently, and you'll realize, oh, it's exactly what we were thinking, or very close. So typically when I talk about this, I say a voice agent is just an agent in a loop. The only difference between a coding agent and a voice agent is that the input is different. It has all the same issues. You have to context engineer. You need to have some understanding. You have to figure out reasoning, and there's a response. The other part is latency, right? I think Andreas talked about you really want to have the bot respond to you. Coding agents, they show you this kind of blob or thinking, or show you curl commands that it's running in the behind, or terminal commands that it's running behind, so you know it's doing something, but they're super slow, right? It can take sometimes 3 minutes for it to do something simple, and then 2 months down the line, that same thing takes 5 seconds. So they figure out the latencies and they are compressing that. But with voice AI, we have that, the goalpost is already very close for us, so we need to hit those latency metrics from day one. So very quickly, so you can have a speech-to-text, context management, LLM, text-to-speech, some more context management at the end, audio in, audio out. Turn detection, the main difference between text and speaking is text is super easy because you press enter. And you're not streaming your keystrokes to your LLM. You're pretty much when you press enter, that's when the LLM gets invoked. With speech, it's kind of hard because you have to detect when a person stops speaking. The simplest thing is you use VAD, voice activity detection. You wait half a second, wait 300 milliseconds, wait. VAD is also very dependent on your use case. So if you build a thing for the older generation or for the young generation, under 10 years, your VAD has to be super long. You can't have the bot interrupt. We built just a segue again. We built an app really early in 2024, December, called Santa Cat. Was in line to launch with. So this is a year after ChatGPT came out, 6 months after the API was released, and we said we need to get text-to-speech sucks, but we need to get something out that shows the world that this is possible. And we said Santa Cat instead of Santa the person, because it was difficult to go over the fact that the voice was terrible. But as soon as you reformed the Santa to a cat and the pitch was all over the place, it was totally okay, because you've morphed the output from a human sounding to something anthropological, so people were fine. But what we realized, we gave it to it was Santa Cat. What we thought, people will give it to their kids will talk. And the first question Santa Cat asked the kid was, what do you want for Christmas? And the kid was immediately silent for tens of seconds. And our VAD would fire 5 seconds later and say hey, you didn't answer. Can you tell me what you want for Christmas? 5 more seconds. So now the compounding problem is that every 5 seconds this app is asking the kid, who's still not, it's interrupting the thought process of the human, which is the kid, because it's not able to formulate the answer in time. So be conscious of who your target audience is, especially if you go beyond the dial-in, dial-out use cases. So in Pipecat, this roughly maps to an array with things in a line. So you can have like transport, that's input, STT, context, LLM. You can also create a sub-array, which basically creates parallel pipelines. So if you want to, like, for example, the simplest example for you all would be, you call a phone number, it rings, someone picks up. It could be voicemail, it could be human, right? So if it's voicemail, you need a voicemail detection. LLMs can do that, actually. So you need to like send the audio to 2 places, transcribe the text, and then have the LLM decide if it's a human or it's not. You can't have one LLM decide the same thing because it would be too slow. So you want to have 2 different prompts going to the LLM saying like, if it's a human, say the greeting, like someone said. If you detect it's voicemail, here's the canned voicemail, tell me, I will send a voicemail response, right? So you have a parallel pipeline which kind of works that way. And after the first turn, there's no voicemail after the first turn, so you can drop the parallel pipeline after that. So this comes to the heart of the thing. I wrote to Daniel a couple of months ago. I said, hey, we've been doing SIP. I would love to come speak. We're still rolling out. We'll see how it goes. So SIP at Delhi, you guys have done a fantastic job. The only reason we built on Kamailio was compliance and mainly static IPs. So we have customers in India, we have customers in Europe, we have customers in the US, all 3 areas with high compliance. They want like the SIP to terminate in India or in Europe, in the US. Similarly for media. For media, it was easy. We always had instances in 12 geographies, so that was not a problem. But having global SIP meant that people frowned upon it, because if you load balance across the world and like it doesn't land up in India, then the Indians are unhappy. It's the same thing for the Europeans. And also thank you for all the work that Homer's done, because one of the ways we were able to get really quickly into the market, like within like 4 days of like load testing the system and handing it out to like one of our first customers, was because we had observability also on day 1, without having to think too much about it. So we offer 2 ways to do this within this. So one leg, Pipecat directly speaks SIP, so it connects directly to Kamailio in our case. We'll expose a new API which will allow it to register to anything. So it'll be truly open source SIP. It's not tied down to like our Kamailio instances or any. It can be sent to any SIP provider. There's no SFU involved in this case. So it basically means the caller calls a phone number, which may be on SignalWire, Twilio, or some contact center. The contact center sends it to our Kamailio. There's an RTP engine. Then we have Pipecat bot, which has the SIP transport, RTP transport. The main reason is that SIP and RTP here is encrypted, and the Kamailio RTP engine basically handles all the vagaries of SIP, right? So like if we get no unencrypted RTP or some other form of RTP, we are like, yeah, RTP engine solves that problem. We don't need to like take all that complexity down to inside Pipecat. So this was really useful for us. SIP refer comes out of the box. So for most simple use cases, like the call comes in from the contact center, the bot answers. When the human says like, I want to send, I want to talk to human, or Pipecat decides that it can't answer the questions, it can escalate to a human. So SIP refer works in this case. So architecture 1 was fairly straightforward for us. Architecture 2, which was the SFU based, the main reason for this was, as Tim pointed out, there are so many use cases where there is a need to do something, like where you would want to record the call, or you want to have like barge in, some silent whispering happening. So in this case, we have like the carrier, then this can be anyone, Twilio, SignalWire, Telenex, or a contact center. It calls our Kamailio, it calls our RTP engine. There are multiple SIP workers, so the SIP will terminate before the daily room, which has the SFU. So each user gets a single track audio and video if they do SIP video. Then you can have a Pipecat bot, you can have a human agent, you can have recorders on the daily room, which will do this for you. How did we scale through 3 geographies? I think there was a push to talk on a text notification talk earlier today. Her slides were much better than mine, but it's very similar in that architecture that we have SIP US, SIP EU, SIP India. There's Kamailio 012. There are 3 of them. I think we use DMQ. I think there was a talk about that. And there are similar trifecta of servers in each geography. Going down, so if the call comes to SIP US, then you have the worker selection. So the call needs to go to a particular SFU. This is decided by our backend service. It decides which SFU it needs to go. It'll spin up the SIP workers and the RTP engine. It's a strange model. We have, for every SFU, there's only one RTP engine, partly because RTP engine is also very high performance. We tested it with like 10,000, 20,000 calls, and it works really well. Our SFUs typically for audio video do thousands of calls. For audio only, can do tens of thousands. So we realized that we could just, actually we could have multiple SFUs use a single RTP engine. The only reason we went with this design was shared failed state, because when we take the SFUs out, we would have to maintain state of like which RTP engines belong to which SFUs. This makes our life very easy. If you're taking away the daily SFU, then the RTP engine goes with it, and it will unsubscribe from Kamailio as well. So the only problem, and I think we'll send a patch up to RTP engine, is that we run, I think, thousands of RTP engine right now, and like we have issues with, we had to patch things in Kamailio to like support thousands of RTP engine, mainly because of this design choice that we made. One easier way for us might be that we may actually go down to multiple SFUs using the same RTP engine. But that is not probably something that we're going to do this year. And as I said, the whole reason for doing something like this was we have use cases where the call escalates, the bot talks, the call escalates to a human, but then the human needs coaching or help. The bot whispers into the ear, just like a supervisory human would have done. So there are use cases where the bot sticks around, still transcribes the call, follows the call along to improve itself for the future, but also to say, hey, I actually looked up what this person's talking about. Here is the data for it. So, and doesn't need to communicate back to the human to say like, they are in observation mode. So there are interesting use cases that we think this resolves. So lastly, the simple thing is use the SFU only when you need more participants in the call. You can just go direct otherwise. So this was about the SIP quickly transitioning. As I started, like we really want people to build more compelling systems with voice. I think we are very close to actually having that kind of solved, in the sense that I think the latencies are around, like within the benchmarks that allow us to build something that is usable. You can build, the LLMs are smart enough. There are already multiple tools, harnesses out there that can help us build more compelling use cases. So today, most voice agents are just a request response loop, just like your chat. Like when you chat, there's only one thing that's happening. You're talking to ChatGPT, and ChatGPT is responding. You can open another thread, which is independent, and that's an independent thread. But if you look at coding harnesses, that's where you start to see like where complex things can happen, where you can call sub-agents. You can say, sub-agent, go do research while I plan, and you can write test cases before I start writing code. And those are all from like the main context being spawned. You can decide to give them part of the context or no context, totally up to you, right? So if you want to take that back to voice agents, that should be possible. You should be able to like have use cases where you call a support line, and like the main agent talks to you about like making sure that the conversation keeps alive, while it spawns sub-agents which go out and do things for you, the main agent. And if it all fails, you can always escalate to a human, right? So we've been talking about this for half a year now, and last autumn we started to embark on this journey of, we said like, we have to tell people that this is possible, but it's really hard to like build something that is compelling for most people. Like if you do something like a dial-in support, people are like, my RAG is slightly different from, my MCP tools are different, my database looks different. So it's kind of complicated. You can't get people all the way there, partly because everyone's use cases and their understanding of their systems is very different from whatever you try to build. So lo and behold, we said, what? We don't know anything about games, but we all love games, and we wanted to build a computer that we could talk to. So we've heard about these games, since 1970s, we've seen Star Trek. In 1990s, there was a game called Trade Wars. It looked like this. It was on BBS. I think it started in '86. It's still running, I think. But it was played between '86 to 2005. It was basically a TUI, so a terminal UI. It started with just like ASCII art. This is a more modern version of it. Some of it looked like this. So you entered commands. You said move to sector X, and then something might happen in sector X because like maybe your friend was there, and you may say, okay, let's go do some trading, or an enemy was there and you would fight, right? So fairly straightforward, but we basically wanted to build this and recreate it. So I'll show you a quick demo. So this is live. It's also open source, so you can download the source and run it yourself. You can probably already see like a lot of the UI from the screenshots look very similar here. So this is live. Hopefully the computer is still here. Hey, how are you doing?
Still here, same as ever. Steady and watchful.
All right.
You need...
We were running a trading loop. I think I'm low on fuel. Can you go to the nearest megaport and refuel?
The closest megaport is in sector 472, about 7 jumps from here. I'll set a course and get us refueled.
All right. Well, while we're going, can you also trade? Because we have empty holds. So we could do something like neurosymbolics and trade buy low, sell high.
We're heading for sector 472 to refuel at the nearest megaport.
So one of the things that you may have noticed that it went from green to blue. It was working and then it steered. That was basically the LLM re-steering itself.
Commander, what's on your mind?
Okay, can you do the trading while we're going on the path?
I'll keep an eye out and buy low, sell high on neurosymbolics at any port we pass, so long as it's worth the credits.
Sure. What's Bumblebee doing? So the idea here is that I have 2 ships, and I have one computer which can control both the ships, and it will respond. And it's spawning, just like in OS, it's spawning like processes in the background which spawn their own LLM threads and like go off and do things. Then the main thread, the main LLM has like basically a process, like a heartbeat, keeps track of like what's happening on all the other processes. If something does not respond, it will go and kill it or restart it, depending on the rules. So much like a small OS. So you can see like it bought something.
Bumblebee's idling in sector 472 with full warp power and nothing on its task list.
Can you send it out to explore sector 907?
Bumblebee is now exploring sector 907 for you.
So you just saw it refueled as well. It arrived, it didn't ask for confirmation.
We've arrived at the megaport in sector 472, refueled and managed a net profit of 660 credits trading neurosymbolics along the way.
I don't want to leave the Federation space, but can we do a trading loop of buy low, sell high, neurosymbolics in adjacent sectors?
Bumblebee finished scouting sector 907, which is still in Federation space and has a standard port for trade. We can stay within Federation sectors for buy low, sell high runs.
So I can keep playing the game, but you all can also sign up and play it. As I said, it's fully open source. You can download it, put your own keys, play with it, or you can go play it online. the idea here was to show that the latency is not that big a problem. Of course, there's a UI here, so I know actually what's happening. When you build new interfaces, that is something that you have to think about. Like if you want to build voice AI and some new voice AI, then keep in mind that there's a visual component that is not going to go away. So you'll need something to control the UI, and the LLMs are already fast enough. So as you could see, like the main problem was the text-to-speech was a bit behind, but was already doing the actions in real time. So that was actually going to be my last slide. What I want to show is that long-running tasks are possible. You have the main LLM, which you can call the harness, which will spawn sub-agents, which you can control through a bus or through whatever paradigm you want, mainly like an operating system and threads and processes. So that's my last slide. Any questions? Fred. Actually, I should give a shout out. I should give a shout out to you because literally we had APIBan set up from day one, but it was very useful because as soon as we turned on, we got scans like within half a second of like going live. So thank you very much.
Okay, Fredo's there.
So I'm trying to process the thousands of RTP engines. So how many simultaneous calls are you, I mean, you're running millions and millions of simultaneous calls, or?
Some of the RTP engines exist because there are SFUs on video SFUs, so they just sit idle. But we do run, I think there are customers who have 1,000 CPS, but it is very bursty. So 9 o'clock EDT is crazy because like all the debt collectors, all the use cases around like telephony just start up like at 9 o'clock, and they'll stop at 9:15, but then at 10 o'clock they'll start again. So thousands of RTP engines because each SFU has an RTP engine.
So how many, so you're running one?
One what?
Or how many calls do you put on an RTP engine?
Oh, I think right now up to 1,500, 5,000, between 1,500, 5,000.
Thank you.
It's mainly, so the reason is the complexity of our architecture is that we run the same infrastructure for video and audio. So we don't partition calls like saying, oh, you started audio-only calls and here are audio-only SFUs. So a lot of the audio-only sessions are shared with video calls. And there are also use cases like webinars, which thanks to the pandemic, I think no one's doing like 1,000 people calls anymore. They're done and dusted, it's out of our system. But we also have some use cases where someone can spin up on the same infrastructure a call which has like 5,000 people in one room, and then have like 2 people call up with SIP, which is like, yeah.
Okay, thank you. Any other quick question, but very quick as we need to. Thank you, Varun, then, for everything and being here.
I think this is a picture from last year or so. People who were here in the last years might know the format. It's deployment on stage. A few people presented a few slides. I think 6 persons today. 5 slides per person, 5 minutes, and yeah, let's start. It's about your deployment or whatever you want to share. Yeah, here are the names. I prepared the slide and started filling it at the beginning, so I'm going to start. And I have a timer. 1 second. 5 minutes per person. Okay. My name is Andreas. I'm working at Zipgate on the other side of Germany in Düsseldorf. We have about 250 employees and offer cloud-based telephony services for mainly business customers. And our people who were here last year might have seen the talk from my colleague Jonas, quite small here in the right corner. You can watch the video from his talk using the link or QR code. It was about automating our different Kamailio roles, how to keep them up to date or what our plans are. And my 5 minutes are about a small update for this. We have more than 10 Kamailio roles in our network. And it was in the past a nightmare to keep them up to date. Small picture of our history. I think that's even not all our roles. We had some random year versions from 5.1. They were drifting on all nodes to different versions. When we had some problems, we might needed to upgrade one of them. So this was upgraded to 5.6 or whatever. And in the end, we had different versions of Kamailio running on different versions of Debian. And then we just decided this needs to be changed and started upgrading all of them to a common baseline. It took us about 1 year to align all of them. They're using a shared Kamailio Docker base image. And while updating them using this base image, we added also for each of the roles quite a few integration tests. Altogether for all roles we have approximately 400 integration tests, mainly based on the P, running automatically in our pipelines to check that everything is working fine after upgrading. We ended here with our last one, the zip load balancer facing our customers, so the main workhouses, in February, beginning of February this year. The last one was on the common baseline. And then we said, okay, we are fine, we can do first something else, and let's see when we are pressing the button to update all of them. But then it didn't took long, then there was a Kamailio security issue. I think it was end of February. An MSRP null pointer issue. I think it was first distributed via mailing list, and I can't really remember, but I think some special packet could kill your Kamailios. So it was a bit risky, and we thought, it's worth to start the upgrade. We have 32 dev nodes, if I counted correctly, and 55 different live nodes. And let's see if our 1 year of work was good invested. The update took not that long. So at I think it came out on Friday, and we decided, let's start on Monday. It's hopefully not that risky, and in worst case, we have to start on the weekend. So at 10:45, a colleague of mine applied the patch, and our pipeline started building the Kamailio image, going to 10, 11, 12 different repos, starting the integration test of all of our Kamailio roles. At 45 minutes later, the dev rollout of all of these 32 dev nodes was finished. All tests passed. We were lucky. Nothing changed in code that some test was broken. So 2 minutes later, he pressed the button for the live rollout. it started to run. We have some live rollouts. At first, one node of each role is updated, then check some graphs and so on. At 12, lunch break, 1 p.m., the live rollout ended. And there was a special one, customer load balancers with TCP connections. We did all only in the evening to not cut off our customers. So everything Jonas presented last year, our plan was good. And the next stuff we plan to do is then quite soon to update to the next. That was it? And to update to Kamailio 6.1, I think it is. I think we can do it without risk now. Next one. Thank you. Ivan.
Hi, Ivan. I'm just going to talk about some projects I've worked on and left them publicly so that others can also make use of. Probably you'll find them useful. I have a disclaimer because I currently work for Airbnb, so I'm supposed to say that these are my views and not that of Airbnb. Anyway, so fun fact, I think 15 years ago-ish, Simwood used to provide honeypot data, and then they stopped, I don't know, probably for legal reasons. Anyway, I used to be going there to look at the data. Yeah, that's how interesting my life was. And 5 years ago, I decided to figure out if VoIP attacks were still a thing. So I built a bunch of honeypots and started to analyze the data. And I wrote a blog post about it. Well, spoiler alert, they are still a thing. I ended up releasing the data, making it public so anyone can go and see it. Updates every hour on the website, so if you're interested, you can go and see. And then the data is also being pumped to APIBan we heard about earlier today, powered by Kamailio. The next thing was one interesting vulnerability we saw, or I saw on the honeypots, was that surprisingly there are a bunch of servers out there that are open relays. So out of the learnings, I decided to build something where people could go and just test their server to figure out if they are vulnerable to the open relay. And again, powered by Kamailio. Now, there's from time to time, I used to have to be able to do some failover testing on trunks to figure out if some platforms are responding well to responses. And it was kind of annoying that web devs have a bunch of services where they can just go and test the APIs. But for SIP, one doesn't really exist. So anyway, after using it a bunch of times, I decided to make it publicly available. It responds to 306, so 3xx to 6xx errors. The redirects will work if you follow. You'll get back 200 from the same server. The idea is really simple. You just put in the last 3 digits should be the error that you want back, and I send you back the error, powered by Kamailio. Now, to probably make Gemini happy, because earlier today we saw or heard how Gemini is unhappy with the number of modules that Kamailio has. I built this MCP for Kamailio documentation, where you can just add, and I mean, you have the option. You can either blow a bunch of tokens by sending your agent to the Kamailio website, or you can add the MCP and blow less tokens for it to figure out which of the modules and functions you're looking for. So you just added the standard way, that's an example, and it supports from version 6.1 to 5.4. And yes, I'm now working on Kamailio server MCP. I was hoping to have it done by Kamailio World, but that didn't happen. I was kind of pressed on with time. It's basically just an interface for the RPC commands. So what I'm left with is a lot of documentation to help people figure out how to use it. But the stuff I'm using it for currently is just for stuff I like to use: the HTable, dialog module, permissions, and a bit of some of the core functions. And I'm avoiding the delete function so that no one accidentally has an agent delete any of the functions. And with that, yeah, I'm done. Thanks.
Perfect on time.
Hello, I'm Cesare. I returned to Kamailio World after a couple of years break, and I'm going to show you a little bit about the Voice Blender. This is my pet project, which I've been working for a couple of months. Yes, so the Voice Blender, it's a cool application that allows you to create and answer calls, perform lots of actions on the calls, and put them into rooms, and also do cool functions in the rooms. The main function of the room, it's mixing all the calls that are in the room. What it can be used for? It's for call centers. You can build full-featured call center. You can build any kind of AVRs. You can connect to all modern and all post-node AI vendors. It has support for many. Go and check it out on a GitHub. It can build dialers if you want to, if your customers like dialers. It has answering machine detection, which is working quite well. And yes, you can create PBX, although there are some few functions missing to create your own PBX. And luckily, you can create tests, which actually Voice Blender, it's using Voice Blender to test Voice Blender. So you can test it. This is how it looks internally. So you have the legs, and legs could be SIP, it could be WebRTC, it could be WhatsApp, and it could be WebSocket. And then you have the rooms engine that mixes all the calls together. Also provides all lots of functionalities, voice activity detection, muting, unmuting, deafing, undeafing, all the functions that you can imagine on a call. And then you have the integration for TTS, speech to text, and AI. And of course, there is this API to communicate with the Voice Blender, because Voice Blender cannot do anything on its own. You can either talk to it using a RESTful API or WebSocket. This is how I use it. So basically, I have two Kamailios, one for where my customers are connecting to, and Kamailio does authentication, sanitizing, and everything, checking some balance, etc., etc. And on the other side, where Voice Blender makes outbound calls, there is another Kamailio, which is basically integrating all the PSTN vendors. And there is, of course, so the application that controls the Voice Blender. So this is how basically you create a call. How you use Voice Blender. So you can create a call. Once the call is created, is answered, you get, of course, you get an event when the call is answered or declined or whatever is happened with the call. You can add it to a room. You don't need to, but you can. And you can play TTS or audio to a room or to a call. If you play it to a room, so everyone in the room will hear what's being played. If you play it to a leg, the only leg will hear it, and you can disconnect. Of course, you can add recording, either leg or room, etc., etc. Yeah. So if you are interested, go and check the website or GitHub. It's open source on an MIT license, so. Very permissive. You can start building, and you have lots of new features coming up and lots of new ideas that I can add or we can add together.
Thank you. Also on time. Next one, I think it's Santiago.
Okay. Thank you. Okay, pressure. Okay, first of all, thanks to all as a community, and happy anniversary. Also, thanks to Bascom. They are not professional streamers, but they seem. And okay, I'm presenting 5 minutes of architectures, and it's part of a longer presentation along with other updates where we use it or we can use Kamailio for things. Okay, I'm Santiago Troncoso, born and based in Vigo, that is Galicia. I'm really proud of it. 15 years working here on this, on the voice over IP. And recently I joined Technische, that since 2021 is empowering BSS and OSS operations on mobile network operators. And is the technical layer of Telnes, one of the founded brands, and along other ones that are joining the platform, and they are the proud creators of Seamless OS. Seamless OS is an API-friendly and modular architecture that brings all these operations easily, but also we want to enhance the voice applications that we want to provide to our customers. Okay, so during this work, I was exploring a lot of different architectures, and this part of a longer work. And what we are exposing here is the event-driven architectures. Is these architectures where we shifted from the monolithic idea that we had originally of the SIP, and the SIP edge usually should be all the application itself, and all the features could be done in the same thing. But nowadays we usually have this orange side of the network where everything is blurry and different kinds of events are required. Okay, REST APIs and other kind of stuff. So scalability, Kubernetes, and so on changes the paradigm. Also, the eruption of the artificial intelligence and the voice agents also changed everything. So what we try to use is to have these distributed, highly specialized components, and that or mainly suggest for this. Okay, so Kamailio is great as a SIP edge, as a SIP engine, and it's good for what is good. So I really recommend to use it for what is created and not to build everything on the top of a single element. And also, I want to bring some updates about the Camara project. The Camara project is a Linux Foundation project along with the GSMA in order to expose 5G features that to be easily consumed by developers worldwide. And the last year I presented the Camara Web ETSI project, and this year we were able to add the emergency call signaling requirements and also the located call requirements to enhance the session establishment. And also I'm participating also on the verified caller that allow us to bring branding calling along with also identity of the colors. So that's mainly, and also there is a really nice published procedure in order to distribute the releasing process across a multi-distributed team, that is the autonomous review process, that it's fully AI automated. And remember, AI is good for something that you can reproduce, that you can mechanize, and then you can repeat. So the boring stuff is the thing for machines. So use the Kamailio for what it's it, use it wisely, and look for the correct piece for your architecture, and probably Kamailio appears in the middle because it's 25 years creating a very big, good software. Okay, so here's my contact. Ping me about anything that you want, apart from this voice and RTC space, and also happy to share with you for with any other content. So thank you very much, and thanks for this amazing community.
Yeah, perfect timing again. Next one is Surendra.
Thank you so much. Thank you, Daniel, for arranging this meetup. So basically, I'm going through Kamailio in real world. So how I'm using from my first startup to till now in different use cases. So first of all, right now I'm using Kamailio with Microsoft Teams. So Microsoft Teams provide 3 ways to connect. First connect model, then extend model, then unify model. So with direct routing, it's allowing us to connect over the SIP. And that's where Kamailio coming into picture. Second part is WhatsApp voice. Again, WhatsApp voice allow us to connect with 2 ways. First is WebRTC way. So signaling happens over REST and media happen over WebRTC. Second way is connecting over SIP. Again, that's where coming to picture. It's allowing me to connect with the WhatsApp user over the SIP. There are certain things like UAC model that Daniel mentioned. We require UAC model to authenticate outgoing calls. Of course, we need to obtain user consent before making outgoing calls to WhatsApp user. Third part is, of course, like we can do WebRTC connect to Kamailio, then SIP carrier and trunk providers. Last part is AI voice platforms and voice port connectivity. So we can connect with the Kamailio over SIP, and if we use Kamailio with RTB engine, we can connect with voice port over WebSocket streaming. Now let's go with the massive scale like performance. What I have achieved with Kamailio. So I have achieved like 10,000 plus CPS, and if I talk about volume, so I have achieved 100K plus concurrent calls. Of course, this is not one cluster. We have done with multi-cluster Kamailio setup, and of course, like users, we don't do the multiple WebRTC based users. It's like 10K plus only users, and the setup is activity setup, HA ready. We are using VRP protocols. That's allowing us to make sure if one particular cluster is getting down, another cluster is getting over. Of course, we can deploy the Kamailio using Docker containers, Kubernetes, CI/CD, GitOps. Now, what I'm doing now, so I'm using LLMs to work as a developer for me. I don't require specific developers. I require the person who understands the Kamailio. They can plan for me. The execution I'm giving over to AI. So AI is writing me the routing logic. If I need to solve any particular bug, any particular, like I need to write any particular module, that AI is writing for me. Again, if I need to identify any particular routing issues based on logs and all, that also LLM is doing for me, like monitoring and self-healing. Now last part is upgrading the Kamailio. Of course, there are a lot of CV coming into pictures, lot of issues coming into pictures. We need to upgrade the Kamailio. That's where again I'm using AI to read the release notes to perform the automation testing and upgrade the Kamailio in lower environments. And I don't require any particular QA to do automation testing for me, to do any manual testing for me. That's why again, this work is in progress. Once I have like conclusive evidence to do it with AI. Last. Thank you.
Thanks a lot. And finally, sorry.
All right. Hello, so my name is Tori. I've been doing SIP since the year 2000, roughly. And I'm going to talk about SIPREC, which has some new features that have been added into Kamailio to allow you to actually implement SIPREC flow with some lifting. So the first thing you need to do is, well, obviously, you answer the call. You do the RTP offer, you do the answer, and then after RTP engine has that stream and you have the to and the from tag, then you have to send RTP engine a subscribe request to tell it to Forti Media. And in the case of a SIPREC, you pass in the flags all, because you want to fork both the from and the to tag. If you want to fork just a specific leg, you could use a from tag and say from tag equals and then the tag name of the specific stream you want to port. Then you specify an AVP where the SDP of the SIPREC will get put into. And then you also specify another IP for the SIPREC 2 tag. You can leave this blank. If you leave it blank, it will generate an ID for you. And this is just going to be the way in which this RTP engine is going to recognize this additional leg of the call. And then the last thing you specify is the XAVP that will store the information about the streams. This is going to be the correlation between the labels in the SIPREC SDP and the tags that you know in the SIP. And then it's up for you to keep track of which SIP tag is associated with which SIP URI. In case you don't understand how XAVPs work, I didn't really know about XAVPs before dealing with this. This is how you deal with the XAVP. So you, say in an example, we gave the XAVP name SIPREC streams. You can you can call count, and you see that we have 2 streams, a from and a to. That should be the normal. And then for each of those streams, you can get the tag. It's going to be either the from tag or the to tag, depending on which leg it is. And then for each of those streams, you will also have 1 or more labels. If it's just an audio call, you'll just have 1 label. If it's audio and media, you're going to have 2, etc., like that. So with that information, you can build the SIPREC XML that you can send to the SIPREC server. But I'm not going to show you that bit here. So then the next step is obviously you have to send the invite with the SIPREC. I'm just sending the SDP. I'm cheating. I'm not sending the XML in this example. It's lazy. And then also the other thing that you need to do is in the TM local request, you need to copy information from the dialogue of the original call into AVPs, because when you want to get the answer and stuff, you won't be seeing the original dialogue anymore when you get the response. So you have to save it into the transaction so you can get it later. And in the real world example, you would also save a lot more, because you would need to have the full route set if you want to eventually build a buy to hang up the call later. But I've simplified this document. And by the way, most of this is it's a subset cut and paste of what's in the Kamailio documentation, so you can look at it later. The exception is the XAVP stuff. That's just my explanation. So here I say, when I get the reply to this invite to the SIPREC server, I go to reply route 2. And on reply route 2, you just send RTP answer with the original from tag of the original call, the to tag that you got generated when you sent the offer, and the call ID of the original call. And there you have it. You have the call streaming to a Cypress server. So.
Yeah, thanks a lot. Yeah, that was the last one. We have tomorrow still the Kamailio Code Challenge. I think we still need a few submissions. Marcos over there, I think you still have a few flyers. Outside lying a few flyers. You have a QR code or the link to be able to participate, maybe. There are cool prizes, or hopefully cool. Yeah, thanks a lot.
Thank you, Andreas. Very interesting presentation. Thank you, Tori, for your Cypress-related extension and giving us a good introduction here. So before we wrap up the day, let's give another beer jug. So I remind to you what you can win if you participate tomorrow to this Kamailio config challenge. So let's select. I have here some guy that could choose a winner called Daniel. Okay, an empty spot, that's me. Okay, so we have Vyacheslav Oho, a proud winner. Can you unwrap it for me? Thank you. So, Kamailio engraved beer. Thank you for coming, guys. And then remember for tomorrow, we still have to give during this challenge. The SIP wise guys will have also some stuff. Then we have from Snom again. The pack already received, we gave away 2 phones, we still have like 3 or so. Then don't forget about James, dangerous demos. If you haven't enrolled, consider 3. Here's 3 prizes, okay. We'll give 1 prize from here, or maybe 1 Snom phone, we'll save it for the dangerous demos. The dinner, for those that are new here, it's where the lunch was, so the same building. We have everything compact here, so we don't lose time moving left and right around the city. Will be also some beer and wine, red and white wine. If you want something else, you will have to pay yourself, like whiskey or other spirits, to the open bar there, that's there, but like beer and wine, it's included. We'll have like full dinner, more or less, similar to the lunch in a way or another. Of course, be responsible with everything. Officially, it's like 7, so you have time to drop your bags or, refresh a bit outside. Still like 45 minutes, 40 minutes or so. But also, again, we have alcoholic drinks, but try to be responsible. If there is any issue with anyone, please report to us. I want to thank to all the speakers for today, again to all our sponsors, especially to Pascom, that the infrastructure was running smooth for everyone.